Hey guys, welcome to Intellipaat. Machine learning is one of the most significant technological development in recent times. It focuses on the development of computer programs to access the data and use it for themselves, just like humans, by collecting, storing, analyzing and developing decision-making ability on its own. But machines are not as intelligent as humans. They do not have the capabilities of performing the task on their own. And the tasks performed by them are just nothing but codes written by us, humans. In this training, you will learn extensively about machine learning. But before we start with the session, let me make it clear for you guys that to start with machine learning, you don't need to have any fancy degree or top programming skills. This session has everything which you need to learn as a beginner to get started with machine learning. Once you go through this whole video, you will be in a position to make the machine work to some extent. Now let's get started with the agenda for today's session. We will learn what machine learning is. Then we will go through different types of algorithms in machine learning like supervised algorithms, unsupervised algorithms, reinforcement learning. Then we will look into the domains in which machine learning is being used. At this point, you will be able to learn about the basics of machine learning. We will also learn some statistics and probability which is required to become a machine learning engineer. Later on, we will dive into the world of deep learning. We will start with the basics about artificial neural networks, topology of neural networks, perceptron and so on. Then we will take a look at some of the popular frameworks of deep learning which are PyTorch, TensorFlow. Once you're done with all that, there will be a project on machine learning which is implementing facial recognition program using machine learning and computer vision. At last, there will be machine learning interview questions given with detailed answers for you to clear the job interviews. We will also throw some light on how to become a successful machine learning engineer. We assure you, if you go through this complete video and practice hands-on on this video, you will have a solid foundational knowledge about machine learning and all its concepts. So now, without any further delay, let's get started.
What is machine learning? Although it's one of the most popular terms right now, not a lot of people understand what machine learning is. So machine learning basically allows you to solve complicated problems by allowing the computers to learn how to infer patterns. Basically, it allows the computers to learn how to map one sort of input to another sort of output. And this is learned by the computer in the same way that a baby learns how to associate a word with an image. So this is why it's called machine learning. So when we're using machine learning, it allows developers to use large amounts of data, really massive amounts of data, and a lot of computational power to solve these kind of problems. Now, since we do have all of these large amounts of data and large amounts of computation power, we can train machine learning models more effectively than ever before. This is why machine learning is so prevalent right now than it was before. So let's take a look at how it's different from traditional programming. So when application developers build applications, how is that different from building applications that are powered by machine learning? So in traditional programming, what we do is we take users' input, process it through the program, and process it through the program, and then map it to the output. And in machine learning, what we do is we do some opposite steps. So instead of mapping input from program to output, what we do is we take the input, we use some algorithms to understand how the input is mapping to the output, and then finally we take a look at and we get the rules that we need for the input to be mapped to the output, which is our program. So instead of explicitly programming the rules that we need to convert the input to the output, the machine will figure it out themselves. All we need to do is provide them a really good set of examples that contain inputs being mapped to outputs, or the thing that we want to predict and the data that we want to give it to.
Hey guys, quick info. If you're looking for an end-to-end machine learning training program, then do check out Intellipaat's machine learning course. Now let's continue with the session.
So now let's take a look at some of the machine learning use cases. Machine learning, as I said, is prevalent in many domains. So it's not necessarily just computing. Machine learning is now used in almost every industry, beginning with healthcare. So in healthcare, machine learning is used to do a variety of tasks, mainly to assist doctors. The doctors are still the people who are calling the shots, but these machine learning systems can take a look at the scans of the patients and take a look at their records and their blood levels and every information that's vital to the answer that is being given, and it maps it to an output, or either gives it a likelihood or the chances of a patient having a certain disease or being free of a certain disease. So that's where it comes in healthcare. Then there's automation. So machines being automated to do stuff that humans can do, but there are certain tasks that machines have been known to do better than humans. However, there are other tasks that take a bit of understanding of data. These kinds of tasks are automated using machine learning. So they use machine learning technologies to get some good set of data, and then train that data, using that data, train the machine learning model to perform the automations that need to be done. And there's security. So facial recognition systems can be one of them. They allow you to figure out how to identify if a user is a said user. Many CAPTCHA systems now also use some machine learning techniques to figure out whether a user is behaving like a bot or not, and then classify them accordingly. And finance. So things like credit card fraud detection, check fraud detection, these are the kind of things where machine learning comes into play and helps the banks and the other financing entities to figure out whether or not a customer could be potentially frauding the system or not. Now these are just a few of the things that I have mentioned. There are many industries that have been impacted by machine learning and are using machine learning directly in their daily products. So these are just one few of them. Now let's take a look at the machine learning process. How does machine learning work? So we begin by gathering data. As said, machine learning mainly works on mapping input to output, and we need really a large, massive set of data to get a good model. Now gathering the data is just the beginning of the machine learning pipeline. So what we end up doing is we first gather data from a lot of sources. These could be from institutions, we could survey, we could get data from sensors. There are a lot of places to get data nowadays, and we get the data from those sources and collect them in places where we can use them for our machine learning pipeline. Then we prepare the data. So the data that we get is not going to be 100% correct. We will get some errors, we will get data in different metrics. So we could get different formats of data, and all of that needs to be accounted for and then converted into a normalized set that could be put through a machine learning system, and outputs could be generated. Then there's the step of choosing a model. Now there are several algorithms and several models available in machine learning to be used to perform certain tasks. Having a good understanding of which model to be used when is very handy, and it allows us to pick a model that would best solve the problem that we're trying to solve. Then comes the training phase. In the training phase, we basically take a portion of the data and train our model on that data, and we do it iteratively to find the best model that we can use, and we train our model on that data so that our model can get some data and then predict some output. Then comes evaluation. This is where we test whether the model has been trained successfully and is performing the way we wish it to. So whether it's classifying the things that we want it to correctly, whether it's predicting the house prices that we want it to correctly, so on and so forth. Then comes the tuning phase. In the tuning phase, what we end up doing is we get the data, and after getting the data, we evaluated it, and we have trained the model, and we have evaluated it, and we have understood what this machine learning model is doing. Now if the model is not performing up to our expectations, we tune it. Tuning basically means that setting several hyperparameters on a machine learning model. Now this could be a bit difficult for you to understand. Don't worry, I'll guide you through some resources that can help you understand these steps more clearly at the end of the slide. And finally, it's the prediction, or as you can call it, we deploy the model in the real world, and then the data is given to the model and it produces the information that we want it to be mapped to. And this is the final step. And now this process is iterative, so if we get more data, then we go through this process again and again and again, and the model keeps getting better and better depending on the data that you get and how you're training it. Now here is a job description for a machine learning engineer. So as you can see, you need to understand how to transform the data. This correctly maps to the pipeline that we previously described. We need to understand how to design a machine learning system. You need to understand how to research and implement the algorithms. You need to understand the requirements that you are trying to satisfy, the objective of your machine learning model. Understand how to get appropriate data sets and how to figure out which one is the best for you. And then you can test it, analyze it, and then retrain it, similarly as our steps mentioned previously. Now let's take a look at the companies that are using machine learning. So one of the companies that's using machine learning is Netflix. Netflix uses machine learning for their movie recommendation system. So when you see the feature that says people who watched what you watched also watched these shows or these movies, this is where Netflix takes in the massive amounts of data that it collects from the user and trains a machine learning model and gives you the best recommendations it can. Then comes Google. Google uses machine learning extensively. So you could see Google using machine learning in their ads platform. You could see them using them in the recommendations platform, the search engine platform, and there are many other platforms that Google has created which uses machine learning. Then there's Twitter. So in Twitter, machine learning is used for many purposes. One of the most famous ones is that it's used to figure out whether a tweet is offensive or should be banned from the community or not. This is where Twitter uses machine learning. Then there's Quora. Quora uses machine learning similarly to Twitter to figure out whether something is plagiarized, something is containing something that's offensive, that's breaking the guidelines that are set by Quora. Then there's IBM. IBM uses machine learning a lot, especially in their internal tools, and also it has a machine learning platform called Watson, which it has made public so people can use it, supposedly if they are paying the appropriate price. Then there's Apple. Apple uses machine learning a lot as well, especially when you are using Siri, which is the Apple's voice assistant. That uses machine learning extensively and as well. Now let's take a look at the steps that you need to take to become a machine learning engineer. So the first thing that you need to do is you need to get comfortable with mathematics. Now mathematics is quite a scary thing, and don't worry, if you don't know any mathematics, you need to wait till the end of this presentation and I'll show you or guide you to the resources that you could use to get comfortable with mathematics and proceed to other steps in machine learning. Then you need to learn programming. You also need to get certified. Then you have to build a portfolio and then you can start applying for jobs. So when it comes to learning mathematics, the main thing that you need to understand is you need to learn linear algebra, calculus, statistics, and probability. You don't need to be an expert in all of these, but there are certain aspects of these subdomains of mathematics that are used in machine learning. So you need to understand those topics, how to use them, why are we using them, and when you can use them, and you'll be good to go. Then there's programming. So programming is essentially you use a computer to perform certain tasks. In this case, we use the computer and program it to create a machine learning model from the data that we're providing it. Now, many programming languages are available for you to use in machine learning. Most popularly, people use R and Python. R is mostly used in academic and research scenarios, while Python is mostly used in software development and using machine learning in normal day softwares. So you can use them. Now that's not necessary that you only use R and Python. There are other languages that use machine learning as well. However, Python and R have great support for machine learning and other things. So this is why these are the most famous ones. Then you need to get certified. Certification really helps in setting yourself apart from the crowd in the eyes of the recruiter. So when a recruiter looks at a resume and sees that he is certified or a person is certified, then it gives them a higher probability that this person knows what they're claiming to know and they can proceed further with that applicant. So knowing or getting a good certification is very, very helpful. Then you need to build a portfolio. You can basically use your machine learning skills that you acquired during the certification or your learning phase, and you can use it and apply it to the tasks that you see on a daily basis. This also shows the recruiter that you are very passionate about the machine learning scenario and you want to learn more about machine learning, which is always a positive sign for the recruiters. Then you get to apply for the jobs. Now when you apply for the jobs, you are certified, you have built a portfolio. These are really great indicators for recruiters, and they'll probably shortlist you if you are following these steps. So now let's take a look at the demo. So a recent survey that was conducted by the International Diabetes Federation showed that 371 million people worldwide had diabetes, and 187 million of them did not have any idea that they had that disease. So that's very difficult. So let's see what we are doing. So let's try and use some diabetes data set and build a model that will predict whether a person given some information has diabetes or not.
Hey guys, quick info. If you're looking for an end-to-end machine learning training program, then do check out Intellipaat's machine learning course. Now let's continue with the session.
So I am in Google Colab. This is an online environment created by Google. You can use it for free, and you can run Python code that you could write and understand how to use it, and then you can run it inside this Colab environment and create machine learning models online, and you can collab with other people as well. This is completely free, and it's an awesome resource. So what we're doing right now is we are using some code, and it's not necessary that you understand it right away. It's fine because you are just beginning, so you don't have to worry about understanding it completely. Just take a look at how a problem is solved using machine learning, what are the steps that are taken, and hopefully you can get away with some information with it. And don't worry if you don't understand it, stick with me till the end of the slide and I'll guide you through some resources that will help you. So after we have set up our libraries and we have installed or we have imported everything that we need through the Colab environment, now we need to upload the dataset. So we run this cell and it will show us a button that will allow us to upload a file. Okay, let's see. Okay, yeah, it shows some error. Never mind. I could just use this as well. Basically, I just need to go to files, click on upload, and then I have to download. I have to use the diabetes dataset. Okay, and as you can see, diabetes.csv is the file that we'll be using. It's 23.31 KB. It's uploaded. Now comes the step of data preparation. Now in our case, data preparation is not going to be that difficult because it's gotten from the UCI machine learning repository, so it's already prepared. It's got normalized data sets and everything, so you don't need to worry about preparing the data. But in case you were working it in a real life environment, there you would have to use some data preparation techniques and get the data into the normalized format that you can use. Now let's try and use the diabetes.csv file. So we run this, and these are the columns that are inside our data set. We have pregnancies, glucose, blood pressure, so on and so forth. The last column, outcome, is the thing that we're trying to predict. Let's take a look at some of the rows in the data set. So we have quite a few rows, but we are displaying only the first 5 ones. So this is what the data looks like, and the outcome is binary outcome. Basically it contains 0 and 1. 0 means that the person did not have diabetes, and 1 means that the person did have diabetes. And these are all the informations that we have. Now we can visualize the data. Visualizing really helps in understanding what our data looks like, what is the mean, what are the ranges that the data or different columns contain the data in. So we run the visualization. It starts, and as you can see, we have plotted histogram for all of our columns, 9 columns as you can see, and this is what it looks like. Now let's take a look at if we have null points. Null basically means that there are some data points that are unavailable. So we have just skipped them. The data was not available at that time. And if we do, then we would have to do certain things. Let's see. So is null and is NA are both the same. Null means a null is a value that is used to represent the absence of some value. And A means that the value was not present in the cell at all. It was completely blank. So we have 0 NA and 0 null values, which means that our data set is completely fine. Now we'll be taking a look at some of the outliers. Outliers basically means data that is not correct, or the data that is outside the normal bounds. So as we can see that a person with a blood pressure of 0 could not exist. So let's take a look at how many we have. So we have 19 people with blood pressure as 0, and 16 people at blood pressure as 0, and people who are predicted to have diabetes. So that's fine. Now let's take a look at the glucose level. Does a person with a glucose level 0 exist? Yes, today a total 5 people who exist. 3 of them have been predicted to not have diabetes and 2 of them have diabetes. And similarly, the skin thickness is also 0, which is also not possible, but we have 227 records for that. And let's take a look at the BMI, which stands for body mass index. And here we have 11 records with BMI as 0. So now let's take a look at insulin, where insulin is 0. And we have around 374 records. Now this is where the domain experts come in. So if you don't know whether a person can have insulin as 0 or not, or any other aspect that you do not understand, the domain experts help you out in understanding whether or not that data set should be allowed in the model or not. Depending on that, then you can remove these things. So as you can see, we'll be removing everything from our diabetes data set that contains with the blood pressure as 0, or the BMI as 0, and the glucose as 0. So if all these 3 things are 0, then we remove them and we store the cleaned result in the database _mod variable. So we run that, and it contains 724 records with 9 columns. Now comes the model selection phase. So before selecting the model, we will split our data into the input that we'll provide and the output we want it to be mapped to. So the outcome is the output, and everything else, as you can see up in the column, is the input. So we run that, it runs fine. Now comes model selection. So to do that, firstly we'll import a bunch of stuff. You may not understand what all of these things are, that's fine. You don't need to understand it right now. Just stick with me till the end of the presentation and I'll show you what it means. So firstly, we'll create a few models and store them in the models list. Now these are the models that we'll be using and evaluating our program on. We split the data set, and yeah, now we split it into training and testing set. So basically we will train the model on some data and then test it on some data that we've set aside, and we'll test whether or not it's working or what's the accuracy. Now let's train our models and take a look at the accuracies. So we have accuracies of 77.9, which is around 78% in logistic regression, and there are other algorithms that are performing these way. So these are all the accuracies that we are getting, but it's a bit difficult to understand, so we'll visualize it later. Now let's take another look at how to check the accuracy of models using the k-fold method. So k-fold method basically splits the data into 10 buckets and then randomly uses 1 bucket to validate the data and 9 buckets to train it. So it's a more comprehensive way of testing the data. So we have got the accuracy scores now. Now we can take a look at it, and it's easy to see and understand what this is, but suppose we had 15 models, that would be very difficult for us to get an idea of which is the model that's performing the best. So instead of doing that, what we do is we visualize it, and as you can see, the bar with the highest, or the bar with the highest, or the model with the highest bar is the logistic regression one. So when we're training the model, we'll be using logistic regression, and then we'll go ahead. Since we have chosen the model, now all we have to do is we need to get more data, train our model on that data, and get as much data as you possibly can, and then train your model. This could take a lot of time because crunching through the entire data set could be a little difficult. So you do that, you train the model. After training the model, you tune it if necessary, and tuning it is a bit of an advanced topic, that's why we've left it out of here, but you can learn it. I'll guide you through some of the resources that will show you how to do that. And finally, you can deploy it in any way, shape or form you want, maybe a mobile application, maybe a web service, so on and so forth, and it'll work just fine.
Hey guys, quick info. If you're looking for an end-to-end machine learning training program, then do check out Intellipaat's machine learning course. Now let's continue with the session.
Machine learning is subcategorized into supervised learning, unsupervised learning, and reinforcement learning. So let's start off with supervised learning. In supervised learning, we teach the machine using data which is labeled. Let's say we have a bunch of fruits and each fruit is tagged with a label. So here the machine learns that an apple looks like this, a mango looks like this, a banana looks like this, and an orange looks like this. So once the training is done, the machine is fed with new data or test data. So here the machine is fed with a new image of apple, and the machine predicts that there is a 97% probability that this is an apple. Now, supervised learning can again be divided into classification and regression. So classifying the input data is a very important task in machine learning. For example, whether the mail is genuine or spam, whether the transaction is fraudulent or not. And there are multiple other examples. So let's say you live in a gated housing society and your society has separate dustbins for different types of waste. So one dustbin for paper waste, one for metal waste, one for plastic waste, and so on. So now what you're basically doing over here is classifying the waste into different categories. So the classification is the process of assigning a class label to a particular item. And in this example, we are assigning the labels paper, metal, plastic, and so on to different types of waste. And one thing to note in classification algorithms is that the output variable is categorical in nature. Let's take this example to understand it better. So over here we have gender of the student and result of the student. Here, gender is the input variable or the independent variable, and result is the output variable or the dependent variable. So we see that our output variable is categorical in nature. That is, it has two categories, either pass or fail. And here we are trying to determine whether the student will pass the exam or not on the basis of the gender of the student. So there are different classification algorithms such as decision tree, random forest, naive Bayes, and support vector machine, to name a few. So let's go through the concept of decision tree briefly. Decision tree, as the name states, is a tree-based classifier in machine learning. You can consider it to be an upside down tree where each node splits into its children based on a condition. So let's take this example to understand decision tree better. Here we are building a decision tree to find out if the person is fit or not. And based on a series of test conditions, we finally arrive at the leaf nodes and classify the person to be fit or not. So the next type of supervised learning algorithm is regression. So when it comes to regression, the output variable or the dependent variable is a continuous numerical. So let's take this graph over here. Here we have horsepower on the y-axis and miles per gallon on the x-axis. Or in other words, horsepower is the dependent variable and miles per gallon is the independent variable. So we see that our output variable is a continuous numerical. And here we are trying to determine how does the horsepower of the car vary with its MPG. So this is the concept of regression. Now let's see some of the use cases of supervised learning. So first we have spam classifier. So how do you think your mail is being classified as whether it is spam or not? So this spam detection basically works on the concept of filters. So mainly there are two types of filters, text filter and client filter. The text filter works by using algorithm that detects which words and phrases are often used in the spam email. So phrases like lottery or you won or free Bitcoin are often an immediate flag for removal by filters. So next is the client filter. As the name states, client filter understands the client identity and history to block malicious and annoying spam email. So how does this client filter work? Well, this is done by looking at all the messages of a certain user which he has sent out. So if a user has sent out huge amount of emails constantly, or several of the user's messages have already been marked as spam, then in that case their email will be blocked entirely. So this brings us the use of blacklist. So spam filters also include something known as blacklist. So blacklisting is the process of adding known email addresses of a spammer to a list. And this list prevents the user's messages to be forwarded to someone else. Now let's look at the next use case, fingerprint analysis. So in fingerprint analysis, you save your fingerprint in a machine as a record. So the machine checks the data and verifies whether the data belongs to you or not. So once the data is saved into the machine, from next time whenever you put your fingerprint on the machine will scan through all of its user data. And if the machine finds a match of your fingerprint in its data, then your fingerprint will be verified. Now that we've completed the different types of supervised learning algorithms, let's go ahead and understand what is unsupervised learning. So when it comes to unsupervised learning, the input data doesn't have any labels associated with it. The machine understands the underlying structure of the data to identify similar patterns, and the data which is similar in nature is grouped together. So here, even though there are no labels, the machine understands that all the apples are similar in nature and thus they are grouped together. And same is the case with bananas and oranges. So this is the concept of unsupervised learning. Now let's go through an unsupervised machine learning algorithm called as k-means. So the aim of k-means is to group similar data points into a single cluster. So there must be high intra-cluster similarity and low inter-cluster similarity. That is, all the data points within a cluster should be as similar as possible, and all the data points between two different clusters should be as dissimilar as possible. Or in other words, all the points inside cluster A should be very similar to each other. But when we compare a point from cluster B with a point from cluster C, then they would be very dissimilar to each other. And in k-means clustering, k denotes the number of clusters to be formed. So in this picture over here, the value of k is 3 and hence 3 clusters are formed. Now let's go through a use case of unsupervised learning. So Netflix recommendation is a perfect use case of unsupervised learning. So more than 80% of the TV shows that you watch on Netflix are discovered through the platform's recommendation system. It means the majority of what you watch on Netflix is the result of decisions made by a mysterious black box of an algorithm. So let me just give you a brief of how it works. Well, Netflix uses machine learning algorithm to recommend you a list of movies and shows that you might not have initially chosen. To do this, it looks through a thread within the content rather than relying on broad genres to make a prediction. This explains how 1 in 8 people who watch Marvel shows are completely new to comic book based stuff on Netflix. And finally, there's reinforcement learning. So in reinforcement learning, the algorithm learns through a system of rewards and punishment. And the goal here is to maximize the total reward. Let's take this example to understand reinforcement learning. So here we have a self-driving car which is supposed to reach its destination without hitting any barricades. So here, the self-driving car is the agent and the road is the environment. Here the car takes an action and goes straight. But when it goes straight, it directly hits the barricade. Now since the car has taken a wrong action, it will be punished. So the car realizes that going straight is wrong and it has to go right. So when it goes right, it will be given a reward. So this process continues and the car learns how to drive by itself without hitting any barricades. So the obvious application of reinforcement learning is a self-driving car. A recent study has shown that over 90% of road accidents are caused by human error. So to err is human, but behind the wheel, mistakes are often more catastrophic. Accidents have led to a massive amount of unnecessary deaths. So this is where self-driving cars come into the picture. So trust me, the autonomous car or the self-driving car is much safer than a human-driven car. They are unaffected by factors like human fatigue or illness, and this makes them very safe. And self-driving cars are always attentive, observing their environment and scanning multiple directions. It would be difficult to make a move that the car is not anticipating. So how does a self-driving car work? Well, self-driving cars mainly rely on 3 technologies: IoT sensors, IoT connectivity, and software algorithm. There are many types of sensors available for a self-driving car. For example, sensors for blind spot monitoring, forward collision warning, radar, and so on. So all of these IoT sensors work together to help in navigation of the self-driving car. Next is the IoT connectivity. Self-driving cars use cloud computing to act upon traffic data, weather, maps, adjacent cars, and so on. This helps the car to monitor its surroundings better and make informed decisions. And next is the software algorithm. All the data which the car collects needs to be analyzed to determine the best course of action. And this is the main function or the control algorithm. And this is where reinforcement learning comes into the picture. This is the most complex part of the self-driving cars since it has to make decisions flawlessly. So in today's world, the most famous self-driving cars are those from Tesla and Google. So Tesla cars work by analyzing their environment by using a software system known as autopilot. So autopilot uses high-tech cameras to view and collect data from their environment. So it's the same as what we do with our eyes. And autopilot uses this data to make decisions during navigation. Now let's quickly head on to the quiz. So this is our first question over here. Amazon product recommendation uses which of the following machine learning techniques? Supervised learning, unsupervised learning, or reinforcement learning? So guys, what do you think is the answer? So whatever you think is right, do put down in the comment box.
We are going to introduce some basics of statistics, as well as introducing you all to these statistics before we start any probability, anything on probabilities. First, when I say statistics, what exactly triggers in everybody's mind? So you might have seen your daily newspapers where people talk about how much pollution is there in northern central part of India, like Delhi, and what is the percentage of carbon content in that. And also you see that how many people, and also coming to the sports, you might have seen that how IPL is going on nowadays, and how many runs that particular batter is doing. So all these numbers, okay, actually shown that who is performing better. Or if I take an example of one batsman, how his record has been from past several years, how many runs he made, what is the average he made, and what is the best he made, I mean to the maximum runs he made. So all these things, actually all these measures generally describe the data or the performance of that particular batsman, or anything, the situation or the scenario that you are expressing in the form of data. From that data you are actually trying to tell some numbers out of it. Let us look at this example. An university is actually trying to show that who are the people who are graduating into chemical engineering, and there are many graduate engineering graduates are there, out of which how many of them are chemical engineers in 1998 and in 1988. So if you look at this one, from within 10 years, 1988 to 1998, what is the ratio of these chemical engineering graduates are changing? For example, here in 1988, if there are total graduates are 140, out of which 120 of them are chemical engineering graduates. Now in 1998, there are, let us say, 130 engineering graduates, out of which only 90 of them are chemical engineering graduates. So now what this chart will give you, what is this actually talking about? This is actually talking about the data of engineering graduates, out of which how many of them are chemical engineering graduates. So you are representing the complete data in the form of simple charts or simple measures. Here it is just in a number. Okay, based on that you are actually describing the data. Let us talk about this figure 2. Here, what exactly this is representing? It is representing that you are having some stock price of Facebook, alright, and how it is varying from 2009 to 2018. And since we are in the year of 2016, it is projecting that is the projected stock price, okay, projecting the stock price in 2017 and 2018. So for example, if a person is at this time instant, let us say 2013, he has the history of the data 2009 until 2013, and he is projecting this data, means projecting the sales or the stock prices, okay, in the future years. So I'm not going to talk about how Facebook is performing and all these things, but this is an example I'm just taking to explain you that what anybody expects out of the data in the simple charts to describe about statistics of the data. So in this session I'm going to talk about more about descriptive statistics. Okay, descriptive statistics is the term given to the analysis of data that helps to describe or to summarize, okay, in a meaningful way. For example, if I'm giving you this particular sheet of data, Excel sheet of data, and I would ask you that what exactly this data is representing. Okay, so for an analyst, okay, who is going to sit down and looking at this data, he will first try to understand what is this data all about, and when he is going to communicate, he would actually start analyzing this data in this way. For example, if I'm looking at population projection of Delhi, okay, so this is a year, okay, and these are the, as of 1st March, okay, these are the males, these are the females, and urban, rural, as in 1st July, similarly the values. So as in 1st October, this is the value. If somebody comes and asks you about this data, forget about statistics. If somebody comes and asks you about the data, the first and very important very important way to describe this data is, hey, this data is talking about the number of males, females, okay, in urban and rural areas. They have recorded in 1st March of every year starting from 2002 to 2026, okay. Since we are in the year of 2016, these are all the projected values, okay. That is what the population projection of Delhi. So we are actually trying to predict what could be the population in Delhi. I don't know how they have predicting and everything, but this is the data I got it from the survey department. Now I will have to give some kind of summary of this data. So whenever you are trying to give the summary of this data, then you have to then the particular field is called descriptive statistics. Okay, as I mentioned earlier, descriptive statistics is the term given to the analysis of the data. So you are going to do the analysis of the data, and here you are not going to do any projections or any predictions, any estimations. No, you are just, you got the data, you are actually giving the summary of the data. So now it is very important because you are going to take the raw data. This is called raw data. What I mean by raw data is that which is in the very basic form. No analysis has been done. No pre-processing has been done. What I mean by pre-processing, most of the data that we get out of all these surveys or any kind of experiments, the data will contain a lot of unnecessary information that is called noise. So when we have this noise, okay, so before we conduct any analysis, we try to remove that noise. But here the question comes, how do I discover that noise? That I'm going to cover in the later sections. But to explain you that what is raw data is the data that you are getting in the very basic format on which you are going to perform some analysis, okay, and to describe the complete data in a very descriptive format. Is that clear? So now, in simple sentence, if anybody asks us what is descriptive statistics, which means that descriptive statistics enables us to present the data in a more meaningful way. Okay, in the simple way, I can say it is a simple interpretation of the data. All right. So simple interpretation, just now the way we have done here, this data is actually explaining about the population data, population projection of Delhi from 2002 to 2016-26. Okay, and on March 1st, 1st July and October. Okay. So now similarly, yes, if I talk about this particular table, okay, can somebody interpret this data by yourself? Please look at this table and try to see that what exactly can you interpret here. Yes, if we interpret this data, okay, this data is talking about near about 22 languages, okay, and people who are who are actually talking. Of course, the table title itself is showing, but let us only from the data itself, let us interpret this data. And okay, in 2001 and 1991, how many people are speaking Assamese in 1991 and in 2001? Okay, male, female, and the percentage it is showing, right? So now this is simple what the data is. Now I'm going to ask you that what is the percentage of the people who are speaking Hindi, okay, and those are males? Another question, how many people who are speaking Manipur, okay, who are females in 2001? And I also asked the questions that from 1991 to 2001, what is the percentage growth of people who are speaking Bengali in Delhi? Are you getting my questions? So all these questions can be answered from this data only. But in order to answer all these questions, first of all, we have to do a very simple operations on the data, which means that simple measures that we have to find out. For example, if I'm taking an example of Sachin Tendulkar, I would say Sachin Tendulkar is a very good batsman. He is maintaining a very good average. What do you mean by average? The average is a simple measure that is completely describing his performance from the past 10 to 15 years. Similarly, if I say that one particular what is that simple measure that I can get out of this data to explain, to interpret this data in a more meaningful way? That is what we are actually talking about, the descriptive statistics here, right? So the questions that I have asked, can anybody able to answer those? For example, what is the percentage of growth of the people who are speaking in Bengali from 1991 to 2001? Those are especially females. If I am asking this question, then I will go to 1991 female, and in 1991 female who are speaking Bengali, and 2001 who are speaking Bengali. Then what is the percentage of growth? So the percentage of growth is nothing but the difference between these by the original. So that is one measure. Percentage of growth is one measure that gives you the complete understanding of the people who are speaking Bengali. But from this data, there can be many questions can come out of it. So let us represent all of them in a simple form, so that that particular form, it may be a visualization graph, a plot that can provide you the complete set of information. This slide is mainly talking about collecting the data, understanding the data, finding the useful information in the data, interpreting the data, and visualizing the data. So somebody has collected this data, okay, and we are trying to understand this data. And after understanding the data, we are trying to find out what is that useful information that is needed. So useful information means those are patterns in the data. There can be many patterns. You can retrieve many information out of it. I mean, it's many information points out of it. But from the business point of view, if a person asks a question from the business question, how do you really interpret it, find out that pattern? The pattern may be, I wanted to know the people who are, okay, this is the question perhaps I can ask you. I wanted to know how many people are there from South India. Okay, so South India, here in this data, South India is not well defined, but that is the question I'm asking you. So you know some of the South Indian places and you know some of the South Indian languages, so you filter out those languages, okay, and then for example Tamil, Telugu, okay, and any other languages here you can see Malayalam, okay. So for example, some of these South Indian languages, I filter them out. After filter them out, I will call all these Telugu, Tamil, Malayalam or any other language into one particular bucket, and I would say that yes, these are all South Indian languages. How many of them are there? I filter out their information. So how do I represent that one in this very simple form? Okay, that means, see, it's not a pattern, but it's a kind of information that I'm trying to get out of this data based on the business question that was asked, right? So based on that business question, I found that information, and then I'm interpreting the data. Interpreting means I'm doing some operations on the data, and then show it in the same visualization format, maybe bar charts or simple any other charts. All right. So here, what I wanted to emphasize is that whenever you get this data that is in the raw data form, and you try to get all this raw data form into a very simple descriptive statistics form, or a simple measure like average or a percentage of growth or a maximum, minimum. So these are all some terms that generally people use to communicate or to interpret the data. Okay, so what is statistics? Okay, as I mentioned, that is an example here. Descriptive statistics means it's a collection, presentation and description of sample data. So descriptive statistics are used by the researchers to report on population and samples. Just now, that's what we have seen. And in sociology, right, and it is a kind of a tool that we use to comprehend the complete raw data in a more meaningful format. Okay, that is descriptive statistics. So you got the data and you're explaining about the data. Very simple. Okay, so what is inferential statistics? Inferential statistics are those from that data you make decisions or you draw some kind of conclusions out of the data. For example, I'm going to the same data here. Okay, I was talking about number of people, maximum number of people, percentage of growth and all these things. Now suppose if I want to take a decision that as the population is increasing, right, that first of all, yes, whether the population is increasing, yes, it is increasing. That is how do you know that population is increasing? That we can find out from the descriptive statistics using the univariate profiling. I will show you what is univariate profiling, bivariate profiling, okay, in the later parts of the course. But just for now, to understand that whether this male is number of males is increasing and females are increasing. Now the question I wanted to ask here is that I wanted to I wanted to see, suppose I want to take a decision that that is more relevant to female population. Okay, so now I'm going to take a decision. All right, first let me answer this question. Male is increasing the most or the female? Is it in urban or in rural? If it is in urban, what is the projected growth rate? If it is rural, what is the projection growth rate? So the questions that I'm asking, okay, those are all some kind of, I want to draw out some conclusions out of this data. I want to take some decisions out of this data. Should I focus more on the urban? Should I focus more on the rural? Okay, so the descriptive statistics just give you the information about the data, but inferential statistics is the one that helps you to infer something from the other. I want to infer that, okay, I will put it like this. So for example, in the rural area, okay, in the rural area, this is the population that is increasing. Okay, and this is the population of female, those are increasing. Okay, now I wanted to ask this question, as the female population is increasing, is it increasing at the faster growth than the male growth? I'm repeating my question again. The female growth rate, okay, I mean to say the projection, what it may be, is increasing much faster than this? Yes, I will answer that. Okay, in order to do that one, first we have to see the velocity of the population growth rate in each year. What I mean by velocity is nothing but the number of population. For example, from 2016 it is 11,827, okay, and 2015 of the same time, okay, I'm calculating the velocity in 1 year. 11,827, okay, minus 11,481 by 1 year, nothing but the difference. Okay, how much it is changing here, how much it is changing within the same year. 9,458 minus 9195. You can do simple math by yourself, okay, on a simple paper, and see that which one is increasing in 1 year. Now, if I ask the same question for the complete like this 2002 to 2026, you actually find out the difference between this and this and the number of years. Similarly here, okay, so then you can easily answer that which one is actually growing at a faster rate. All right, so these are all some kind of, just I'm actually giving you some examples here, but what we are trying to achieve here is that to introduce all of you that from the data, okay, once you get the data that is in the raw data form, fortunately this data is very clean. What I mean by is that there are no missing values, okay, which has a very clean numbers, so we can draw we can actually describe about this data in the more descriptive form, okay. And if I want to draw out any conclusions or any kind of decisions, then I generally do some analysis that is called inferential statistics. That is what these are the two different segments, I would say two different segments that describes about statistics. Is that clear?
Hey guys, quick info. If you're looking for an end-to-end machine learning training program, then do check out Intellipaat's machine learning course. Now, let's continue with the session.
Now, for example, from the industry standpoint of view, generally you might see different kinds of yeah, every day you see these e-commerce sites, right? There you will find out different types of products and everything. But from the business point of view, let us say you are hired by one big e-commerce site where you are going to give some kind of suggestions to the management to take decisions, okay, in terms of revenue growth. Let us take this particular example, okay. Look at this particular page and there are 4 products, okay. Samsung Galaxy S3 Neo, that is blue and white, and there is Core 2 Samsung. So there are different products, and now everybody looks at these prices, EMI and the specifications of these. So now the question here is that tomorrow, given the market changes, dynamics of the market, and as well as what I mean by competitors and the product values, so how do I design, how do I come up with the optimal price, okay? How did they come up with the 7,180 instead of 7,200? How did they come up with this number? Why did they come up 12,480? So how do you decide, okay, the optimal price of these products, okay, so that your sales will be maximized? So I had shown an example of an e-commerce site where we wanted to decide the optimal price of these 4 products. Those are shown here. Defining the optimal price is one of the business problems. Similarly, there can be many business problems like how do we maximize the revenue, or how do we increase the, of course, maximize the revenue through sales only, And in order to maximize the sales, there are many ways. One is optimal. How do we decide the optimal price, or which products are more interest to the users, and what are the features that customers are looking for. So there are many dimensions that we have to consider in to maximize the sales. For any business problem, whether it is maximizing the sales or for deciding the or understanding the customer intentions, what I mean by intentions, customer intentions, or what exactly he is looking for in my e-commerce site. So for any business problem, we have to start collecting the data. So how do we collect this data? So do we collect this data from Monday to Friday, or during the weekends, or for continuous periods of months? So what is the time frame that we are actually looking for collecting this data? That is very, very important. Perhaps I wanted to look at this data as per the quarter level. In the first quarter, what are my sales? In the second quarter, what are my sales? So whether my sales have been improving or not. So these are some kinds of data points that I'm actually looking for. So now, if you take these 4 products, and before I start analyzing or taking any decision, I would like to take the help of descriptive statistics to understand the data. Let us take a very simple example here. In this example, I am showing product 1 sales, product 2 sales, 3 and 4 in different months, starting from January 2015 to May 2015. So looking at this data, what can we really infer? Okay, before we infer anything from this data, let us get the summary of the data. Okay, so what is the summary of the data? If you look at this one with a naked eye, I can say that all right, there are very good number of sales in February. Here product 2 also there is good number of sales in February, whereas in product 3 there is in March there is a good number of sales, and in product 4 in February. So not only like that, okay, so we have to use some kind of measure that we have to use before we summarize the data. Let us take an Excel example. Okay, so these are the 4 products that I'm talking about and their sales. So when you want to summarize this data in Excel, okay, because everybody is having a good exposure to Excel, so that's why I'm taking the example of Excel here. So if I want to see, if I want to get the summary of this data, so I will prepare another table for each of these product, okay, within this time period, that is having these are the measures. What are those? Which is, what is the minimum number of sales happen? 220. This one. What is the maximum number of sales? 542. What is the sum of the total sales? Okay, which is nothing but in this given time period of this data that I collected for these products. For these products, out of these products, for the product 1, the total sales are happened is 1753. Okay, and also mean. What is mean? Mean is nothing but it is the average of the sales those are happened. Average is the sum of all the sales from January to May and divided by the number of months. Okay, since I am looking at the data at the months, then it is the sum of these product sales by the number of months. Okay, that is nothing but 1753 by total 5, which is 350.6. So the average number of sales happened is 350.6. And what is the median? Median you calculate, okay, you just keep all these values in the increasing order. What I mean by increasing order, which is starting from 220, 224, 311, 456 and 542. This is what the increasing order. Okay, just for your information, I'll write on here 220, 224, 311, 456 and 542. So when you calculate the median, okay, you have to just start moving from left 1 point as well as right 1 point. Okay, again left 1 point and right 1 point. So which is nothing but the center of the all these arranged ordered numbers. So which is nothing but this is the median. Okay, so here what we have to keep in mind is that when I'm going to discuss about the distributions, okay, whenever you want to see the profile, what I mean by profile is that any variable, okay, I'm going to explain about variables as well very soon. Any variable that is going to, I mean to say here the variable is sales of the product 1. Okay, for example, any variable, let us say this is the variable. In that variable that will have mean and median. Okay, so that, okay, first I want to describe about the profile. Profile is nothing but any variable that will have certain characteristics, okay, that can be represented in the form of min, max, sum, mean, median and standard deviation. This is called profile. If somebody comes and asks me, hey, what is the profile of the sales of product 1? Then I would say, hey, the profile is, it has a minimum number of sales of 220 and maximum number of sales of 542. The total number of sales of that product from January to May 1753, and the average sales happen to be 350.6, and the median is around coming out to be 311. So whenever I say the profile means, immediately it should trigger in our mind that this will have all these values. All right, so if somebody comes to you and asks you, hey, can you perform some profiling on this data, which means that they are expecting all these different values to understand what is happening in that particular variable. Now I just mentioned that please keep in mind this mean and median are very important characteristics of any profile, which means that the distribution I'm going to talk about of any variable can be easily characterized by these two values, and also these two values help us in identifying whether the distribution is the required distribution or are there any skewness in the distribution. So anyways, so keep in mind that these are very two important parameters of any profile. So now here I am talking about the similar way for the product 2 and product 3, product 4. So this is the complete summary of the data that I am presenting it here. All right. So now, is this summary sufficient for you? Is this summary sufficient for you? No, this is not sufficient. There are some more other characteristics that I am going to introduce that would be helpful for us to characterize the data. Let us take an example. Okay, let us say this is an example which is actually talking about how do you compare the two distributions of, okay, two distribution. Before I use the word distribution, I just use very simple English. There are software, there are salaries of two companies in San Francisco and New York of different designations like junior software engineer, senior software engineer, project lead, manager and senior manager. So these are the salaries of two different companies. Okay, one is in San Francisco, another is in New York. Now if somebody comes to you and asks you, hey, can you just profile this data? When you profile this data, okay, means the salaries of these people, what do we want? Okay, the first one is, what is the minimum salary of the company that is located in San Francisco, which is 5,000, and what is the maximum salary, which is 55,000. And it is good that it is already in the ordered one right here. The salaries, as the designation is increasing, it's quite obvious that salary would also increase. So now here I wanted to know what is the mean of the salary. So here I have just populated my summary. When I actually summarize this data, the minimum of both the companies is coming out to be the same, maximum is same, mean is same, and median is same. But if you and I observe this data, of this very small data with the naked eye, we can see that the senior software engineer of a person of this company in San Francisco is higher than in New York for the same designation. Here in the project lead, New York organization is paying more than San Francisco. But when you summarize the data is coming out to be same. I mean to say that summary is looking same, right? The min, max, mean, median are also looking same. But this is not the actual case here. There is some variation among this data that is called the variability, or we can say that dispersion. So I'm going to describe about dispersion here. Dispersion describes the variability of the data. So we need few more measures to actually evaluate the characteristics of the profile. The first one is the range. Range is maximum minus minimum. Oh, here also the max and min, the range is coming out to be same because the max and min are same for both the companies, right? Then let us go to the other one, which is mean absolute deviation. Mean absolute deviation, which is nothing but, suppose you are having 5,000, this junior software engineer who is earning 5,000, how far is he from the mean value? The mean value is 30,000 here, right? The mean value is 30,000. And how much this person is varying from the mean, and which is the absolute value, that is the mean absolute deviation. Mean how much this particular junior software engineer from San Francisco is deviated from the mean, which is an absolute value, right? So which is nothing but 30,000, so 5,000 minus 30,000. Okay, similarly software engineer of this San Francisco. So I calculated for all of them, and when I sum all these values, the mean absolute deviation is coming out to be 15,000 here, whereas for New York it is coming out to be 25,000. So which means what exactly this is actually giving me the information? This information gives me that the company in San Francisco, the people who are earning money are very close to the mean than the people who are in New York, right? So these people are, let us say these people are 5,000, three of them are, three designations are complete, are 25,000 distance away from the mean, right? And these people are again 25,000 points, I mean the salary points away from the mean, right? So the mean absolute deviation is nothing but the sum of all the mean absolute deviations, okay, which represents this one. So here we found this particular MAD, mean absolute deviation, is helping us to find out the variability across the two profiles. Am I right or not? Neither the mean nor max or any other mean, median, range was not actually giving us the variability in the data, but mean absolute deviation is giving us. Okay, now we are going to the variance. variance here, okay, which is the same difference but square of that, and we calculate the variance as the sum of all these values, which is the variance. Similarly for the New York, and then once we calculate the variance, we can calculate the standard deviation. How? Standard deviation is equal to square root of variance, right? So which is here in this case the standard deviation is 17,078 and 25,000 for the New York based organization. So this value is giving some information. What is that information it is giving? Which gives how much these salaries are varying from the mean, okay, how much it is deviated from the mean, okay. So this is second measure, I mean to say third measure, range, which is coming out to be same. Mean absolute deviation, yes, it is giving good value, good information, as well as variance. Now let us see what is coefficient of variation. What do you mean by coefficient of variation? The variation, that is, which is nothing but the variance that we calculated, okay, and then standard deviation we calculated, okay, and the mean. The coefficient of variation is nothing but the standard deviation by mean, how much it is deviating divided by the mean value. So the coefficient of variation, so it is coming out to be 57%, whereas here 83%. So if you look at these three measures like mean absolute deviation, variance and coefficient of variation, these are all actually capturing almost on the same kind of information but in a different units. What I mean to say is that mean absolute deviation gives us the information that most of the salaries are not away from the mean, and here the coefficient of variation, which is also giving the information that there is not much variation in the data when compared to the people who are in New York. Alright, so there are cases where whenever you are summarizing the data, you are getting the same kind of values but data is not capturing that, okay. I mean to say the data properties are different. So now these are some of the measures that will help us in identifying the different properties of the data. Now I will explain these skewness with the graphical plots as well. In fact, I would explain all these concepts with the plots as well, but this is an example trying to show you that whenever you get the data, what are the different characteristics that I should consider to describe the data. So coefficient of skewness, yes, coefficient of skewness is actually, this is the, I'm straightforward giving you the formula here, which is the mean minus median by standard deviation. Whenever mean is equal to median, the coefficient of skewness will become 0, and whenever there is that, whenever the coefficient of skewness is 0, then you should be very happy that the distribution is not skewed. Skewness is a property of the data that is centered towards, that is centered means that is actually not for, that is the mean and median are not equal, where it is moving towards either left or right side, which means the distribution is skewed. Skewed means it is actually not following the very good distribution. We have worked out on very small data as an example, where we were trying to compare the salaries of two people coming from San Francisco, New York. Why can't we do the same thing for a very not very big for a data set that is reasonably better. Okay, so I'm not talking about any very big data table. Let us talk about a small data table that is having total 100 customers who had come to my website and had purchased different products and their gender, what kind of product they had, what color of the product. Here I have taken Samsung Galaxy of 3 different phones, okay, and their color, the characteristics of the product like memory size, price, and what is the EMI value that it is actually showing there in that website, and number of sellers. Okay, so it is also the feature of the product who are all selling, and RAM size, whether it is having dual SIM or not, and what is the resolution of the camera. So now similar data set, assume that you have collected for your experimental study data, okay, from the experimental study data, and you want to get some summary of the data. At any point, okay, whenever you are going to handle with the data, it is always better to first get this summary of data irrespective of whatever may be the data. Okay, so now let us say now I want to apply the I want to just summarize this data by using the descriptive statistics. So there, if I am actually going to do that, the first thing, summary of the data, I would say that number of rows is 100, okay, and number of columns, how many columns do I have? 11. Now I want to calculate the mean, max, mean, median, standard deviation, and number of unique values. So here I just want to explain you one more concept, that is the type of variables, because if you are actually looking for minimum for anything, something like for the gender, so is it possible to find out the minimum? No. So you can find out the minimum value, maximum value, or mean value for only continuous variables. Right? Continuous variable means those are numerical variables, and those have some value. Okay, there can be situations that the values will be numerical but may not having some value. So in order to explain this particular, before I go and summarize this data, it is very important for us to understand what are the various types of variables that we generally encounter in our data. Okay, so you might say that, hey, by looking at this one, I can see the numbers and the strings. These are the only two types. But from the statistics point of view, it is better to understand various types of these variables. So now let us look at these basic definitions. So population, okay, these are the basic definitions. I will explain this population, sample, and everything. Okay, population is the group from which data need to be collected. Let us say a large population of software engineers in Bangalore, which is one of the examples. Okay, and out of which you are selecting some 100 people for your study. For example, whether they know any particular computer programming language like Java or Python or any other .NET. So you want to see that how many people know a particular computer language, programming language. So you may not go to each and every software engineer in Bangalore. Okay, so you take some sample there. I want to explain what is variable. A variable is a feature characteristic of any member of your population differing in quantity and quality. Okay, please remember this, quantity and quality. Based on this quantity and quality, we are defining the quantitative variable and qualitative variable. Quantitative variable is the variable that is actually differing in quantity. Okay, and qualitative variable is that is differing in the type of quality. For example, you may have, okay, for the product I am having color. It is a qualitative variable, okay, which is not having any quantity, means any number associated with this. No. Okay, and similarly, if I'm talking about the stock price is going high, okay, the stock price is going at low, so there I'm actually talking the qualitative nature of the particular variable, right? So these are the first quantity and qualitative variables. And then discrete variables. Discrete variables are those variables those will not have any floating values. Okay, these are called, in programming language we call them as integers, right? So int, generally whenever we write any program we say int. Okay, so what are the examples of the discrete variables? So how many number of licenses you have, how many number of insurances you have, how many products, how many number of products, number of cars, number of visits. So you cannot say that I visited this shop for 2.5 times. You always say that I visited this shop for 2 times or 3 times. Okay, so such kind of variable is called discrete variable. And then continuous variable is the one which is again quantitative variable that has some floating values, like this product value is $233.35, or this particular one costs $2.57, so which has some floating value. So whenever we get the data, so it is always better to develop a hierarchy of the data. Okay, a variable type hierarchy, it is better to have this one that will give you a very clear picture of what kind of variables I have. So out of these variables, what kind of descriptive statistics methods that I can apply on them. For example, if I'm telling you, if I'm showing you the data of a product which is having different colors, then I might ask you a question, which color is coming out to be the most, which color of this product is having the least. I don't ask you that what is the minimum value of this color, right? So similarly, whether the product is having a camera or not, I'm saying that yes or no. I'm not there. Can you find out the mean value of that one? No, right? So mean, median, all these things can apply to only quantitative variables, right? So that's what, whenever you perform any arithmetic operations on them, then we can call them as quantitative variables. Okay, whenever no arithmetic operations are not possible, when no two are possible, that means you cannot do any arithmetic operations, then it is called qualitative variable. All right, so again, in this quantitative variable we have two types of variables. One is the discrete variable, another is the continuous variable. Similarly, in the qualitative variable, okay, again you have two branches. One branch is that, okay, nominal variables. Nominal variables are those variables whenever I say male or female of any gender variable that has the values like male, female, then there is no grading, there is no grading or there is no ordering on these variables. Okay, whereas I say that, hey, my son got A grade in mathematics, B grade in physics, C grade in natural science. So when I say these grades, you are actually finding the relationships among these grades. Okay, like something like A grade is always greater or B grade is less than A grade, some kind of relationships that you are maintaining. For example, the same example, like whenever I say that my stock price, this particular company stock price is going very low, medium and high. So if I use these values to any variable, though it is qualitative, but we are actually maintaining the grades among the variables. All right, so here male, female, female, male, female, there is no grade here. New York, Texas, or if I say Chicago, Seattle, so there is no such kind of grading is there, correct? So this is about the qualitative variable. And also, suppose in the ordinal variables there are chances of coming some numerical values. For example, this particular the customer who visited my site gave 5 stars. Okay, 5 stars grade. He provided a review, I mean to say. So 4 stars, 3 stars. So though it is a quantitative number, but it is still talking about the qualitative nature of it, right? 5, 4, 3, 2, 1 star ratings are still coming in under the ordinal variables. Okay, so which means that you cannot add you cannot add 5 plus 4 here. You don't need to add. That shows that what is the nature of the or the kind of grading that it has been provided by the customer. All right, so my point here is that whenever you get the data, on this data first build this hierarchy. This is the first and fundamental rule that you should follow, and that gives you very clear picture that what are my variables that I am having. If there are 300 variables, do that. Okay, just put all your qualitative variables here and nominal variables just put down here, put down at the bottom, discrete variables, continuous variables. Then on these continuous variables, whatever we discussed in the previous session like mean, median, all these things can perform in a similar way here also, but on these quantitative variables only you can do the mean, median and all these things. Then you may ask the question that what will we do on these type of variables? On these type of variables we can perform only least, highest, how many number of females are there, okay, how many number of unique values the particular value has. Gender will have number of unique values will be male and female too, okay, whereas in continuous number of unique values can be very high. If I start taking 2.1, 2.5, 3, 3, 7.5, so it is a continuous value, it's a curve, it's continuous curve, but here it is a kind of only unique values that you will have, that means the points you have. Okay, so now if we go back to our data and look at the data, and now if I'm start doing my data summary on this one, what I will do first, I will take the number of rows, number of columns. Customer names is my first variable, right? Customer names. So customer names, can I get min, max or anything? First of all, why can't we build this hierarchy? Okay, I'm leaving this one as an assignment to all of you. Okay, as an assignment to all of you. I'm having name, color, memory size, dimensions, price, EMI value, number of sellers, type of screen, RAM size, dual SIM or not, resolution of the camera. So can you build a type of variable hierarchy? Okay, why don't you try yourself? That is a good exercise for you to really think through the type of variables. Okay, for now I'm going to show you the data summary here, and also this is also I'm leaving it to you for your assignment because I had already explained this example, right? So do this one, but I just want to give you some kind of directions. Okay, customer names, gender is male, female, I cannot find out min, max. Then for this variable, and names of the products, this variable and this variable, these are all non-numeric, I cannot perform any kind of, I know this is an assignment. Okay, before you follow this session, better you work out yourself and then see whether you are matching to this discussion in terms of variable hierarchy. Okay, so now memory size, it seems to me that these are all some numerical variables. Okay, I'm just trying to make it as a numerical variables. Okay, and here dual SIM, yes or no, it is just like a nominal variable, non-numerical. Okay, I will put it like that. non-numerical. Okay, and resolution of the camera, again this is a numerical variable, right? So in on these things, okay, memory size, what is the minimum memory size, what is the maximum memory size, what is the mean memory size, what is the median, what is the standard deviation, so I can find out all these things, right? Similarly, if from this distribution also see that what is the mean absolute deviation, I want you to do this one as your assignment, okay? On this data, I want you to do this one and find out what is the dispersion in the data and see that whether you can really communicate these values in simple English to any of your seniors or your colleagues or to anybody, okay? But what I'm going to focus right now in the next session is how do we visualize these summary in terms of plots, okay? In terms of plots would give you more visualization, more information. Obviously visualization will give you more easy description than something like all these numbers and everything. But it is the first good practice if you can really find out all these values, coefficient of skewness, coefficient of variation, variance, and mean absolute deviation for this data that I'm having. Not only for this data, any of the data that you may have, okay, first do these operations and keep that with you as a reference throughout your statistical studies. This is also called a data dictionary. Okay, data dictionary means when instead of going and looking at the each and every data, if you go to this particular data summary, I will also call it data dictionary, you will have the complete information of the data variables, their distributions, means how they are actually mean, median, max, or varying. In fact, we are going to introduce the percentiles and everything, okay? How they are actually varying, whether there is a skewness in the distribution. Skewness is nothing but how the mean and median are varying. So that is completely, that complete information is available in this particular data dictionary. So what are the applications of this data? Where exactly this data dictionary will be useful? If you have this data dictionary in hand, so in the future when you are going to build a machine learning model, or you are going to infer some kind of rules out of it, or you are going to take decisions, in those places these values would help you to see that whether your decision that you are actually taking is valid or not. So such kind of information would be available from this data dictionary. So I'm leaving this assignment to all of you, okay, just to follow the same thing on this data. I'm going to ask this question, what is probability? Okay, so this is very common question that people generally ask. Okay, who is more interested in visiting my shop? What will be my inventory cost for the next festival, Diwali season? I'm going to put a lot of products so that people can buy them. So what will be my inventory cost? Can you go and tell them that okay, your inventory cost will be $20,000? No, you cannot come up with a very certain answers. And who is more interested? Here also it is very difficult to capture the customer behaviors, and you cannot really give such kind of very certain answer. Okay, and also what will be the airfare during the summer season? Okay, there are 8 mistakes in a page. How many mistakes you find in 200 pages book? Given the market conditions, what will be the share price of Facebook tomorrow? How many number of cars are having airbags on a given national highway during the weekend? So these are all questions that people may not have very certain answers. Okay, certainty here is that you will have a very high confidence in your answers. Okay, if if you are having such a high certainty, then you can say that your probability, your confidence is very high, and the probability is almost close to 1. So if I look at any time, whenever we talk about probability, if I say that it is nothing but, okay, it is nothing but just it is nothing but the gradation from 0 to 1. 0 is that impossible event. Okay, impossible events are those events that will never happen. For example, I don't have any impossible events at this point of time, but yeah, any impossible events, something like okay, Obama becoming the president of India, that is an impossible event for me. Okay, so those are impossible events, and slowly you will actually talk about unlikely. Okay, please remember these words. Whenever people say that likely means very close to 1, unlikely means not very impossible, but yeah, chances are very less, like that. Okay, even chance means which is the 50% probability. Okay, if any of your friend asks you, okay, are you coming to the party tomorrow, you say that yeah, it is 50-50, because there are many kind of constraints you have in your mind, that you may have to go and attend some conference, you may have to meet your other friends, so you don't know. So since you don't know, you will actually give that okay, it is a kind of 50-50. So whenever any kind of event is going to happen, so you should be able to term those events in terms of likely, unlikely, even chance, it is highly certain, it is completely uncertain. Okay, so highly certain, or it is impossible event. So in those ways you have to frame your questions. Suppose if you are an analytics person and your manager is asking, hey, tell me that tomorrow what is the probability that the number of customers visiting our coffee shop will be more than 200. So you tell that okay, without calculating anything. What I mean by is that how many number of people were coming last week, before last week, last month, without calculating, without taking the data into consideration, you will say that sir, very unlikely. So what I mean by here is that he is not using any data. Okay, not using any data, but based on his self I won't use the word guess, self observation, he is actually telling that particular probability value, right? So we are going to cover what are those different types of probabilities in the later session. Okay, there are subjective probability. Okay, it is a person's belief. Empirical probability, which is nothing but he takes the data and talks about it. And then theoretical probability. Theoretical probability is mostly like I mentioned, right? What are the high school standards, we learned all these theoretical probabilities. Okay, which is nothing but actually you just say that how many ways that it can occur, which is something like how many satellite launches will be successful. So you don't have any kind of data, but you are going to predict some kind of theory. Theoretically you are talking about, not something like based on the experience. I'm going to talk about it, but before that we have to understand the sample space and events. So you may have observed that since the beginning of this class I have been using the word event, right? And all combinations, right? And some event and what is the possibility that particular event, right? So here sample space is nothing but which is actually having a kind of all possible combinations, and events is the one that you are more interested in. What I mean by it is that you are going to calculate that particular one. Okay, so for example, who is more interested in visiting my shop? Okay, the sample space is that there are many customers, C1, C2, C3, C4, C5, and like that. Then what is the event here? You have to define that event. Okay, you have to define the event. Event is the one that you are defining, and then you are calculating that particular probability based on that, the event that you are more interested in. So E is an event where the customer with age range 18 to 35 visit my shop. Another event I can tell you, E is the event where the customers, okay, with customers who are males or customers who are females. So you are more interested in solving one particular, understanding one particular probability, that you will call it as an event. All right. So whenever I say that event, means that I'm more interested in finding out that particular probability. Okay. Now, what will be the airfare during the summer season? Okay, air ticket prices are there. Okay, if I'm taking that, that can be sample sampling. It can be high, medium, low. These are the total possible set. Okay, and what is the event here? The event is an event where the prices are high. You wanted to know that how much the particular prices will be there. What is the probability that the prices will be very high during this particular summer? Okay. Similarly, there are 8 mistakes in a page. Okay, you are actually reviewing a book, and while reading those books, okay, so you found on an average 8 mistakes in a page. So now somebody comes and asks you how many mistakes you find in 200 pages. Okay, this is something like you have to estimate that. Okay, let us talk about the event. Okay, it is an M is an event where the number of mistakes in a page is even number. Okay, it is just, I made it up, but it is something like event is that, okay, events, the mistakes can be even number or odd number. So you are more interested in the even number. Similarly, given the last month's share prices, what will be the share price of Facebook tomorrow share prices? So the sample space will be share prices you are having. But what is the event here? T is an event. Okay, I'm just defining different words here. Don't worry about these words. Okay, it is an event where the share price is lifted by 2%. Okay, that is your more interested event. I wanted to know what are the chances that it will be lifted by 2%, or what are the cases where this is actually lifted. So something like that. Okay, and similarly, how many number of cars are having airbags on given national highway during the weekend? So cars are the sample space event. So K is an event where the cars are sedan type. So there are many possible different cars. Total number of cars are, let us say, 100. Okay, and during the weekend you found it, and how many of them are actually having airbags? And in event that you are more interested in sedan type, how many of them are actually, okay, are having the airbag? So what I'm trying to explain here is that these are some examples I provided. Whenever you are solving a problem, don't think that your boss is not asking you to solve the probability problem. Okay, when any problem that you are solving in industry, means you can really formulate the problem in those terms. Your communication with your boss, your colleagues, should be in such a way that you should define it. Okay, this is my sample space. I have taken this many event, and and this is the event I'm interested in. And many times I'm telling you, many people are taking the data, and without understanding the problem in those terms, they will just go and solve the problem, and finally after 1 week of cycles, they'll come back and say, I didn't find any results. Why? Because you did not really understand the problem. Okay, maybe for example, this is the one. The cars are sedan type. Did you see that how many sedan types are there here? If there are only one sedan type, okay, then the probability will come out to be very less. In the similar fashion, whenever you are solving any problem, you should completely understand the complete sample space, and you have to define your own events first, and then you jump into solving the problem, whatever the problem that you are going to solve. Without doing these steps, if you are solving the problem, then I would say that we are wasting time. Okay, so now going back to the 3 approaches to probability, as I told you, right? One is subjective probability, which is a person's belief. My belief that Hillary Clinton wins these elections is different from your belief. Here, I and you are not using any data, but we are using our previous experiences or readings from the newspapers, news channels, and all these. Based on that, I'm coming with some belief that this is the value, that particular probability that Hillary Clinton would win. It varies from person to person. Okay, I would say that there is a high probability that Messi would come back. You would say that no, he would not come back because he is imprisoned. Okay, and there is something like a big project is there, and the revenue is coming out to be something like $300 million. Now, given the chances that that particular probability is success is less than 20%, okay, I mean to say it is going to fail. 20% means 80% chances that it is going to fail, but the revenue is coming out to be $300 million. Then will you take up the project? So your personal belief tells you that should I really take this project or not? How many chances that my career would go up, okay, if I take this project? So these are all subjective probabilities. Okay, so as we go down, I'm going to teach you that how we can introduce these subjective probability values in solving your problems. And second is empirical probability. Empirical probability is nothing but you conduct the experiments and then you calculate the probability. You conduct the experiments. If I'm throwing a dice, or if I'm catching a bus or catching a metro, how many times am I going to miss? So you calculate the data. Okay, for example, Sachin made more than 8 centuries against Australia. What is the probability that he would make century in today's match against Australia? Here I have the data of that particular cricket player Sachin who made centuries. Okay, so now based on that I'm going to calculate the probability. Now coming to the theoretical probability, here you are not conducting any experiment. Here it is not your personal beliefs. It is something like theory, you would say that. Okay, if I want to catch this train, okay, what is the probability that I'm going to catch the train or miss the train? Then you will actually calculate where am I staying, how many times, what are the possible chances that you would go, can I catch the train? So you will take all those possible combinations and then you will tell the probability. There you are not empirically, you are calculating the data. You are not actually telling the subject that, oh yeah, I can catch the train with 80%. That is completely without calculating data from your personal belief. You are telling that is subjective probability. If you are collecting the data every day and you are doing and calculating them, that is empirical probability. If you are just calculating just like a mathematics that, okay, this is the chance, this is the chance, this is the chance, then that is called theoretical probability. Okay, so whenever you are calculating any probability problems, working on probability problems, first you have to really define that whether that person is talking about subjective probability, empirical probability, or theoretical probability. Many of our discussions that happen in industry are subjective probabilities. Okay, which is something like experts talk about these things. Experts, subject matter experts, based on their 20 years or 30 years of experience, they would say that this is something like going to happen. But that particular era is going to be changed with the data is arriving into our servers. Okay, like which means that we are getting more data, that is we are having more empirical results, the real values we are having. So industries are actually using both SMEs and empirical probabilities and then getting the most powerful insights in terms of business decisions. Okay, theoretical probability, of course, it is something like you don't have the data, you don't have subject matter experts, and you will just calculate these things. We are going to talk about Bayesian theorem and how we are actually going to use this Bayesian theorem in any of our practical applications. So how many of us are having a very basic fundamentals of probability? What I mean by basic fundamentals of probability here means we have done a lot of probability courses during our elementary school level, right? During that period of time, we know how to calculate a simple probability. For example, the common example that we generally take in this one is that, okay, there is a dice, and when I throw this one, what is the probability that I will get even number, or what is the probability that I get some number? So you will find out all the possible chances, and then you calculate the probability. So this is what I mean by elementary level of probability. But in practical applications, whenever you are solving a problem where you are having lots of data and you wanted to really understand the relationships among the variables, that we generally cover how exactly the two variables are related, you wanted to, or two events, I will put it, okay, in the probability terms. I really don't want to make it very technical. I just want to give you a very simple example so that let us understand how exactly uh, these concepts of probability we can use it in the real practical applications. Okay, yeah. Now coming back to this one, yeah, there is a relationship between two events or two variables you wanted to find out. Let us say um, uh, Max or Thomas came to the office very late. So when the manager asked him, okay, what is the reason for his arrival coming late? So he said that it's a traffic. Okay, so traffic is an event that made Thomas to reach the office late. Okay, and that event is causing another event to come late. So if I take two variables here, coming late or not, whether there is a traffic or not, if there is a relationship you wanted to understand, okay, traffic always causes the persons to come late. So if you understand the relationship between these two variables, like traffic and coming late, are two variables, so you wanted to find out one variable how it is causing the other variable to act upon. Similarly, in any e-commerce application, you wanted to see that a particular product has been really sold very well, which means, for example, a cell phone has been sold very well. So what is the reason behind that particular activity? You wanted to understand that the sales are growing up very well, high. You wanted to find out the cause behind it. Is there any other variable which is impacting? Is it just because of my salespeople performance, or is it just because I put the right element at the right amount of time, or right pricing? Or you want to find out what is the relationship between the pricing of the product and the sales of the product. You wanted to understand the relationship among them, right? So in those kinds of relationships, generally how we approach, if I approach just a common thinker, I approach this problem is, okay, let us see how many products had been sold, okay, when I was, means how my sales were there when the product price was, let us say, $100, and how the product is, the sales are changing when my product price is, let us say, $25. So there is a change in this particular variable, how my sales are actually getting affected. So you want to find out these relationships, the associations you want to find out, okay, between the variables you want to find out these associations. When you want to find out these relationships, okay, we find out, okay, whether it is dependent, independent, that is a different story, where we had conducted chi-square test, and using the chi-square test we found out the relationships. There we were just finding out the relationship, okay, but here we wanted to find out the relationship in quantitative terms. How much? That is the answer that we are going to answer here. How much? Okay, whether in the chi-square test we are trying to find out whether there is a relationship or not, dependent, independent. It's a binary answer, but here we are trying to find out how much it is actually getting affected. If it is raining, how much my traffic in this particular city is going to change. Okay, if it is drizzling, then maybe different. If it is heavy rain, then that is the traffic is different. So is there any relationship between them? That is the chi-square test we use. So are you with me, guys? So what I'm trying to say here is that this particular probability, until now, until elementary level, we have been using it in the form of like just understanding, okay, events. But as we are started going to use this one in the applications of our industry problems, we use it not only one particular variable, we will find out the relationship among different set of variables. Okay, now here what I'm trying to cover here is that how these Bayesian rules can be applied. Okay, so that is what the main focus of this session. Let us review some probability rules before you jump onto this Bayesian thing or any Bayesian rules or Bayesian theorem. Let us talk about first question. Do we know what is contingency table? If not, let us review that. Okay, what is a contingency table? To determine whether two categorical variables are related, we generally okay, any one particular variable, categorical variable, you want to see that profile, I mean, so the distribution of it. You see how many number of unique levels are there, that frequency distribution is different. Now we are going to use this contingency table, okay, not only for 2 dimensions here, okay, to find out 2 variables. You can use for 3 variables also, 4 variables also, 5 variables also. So that is called k-way tables. Okay, the 2-way, 3-way, 4-way, 5-way, 6-way, which means 6-way means I'm going to find out the relationships of the 6 variables at a time. I want to put it in one particular 6-dimensional table to see that how much this variable is going to affect. So very simple example I can give you here is that, for example, your manager is asking you to find out the patterns in the data. Okay, then almost all of the variables are categorical variables, which means that one variable is gender, other variable is city, or second variable is city, third variable is let us say the product price, okay, the number of products they had purchased, and fifth one is that whether he is a student or employee, something like that. So you wanted to know that how many students are males, okay, coming from one particular city, let us say New York, how many products they had purchased. This is one question. And you wanted to know that tomorrow if you want to project or predict your sales or anything, okay, does the gender is having any effect on the sales, does the place has any effect on the sales, does the type of employment, like if student or employee is having effect on the sales. So you wanted to know all these answers. If you know all these answers, then you will be able to easily answer, you will be able to come up with a insight that yes, I should not project this particular product for this particular segment. I mean to say students are not interested in this product. Employees are more interested in EMIs to purchase some products. So in order to come up all these things, you have to build a kind of a table that gives you all these insights. But the question here is that, is it really possible to visualize that 6-dimensional or 60-dimensional or 6,000 dimension or 1,000-dimensional contingency table? Yes, it's very difficult. That's why we are having a lot of algorithms. So generally that comes under part of a machine learning course, where we will find out how do we handle such kind of high dimensional tables. Not only handling, it's not handling, it is more of finding out the relationships. Okay, these algorithms would help us to find out those relationships those are related among the variables, and you can give you the better insights. That is what. But anyways, beyond going to that high standard of machine learning or anything, I just wanted to first get the idea of a basic contingency table. If you are able to understand this contingency table and calculating the probability, applying the Bayesian rules on that, you would be able to easily visualize how we can do the same operation at the higher level. All right, so we know this contingency table, you got the picture on it, right? So what do you learn from this contingency table? In this contingency table, we learn all the conditional probabilities. Okay, I'll give you the complete details of it. And then it also we have to understand that product and addition rules, what exactly that these rules, how exactly can we use these rules, and also we will cover here. Okay, so most of you know that, right? Product rule can be used trying to probability that both the events occur, means A and B, event A and event B, which is something like students and coming from New York. Okay, both the events occur. So your question tells that I want to know the sales for the students and they are coming from New York. Okay, another question is that I want to find out the sales for students, okay, are coming from New York, something like that. So that is the addition rule that you. So try to understand the difference and or. Okay, based on that you will get these probabilities. Okay, and what is Bayesian rule? Okay, so if I talk about Bayesian, okay, this is actually I'm leaving it to you. This particular question, how Bayesian statistics or Bayesian rules are different from frequentist approach. Again, I'm repeating this question. This is something like out of your curiosity. If you are interested to know the complete history of these Bayesian rules, I'm asking this question: how Bayesian statistics is different from frequentist approach. Okay, search it out and understand how exactly this is different. Okay, just to for those people to just give to get some kind of basic fundamental answer here is that Bayesian thing always, okay, have some prior information. Okay, so that is how you start your Bayesian approaches. Okay, I'm a little bit digressing from the topic, but I just wanted to spend only 1 minute on this here. Okay, let us say there is something like we all humans means we all had developed some kind of understanding about this world, right? What I mean by understanding this world is that uh, you you easily know that whenever Sachin Tendulkar plays cricket, okay, in Indian cricket, you always think that India wins, right? That is the confidence that since childhood I had built up, such kind of some kind of probability of winning India whenever Sachin plays. Okay, this is something like that. Okay, or I have some kind of prior information about Narendra Modi, the Prime Minister of India, implementing a policy in our economy or for economic stability. So we have all some kind of a prior information, right? So that prior information we can easily say that yeah, India will win. Yeah, Messi will resign. Yeah, Messi will come back. So you have some kind of prior information with all of us. So this is called prior probabilities. We are having some prior information. Okay, as you start getting more and more information, okay, the probability of that particular event happening is going to change. Okay, that is what the main idea behind it. Anyways, I will go and cover all these things, but do not worry about things. I'm going to cover all those things. So let me first explain you what is contingency table. Okay, so a contingency table provides a different way of calculating probabilities. Okay, this we have already seen in chi-square session. Okay, and but here I just wanted to explain you from the probability point of view more. There I was actually explaining it more from the statistical point of view here. Okay, so the table helps in determining conditional probabilities quite easily. You must be having a question here. We all got the idea of what is contingency table, but what are these conditional probabilities? Okay, so as I told you, okay, for example, I met you and said, hey, today there is a match against Pakistan in India, cricket match I'm talking about, and the probability of India winning based on my previous experience is 7 out of 10, means it wins. Okay, okay, so I mean to say 7 out of 10 is 70 out of 100, 70%. Wow, that this is something like an information I have. Now immediately I came to know that during my discussions, Virat Kohli is playing that match. Then I apply the condition like this. Then what is the probability that India wins given that Virat Kohli is playing, or he is actually Virat Kohli is playing? So what is the probability of India winning? Is my just India winning? That is the information, first level information I had. Now, given the condition that Virat Kohli is playing or is not playing, that gives me another level of information. In order to know that one, you should know what is the probability of Virat Kohli that he is actually making good runs, or some information you have to know about it, right? So here I wanted to explain the condition probability very easily. That condition probability is the one when you apply that condition, what is the probability that you would get? Okay, so let us take the simple example. Here I am showing you, okay, there is a data that I have taken from somewhere in the internet, and this data is actually showing that people who are using the car phone user and how many people got this speeding violation. Okay, I just wanted to find out the relationship between this variable, speed violation, and the car phone users. Okay, this is one variable, and within this variable, these are the levels. Okay, we have discussed the levels, right? Which means that if I say city is a variable where New York, Chicago, Atlanta, okay, Sunnyvale, all these places are coming out to be like levels, values of that variable, right? So similarly here, car phone user is one variable. In that, car phone user, not a car phone user, are the levels. Here, speeding violation is my variable, and how many of them are actually violating and not violating, yes or no, yes or no. Okay, so these are the values. So these are the actually independent variables that I'm getting, and I wanted to find out the relationship among them. Okay, so which is a relationship among them. I'm not trying to find out, okay, it's kind of finding out the relationship among them. So now you want to know that how many car phone users in the last year who actually violated this one, which is coming out to be 25. So I'm trying to find out the number of people who are doing end operation, not speed car phone users, no speed violation is coming out to be like this. And similarly the same thing, when you add them, this particular 305, which is showing the people who are using the car phone, means car phone user means people who are using the phone while driving the car. Okay, and 450 people are not using the car phone. Are you with me? So if somebody comes and asks you, okay, hey, tell me what is that particular number of phone users, car phone users are there, then you will say 305, right? Now somebody comes and tells that, hey, who are the people who are using the car phone user and violating the speed? That means this particular thing, which means this and this, which is joining here. Okay, this is the value. If my question is that how many people who are using the phone in the car and not violated the speeding, okay, this is the one. Similarly, not using the phone, but they are not using the phone, but they violated the speed limit, which is like this. Okay, so this is something like this total. When you do this total, this is the total number of people or the observations that I'm having. Now, out of this table, I'm going to explain different types of probabilities. Okay, before go to this table, can we do this quiz quickly? Okay, do this quiz by yourself. Okay, and let me know if you can build this contingency table. You'll get the complete idea of what exactly I'm talking about. Now here in this quiz, problem 1 is that completing the table, and problem 2 is that, okay, if f is the female, and this is another example, not the previous example. This is another example. So here it is the preferring the coastline and female. Okay, now I am going to ask the question here is that what is probability of female and preferring the coastline? Okay, see if you can answer this one by yourself before going to the next session. Okay, please try that one. Similarly, this one. Okay, here, okay, find out how these numbers are coming and what is your understanding in terms of dependency independence. Okay, similarly, I'm giving you all these different quizzes, and please go through them. I'm sure you will get the complete idea in the on the. If you make mistake, don't worry. So once you have this table, okay, once you have this table, you are going to, okay, let me show you a simple example before go to this one. Okay, practical table. Let's say this is something like a very simple contingency table I have taken. Okay, these are the people I'm taking. Right now I'm going to calculate the joint probability. What is the joint probability? Joint probability is the one which is having this, okay, this and this. Okay, for example, let me highlight this one, this, and this value is a joint probability. Okay, first of all, how I came to these numbers, I came to those numbers. These are the 20, right? Let me highlight this area first so that you can easily, these are the numbers I got, and this is the total, correct? This is the total, and this is the total. Okay, the overall total is 94. So in this contingency table, what I'm going to do is that I want to find out what is the probability of people coming from Maine who are from New York. That is nothing but the total candidates I have 94, which is nothing but 20 by 94. This is that value. Okay, C3 by this is that value, and similar, this is the joint probability I'm getting here. Okay, the complete joint probability of all the values will be equal to 1. Okay, don't worry about how this is and everything, just try to understand the concept here. It will be very easy for all of us. And if I ask the question that people who are coming from Chicago and those are males, which is nothing but 40 by 94, can you tell me out of all these 4 values which probability is more? People who are coming from male or coming from Chicago and who are males. Okay, I'm just taking an example to a shop or anything. Okay, I'm not worrying about it, just I'm having these 2 variables. Now this is what the joint probability. If I go back here, these are the actual values, and now I want to just find out the joint probability is nothing but A by the total that I'm actually taking. Okay, so that is what practically this is what it is showing here. Okay, similarly we are getting here. Okay, now by looking at this one, if I ask you the question, what is the probability of the people, okay, listen to my question, what is the probability of the people who are coming from New York? Okay, that means this whole thing. Okay, in my question I don't have anything. Okay, let me write down here. What is the probability of the people who are coming from New York? Okay, I did not mention whether male or female. Then it is only this particular thing I'm asking, which is nothing but this value. So let me write down here, which is nothing but this value, right? If I ask you the question, what is the probability of the people who are female? What is the answer? Then I'm not asking any question here, right? Anything related to that particular location or anything. So which is nothing but this value. This value is this, right? And another question, just to make up your own questions to understand better this one. So what is the probability of the people who are coming from Chicago and those are females? Okay, here did you observe? I'm using and. Okay, let me highlight that one. Okay, and that means Chicago and female. which is nothing but this value. Okay, see, whenever I say AND, which is a joint distribution. Now I'm going to talk about the conditional probability. Okay, conditional probabilities is nothing but given the condition, okay, and is different, and conditional. Let us go through that. Don't worry about it. I'm going to explain that very well. Okay, conditional probability. Conditional probability is nothing but, okay, whenever I say that what is the probability of people who are males given the condition that they are from New York. Okay, let me write down the question. Okay, here I'm not using any AND operator. Please remember, please look at this. I'm not using any AND operator. Given the condition, okay, given the condition that they are New York, you know the probability of New York. And now what I'm asking is that, okay, you know the probability of the males, right? The probability of the males is 0.638298. Now, what is the probability of the males given that they are coming from New York? Okay, here I'm going to talk about the Bayesian rules. Okay, how do I calculate this one is the main thing in the Bayesian rules. In the Bayesian rules, what we are going to do here is that I want to know, okay, what is the probability of the males. Okay, that means I just want to know the joint distribution of these two things. Those are the people who are coming from male and New York. Okay, and then I want to calculate what is the probability that, and the given condition is that they are from New York. Are you getting me? Again, don't get confused. I'm going to explain it again. Probability of males, let me read this. I'm starting again. What is the probability of males given the condition that they are from New York? Let us forget about this. Just try to see that what is the probability of people coming from New York? This one. This one. Right? Now, what I'm asking here is that here there are something like from New York, both males and females are coming. But my question is that if I ask you this question, what is the probability that the people are coming from New York? I can simply answer this. Very straightforward, right? But if I look at this thing, what is the probability of males coming from New York, given the condition from New York? So here I have calculated this probability, joint probability on the overall population. But here I have to calculate the overall, this probability only with respect to this particular one. Given the condition, it is only from New York. I don't care about all these things. So there are 20 people, right? And out of 36, 20 people are coming from New York. 16 people are coming from New York. So I just worry about this. The conditional operator always neglects the other things and just focuses only on this one. Okay, if it is Chicago, then you focus on this one. So now this is my total population. Now 20 by 36, that is nothing but 0.5. Okay, is the males who are coming from probability of males coming from New York. Given the condition, they are coming New York. Females is 0.44 New York. So this is the total one. Are you guys with me? Now the answer is that probability of that one, males given the condition that they are New York, just this is the condition first I have to remember. Then my whole probability distribution will be only this variable, because that is the condition I'm applying on that. On that condition I will just calculate this one, right? So this will be like, so why this is not coming out to be 1, why it is coming out to be 1 here? Because in this one we are actually, the population is only within this condition New York. Okay, it is something like this. I want to give this particular coupon to those people who have purchased my product more than 2000 in this year. So I'm applying a condition. As a manager, I'm applying a condition. When I'm applying a condition, I do not worry about other population members who are not satisfying that condition, right? Similarly here, I am actually applying that condition and trying to find out here. So the conditional probability of the gender given that city, this is what, right? That's what I'm calculating. Similarly, given the city, that is Chicago, what is the probability of male? 0.68, which means that people who are coming, I'm just only focusing on the people who are coming from New York and want to know that what is the distribution of the male and female. If you look at the joint probabilities, and Chicago males are coming out to be more, right? But here, if you take the overall population, let us see if I change it to, let us say 38, for example. Okay, if I'm making it 38, almost very close to the this one, right? So then overall population is overall joint probability is almost like this. Okay, let me take one more example. Maybe I'll take here 40. Okay, so here females are from New York are coming out to be more, but here with respect to the New York, this is only point, this is actually dominating more, and with respect to the overall probability, this is actually coming out to be less, right? So similarly, conditional probability of city given gender, my condition here is that, let me write down here. Okay, what is the probability of, okay, what should be my sending? What is the probability of people coming from Chicago, or I will write on, okay, New York, given the condition that they are male. Okay, here my condition is male, so what should I do? I should only focus on the males row, right? That is males row. I should not focus on this row at all, correct? So now this is, if I want to find out 20/60 is New York males, okay, 40/60 Chicago. Okay, I do not worry about female one. That is what, see here I'm doing C3/E3, C3 is nothing but this by this. Okay, so now that is how you are going to calculate the conditional probability city given the gender given the city. Is that clear, the difference one? Okay, so first of all, here also I will just, okay, given the condition, okay, if I say anything like and, then that is a joint probability. If I'm giving this one, then it is. Then there are some more concepts I'm going to talk about here. Okay, those are like, what are marginal probabilities? Marginal probabilities are that, just now I told you, okay, I'm just, what I told you, all these males are coming out, okay, sorry, all these males are coming out here, okay, only males 0.5 with respect to the whole distribution, my friends, don't get confused. With respect to the whole distribution, this is the joint distribution, this is the conditional table, conditional probability table. These are also called CPTs, conditional probability tables. Okay, joint distribution is nothing but this particular male with respect to the whole population, how much is this? With respect to this one, how much is this? Okay, sorry. Marginal probabilities only with respect to the joint probability tables. Similarly here, so this is the marginal probability of the people who are coming from New York. This is the marginal probability of the people who are coming from Chicago. This is the marginal probability of the people who are males. This is the marginal probability of the people who are females. Okay, and this can be applied for any problem. Let us say, and this is something like mortgage loan, paid or not, and this is their credit card report or something. You can create these continuous tables on any other table like this. So if you actually calculate all these things, okay, you will completely understand what exactly is considered. So if this is clear to all of us, then I can tell you the relationship how I can tell you the Bayesian rule. In very simple, Bayesian rule is, excuse me, is nothing but this gender given probability of gender given city is equal to probability of city given gender. This is what Bayesian rule. Let me go through this. Okay, anyways, I'm actually going to repeat the same thing here. Okay, we understood the joint probability, and this is the example we had done. Okay, joint probability is the overall distribution, right? And marginal probability on the joint probability table, whatever I just find out, New York people, okay, Chicago people, this is called joint probability of this one. Similarly, joint probability of male, this is the one that I had explained. It is very clear. So independent events, yes, this is something very interesting. Independent events, we have done that, right? So in independent events, that means there is no relationship. That's what in chi-square test also we have done, right? If there is no relationship between two events, then you say that yes, Narendra Modi is the prime minister. Visiting a cricket match anyway depends upon winning of the match against Pakistan or South Africa or Australia. So what is the probability of winning a match given the condition that Narendra Modi is watching that match live? Okay, means live means in the stadium. So is there any dependency relationship? So in those cases, the probability of winning that particular match, let's say B is the event, okay, where Narendra Modi is watching that particular cricket match live, and what is the probability of winning that A is completely independent. That means they are not related. So in that case, what is the probability of winning the cricket match is only probability of winning in the match, right? So there is no dependency relationship. That in that case, we call them that is something like, okay, whenever a conditional probability that you are applying, okay, that even after applying that condition, the probability of that particular event does not change. That's what it means, nothing else. So which is nothing but that is the probability of one event is not affected by the occurrence of the other event. Okay, whether I go to the office or not does not depend on Sachin Tendulkar playing a cricket. I'm an employee. I'm just doing my job. I'm not a cricket player, so it does not depend anything until unless he is my relative or something related to each other, or he dashes my car during the car accident. I don't know. I'm just making up all these examples. But my point is that here, whenever you are trying to find out the relationship between the events, so you generally apply these conditions, and if the probability is coming out to be the same, then those are not dependent. Well, so we are going to cover the Bayesian theorem here. Okay, so Bayesian theorem is nothing but the relationship between the probability of relationship between. Okay, if it is not equal to, it is something like relationship between probability of A given the condition B, okay, and probability of B given the condition A. So which is nothing but, let me write down here. Okay, I'm writing the Bayesian theorem here. Okay, see, this Bayesian theorem is going to use in Bayesian networks. Okay, that is actually interact with lots of many variables. Let me just figure it out with respect to the two variables. So the probability of gender given the condition that city, okay, is equal to probability of city given the gender, okay, the relationship, okay, into probability of city, okay, okay, let me put it this way perhaps, yeah, okay, okay, and probability that was nothing but a p of gender given city, okay, okay, probability of, I think here city, sorry, this is confusing for me. Why is it confusing me more? I'm getting confused. Is that right, my friend? Yes. Or I can put it like this also. Probability of gender given city into probability of city equal to probability of city given okay, probability of city given the gender into probability of gender, okay. This is what the Bayesian rule, which is nothing but the relationship between this contingency table CPT, and this CPT means conditional probability table, and this conditional probability table. But the same thing I'm going to explain using a very easiest way by using a trees, okay. That is what this Bayesian tree, okay. Here probability of F and probability of E, okay, or something like another two events. We can take it something like two events, okay, two events, and let me copy this one. It's easy and quick for me. So if it is something like, if I'm taking, okay, this is like E, okay, event E, and this is something like some F, okay, this is yes and this is no, okay, this is yes and this is no, something like this. This is another event, these are two events I'm taking, okay. So probability of F given E and probability of E given F, all those things we are going to learn with this particular tree. So this is something like I can take a probability of gender or a probability of city or a probability of F, probability of E, anything, okay, fail or boys, girls, or accidents, not accidents, mortgage payments, any event I'm taking, okay. So now what I'm going to explain here is that this is the probability of event yes, probability of event no, okay. That is what F and F dash. Here this event is, okay, occurring given the condition that this is happening. Here this event is not occurring, that means not occurring given the condition F. So we have to calculate these values, okay. Similarly, E, probability of event E occurring when F is not occurring, E not occurring, and F is also given the condition that F is also not occurring. So an example here is that what is the probability of India winning given that Narendra Modi is watching the live, okay, cricket live in the stadium. What is the probability of event E occurring, E not occurring, means India not winning the match when Narendra Modi is watching the cricket in the stadium. What is the probability of event E occurring, okay, when Narendra Modi is not watching, when India is not winning the match, when Narendra Modi is not watching. Or I can put it something like this. What is the probability of, another example, this is another example, I'm trying to give more examples so that I want you to really think about it, okay. What is the probability of India is winning the cricket when Kohli is playing the match, when India is not winning when Kohli is playing the cricket, given the condition, okay. When India is winning when Kohli is not playing, India is losing when India is Kohli is not playing. So you have, if you have all these kinds of probabilities, the values, and it can be many, my friends, if it is having many kinds of values, not only yes or no, it is something like a city, this can be New York, this can be Chicago, this can be Atlanta, like that you can get many trees. So this tree is going to help you to answer many questions. Then my question here is that first question I'm going to ask you, what is the probability of E, okay, given the condition F? I want to calculate this one. How do I calculate this one? How do I calculate this one? This condition probability. Very simple. We go to this contingency table, and here we know that, right? Right, given that condition it is city, right? This by this by this, right? So you know how to calculate this one, and these values you will get it, okay? These are clear probabilities anyways. These probabilities you will anyway get that one, correct? So now let us see, okay? So which is nothing but, okay, how do I calculate this one, this particular one? This into this. These are the two events, those are happening, right? Okay, those are happening, two events. Then probability of, this is the chain rule that we apply, right, that we already discussed. So probability of F into probability of E given F, okay, this is nothing but this, okay? When this is not, and this one nothing but this into this, that is this value. Similarly, this into this. How this into this is happening? Can somebody answer? That is what Bayesian rule. Okay, that is what Bayesian rule. Bayesian rule is nothing but probability of E given intersection F is probability of F into probability of E given F. And what is the, how do you define this one? Probability of E given F, right, into F. How do you calculate this one? This is the joint probability. This is the condition probability. So if you have this value, or if you don't know this value, if you know these values, you can calculate, correct? Anyways, with an example it will become more clear. Let us just complete these things, okay? Now if I want to know that conditional probability, which is nothing but joint probability by that particular probability of the event P of E. So let us just understand this one. Probability of F given E is joint probability by probability of E, or I can put it like probability of E given F is probability of F intersection E and probability of F. So can I write it down something like this? Let me write it down here. Maybe if it is confusing, don't get confused, okay? I'm writing it here from the same equation, okay? Probability of E given F is equal to probability of E, I will write it like this, okay, divided by probability of F. Probability of F given E equal to probability E and F probability of E. In this case the same thing we have done, okay? Probability of this one. Suppose if I want to make it this one, I will come to this particular form. Just watch here. Probability of E given F, okay, into probability of F, probability of F given E into probability of E. Can I derive this one? Because E and F I'm just equaling that, then I'm getting this, nothing but this is the Bayesian theorem. Is that clear? Right? So whenever I want to calculate a probability of E and F, if I know the joint distribution and if I know this one, I can get that, okay? That is what here, okay? Probability of E given F, okay, is nothing but probability of E given F is probability of E and F by probability of F. And if you want to know that probability of E and F, then you can do this, okay? Is that clear? Now if I want to, from this tree, if I want to calculate probability of F given E, which is nothing but probability of F intersection E by probability of E, okay, what is this probability of E? which means where exactly this event E is S. That is what, there is no complementary sign here. Where is that it is happening? It is happening, this particular India is winning the match given the condition that Kohli is playing, and India is winning the match when Kohli is not playing. So there are two probabilities of probability of E is coming. So or this or this. That is what here it is given. Okay, which is nothing but probability of E is nothing but, see, this is the probability of E, right? This probability of E is happening when E and F dash, E and F, two places it is happening. Am I right or not? You just observe this. E is happening. E is happening. Correct? So E and F dash and E and F. So these are all two OR events, not AND events. Okay, that's why we are adding them here. Since you know these joint probabilities, you can easily know that probability F into probability of E given F. Okay, it is nothing but the same thing we have discussed, right? Probability of F, this is F given E. Okay, and the probability of F dash, this one, F dash and E, this one. Yeah, this is the rule. Here it is the one. Similarly, F and E, this one, probability of F, okay, given probability of E given F. Is that clear? So this is how you calculate the probability of F given E. It looks very, I know, I'm sure you people, many of you definitely must have got confused. In order to alleviate that confusion, just draw this tree by your hand on a white paper. Don't just try to understand by looking at it. Maybe we can try with an example. I'm sure this time you will be very clear. Okay. So the problem here is that, okay, there are number of mortgages. Okay, there are number of mortgages and their default values. Okay, 5%, 10%, 20%, 25%. Okay, so what is the probability of 5%? This is something like the values that we have taken. I'm just directly giving you this example. Okay, and this is 5% you are calculating, getting it. Okay, then whether he defaults or doesn't default. Okay, default or doesn't default. I have given this complete example for you guys. You have to just put it on your pen and paper and try to understand this one. Okay, what is the probability of default given that, okay, he has we have only 5% of mortgages? What is the probability of not default? We have the only 5% of no mortgages. Okay, so if I want to see that, okay, what is the probability of 5% given the condition that he is defaulting? D for defaulting. So the defaulting is occurring in many places, right? So I want to add up all these things at the bottom, and I just wanted to know that what is the probability of 5%, okay, given that he is defaulting. This is what I wanted to know. Okay, then it is nothing but 0.225 by this one. Okay, similarly, probability of 10% is not defaulting, is not defaulting all these values, which is nothing but probability of not defaulting is, okay, sorry, probability of not defaulting is these values. Okay, we are taking these values. Okay, this is something like goes to the bottom. And what is the probability of 10% given that is nothing but this value? So 0.2425 by the wherever the probability of D dash is occurring, we are going to take. So now this is the question. Okay, this is the quiz question to all of you. Okay, there is something like probability of, okay, let us consider that A, B, C, D are different sections. Okay, so you wanted to see that whether that particular teacher is teaching that particular class very well and what is their fail. Okay, so teacher, you just want to know the effect of the teacher on the pass and fail of the students. If you want to know that, you know what is the probability of that particular teacher, okay, who is actually doing his performances before or anything, just like I mentioned, right? You have some knowledge based on that, you calculated. So you calculate that one. Okay, and now you wanted to know that what is the probability of pass given that teacher A is teaching. What is the probability that, okay, the teacher is actually failing given that the teacher A in the section, I mean to say A, B, C, D or sections, this particular given from this section, or the teacher is teaching. So you have the complete the probability values, and you wanted to know that who is actually doing better. So my questions are that what is the probability that a student will pass the class? Okay, what is the probability that a student will pass the class if he or she is from section D? Okay, that means this, okay, he is from section D. So section pass means this, where exactly the pass is happening, that will go to the bottom. Okay, again, what is the probability the student passes if she is section D? I think I'm repeating the same thing, I guess, right? Okay, absolutely. Okay, maybe you can put it something like section C. Okay. Okay, so you just try to understand, okay, how you are going to calculate these Bayesian things by using this one. If you people are very clear about how to calculate all these things, you can simply go for the Bayesian networks, and there you can find out many conditional independent dependent events and then calculate the probabilities. Okay, sampling distribution. So generally whenever you get a complete population like this, and consider that you got a big data problem, and the data is very huge, the number of customers who are actually coming to your e-commerce website is obviously in terms of millions, okay, for a very big website. So if you really want to conduct some kind of study on some set of customers, or you study, what I mean by is that in other words, it is a statistical study, or you want to get some insights out of that person, out of that particular set of customers. So you cannot actually pick up all the customers because it is a huge data, and if you really want to do some kind of statistical study on that data, it requires a lot of time, energy, man hours and all these things. So you cannot take all these things, so you just take some sample out of it. So taking the sample out of it depends upon the nature of the kind of study that you are actually going to do. What I mean by here is that if that depends upon the kind of population. First of all, I want to cover that first. The kind of population here, the population is actually completely having boundaries, closed boundaries, which means that if you are performing some kind of fertilizer on some set of agricultural plants, let us say, you want to see that whether that particular fertilizer is actually helping it to really increase your productivity or anything. So you have to apply that fertilizer, and you have to wait for a few weeks, and then you will get the results out of it, correct? And because you cannot also test the fertilizer directly on the agricultural lands, and you may get some kind of bad results out of it also. So all these plants might die, okay? So some kind of studies which is completely costly, what you do is that there the agricultural land that you are considering is fixed, which is not going to change. Means the population of those plants that you are considering is fixed, which is having a closed boundary. Whereas if you are actually trying to conduct a similar study of customers visiting your store, or the cars, the number of accidents happening on any national highway, there you do not know the right exact number of the population of the cars those are actually coming, or accidents those are going to happen. So that is completely unbounded, okay? So first of all, whenever you are trying to conduct this study, you have to know that whether this is actually completely bounded or unbounded. If it is bounded, then half of your problem is solved, and you have to just take the sample out of it. Once you take the sample out of it, you are going to perform some kind of studies on that sample only, okay, not on the complete population, right? So how can you take this sample? You can say that I can take this sample without using any criteria, which is randomly I'm going to pick up. So which is something like, I will give you an example. okay, in brewery system like beer manufacturing or any assembly of engines manufacturing, all these engines start moving on the trail. You pick up some of the things just randomly, you pick it up. You want to see that whether this engine is perfectly good or not, or whether this particular brewery, this particular beer is having the right chemical composition or not. You randomly pick up anything. And if you pick up any sample randomly and you perform some studies on that, which is something like this, I can tell you the best example. Recently, Maggi has been banned. So what they did, instead of doing the complete study on all sets of Maggis, they randomly went to different stores and picked up some Maggi packets from there. And they had done the study. Okay, they found in some lead percentage is there. So all these studies, whatever they are doing, they just blindly do not go and tell that, okay, this is having this amount of lead, so we have to ban it. No, nobody accepts it. They will have to prove that out of these millions of Maggi packets, this amount of Maggi packets are having this amount of the lead. The confidence interval is this much. Then based on that, people will take the decision. What I mean by here is that, let us say a Maggi sample had picked up and he tested and he found that lead is there. Okay, with a lot of confidence he will say that lead is there. Somebody will come and say that no, this is a sample error. What do you mean by sample error? Sample error, what I mean by is that the Maggi packet that you have picked up, which is the only one having that particular lead percentage, but others are not having. Okay, somebody can come and say that this is sampling error. Then you should go back and tell them no, this is not a sampling error. The number of samples that I have taken is actually following the distribution of the total population. Or you can say that out of this sample, if I am actually conducting this study, there is a significance of this particular sample is providing this lead is there. My statement is that it may contain or it would contain with this much percentage in the complete population. What I'm saying here is that you should not directly go and make your statements. Nobody would look at you. But there are some kind of statistical way of communicating your results. What are those? Those I'm going to cover here. That is called significance of the test. Significance of the test means whether you are conducting a test. I will cover more in deep details when I actually explain you what is hypothesis testing and everything. But here I'm just giving the fundamentals of significance testing. Okay, what is significance testing? So significance test is nothing but whenever you conduct any study on certain sample, this sample you are taking, and when you give any kind of your insights that you have observed out of this sample, you should show that it is not having any sampling error. That I will cover later, but let us finish off this sampling distribution. That I'm going to cover using the T distribution and other, that is a reason I have postponed the T distribution after the sampling distribution. Okay, so here for example, that Maggi investigation officer, he went and had taken some samples, like randomly he was doing that. Randomly doing that means with replacement and without replacement. With replacement means here in the Maggi case, he cannot replace that one. Okay, he cannot replace that one. What I mean by that? What is with replacement? Let us say you are having a class of students and you wanted to test the IQ test of the people there, IQ test of the students. So if you want to do your headmaster tells that, okay, do this test randomly, or he may give you some criteria. No, don't do it randomly. Use some business logic or use some criteria to do this testing. What is that business logic or some criteria? The criteria would be something like, okay, you do this test based on the top 10 ranked students only. Okay, so that is kind of, you are having the total set of students and you are applying some criteria. With that criteria, that is actually dividing the complete population into a subspace, which is a criteria that top 10 students. But here in the random sampling, the criteria here is that with replacement. With replacement means, suppose I pick up one student randomly. Okay, I don't know his name or anything. I just did some IQ test, and then the total number of students are, let us say, 62 students. Out of that, you picked up one student and you did the IQ test for him. You got some results. Now, you just keep that student back to the same population, then again number of students will be 60 only. Again, when you go and randomly pick it up, there is a probability that you will pick up the same student is 1 by 60. So with replacement, what happens is that you know that with replacement, the student that you have already tested might come again in your next experiment, next to your IQ test. So that is what called with replacement. So there are situations where we have to do this study with replacement. There are cases that without replacement you want to do that. Your headmaster says that no, don't do this experiment randomly, but do it without replacement. Without replacement, so that we can minimize the person that who had already come, already tested, okay, again come and attend the same test, which is something like 60 students. I have tested one, then I would just keep him aside and I will go to the population. My population has reduced it to 59. Okay, I will test it. 58, I will test it. 57, I will test it. So without replacement, you will perform this study. So that is called experiment with replacement and without replacement. Where exactly would this help you in modeling? Okay, in any of the modeling techniques, generally people prefer to do with replacement only. Okay, there are some studies like which customer had applied for the loan and what kind of benefits can we provide to that particular customer, and how much he can actually bring the value to our organization or bank institution in terms of loan interest that he is going to pay. So in that case, you pick up one particular customer, you give him a loan. Okay, randomly you pick up one customer, you give him a loan, and you want to test some statistical study that how much he is going to pay the interest. So in that case, you cannot go with replacement, because you cannot go send him back and again you take him and give another loan. You don't do that, right? So you have to actually find out where exactly can I do with replacement, where exactly can I do without replacement. Okay, so this is completely random. Now, for example, there are some criteria that whenever you are doing this distribution, okay, let us say I am going back to the example of you are the same example I explained in the last class. I am just taking the same example. You are the Dean of Academic Affairs. Your main job responsibilities are selecting the students for your institute. Okay, your institute is a national organization. So now, what you would use, what would we say is that, okay, your institute, assume that you are the only one institute, and you wanted to select the students. So when you are going to select the students, okay, there must be a criteria that you have to apply, right? So you apply something like there are 5,000 total students, and you are having total 800 seats in your institute, and you have to give some criteria. So when you are doing this criteria, you can simply take the top 800 people. Okay, you can take the top 800 people for your institute very simply. But now what we would do is that, yes, we can do that, but there is a restriction coming from the central government that, just as an example, no, we don't. If you are taking the complete top 800 students, it may be possible that all are coming from the Delhi only, all are coming from one particular Bangalore only, all are coming from one particular city only, one particular state only. Instead of doing that one, why don't we actually create different bins? Bins, what I mean by is that different states, and we will take top people from there, okay, using some criteria. Okay, so in order to do that one, what you have done is that you actually created different state bins. You create different bins here, and you know these are the top rankers, some rankers that you have got in these regions. So if you actually see that what is the percentage, this is the actual distribution of the whole percentage of the people. And now this is the actual percentage of it. So when you are sampling, the criteria here is that I want to have the same distribution. If you can see the same distribution, but the only thing that I have to change is that from 5280 out of these things I have to take 800. So what is the distribution there? What is the total number of people that I have to take, so that the percentage distribution remains same, then only my distribution will be same. This is one criteria. Okay. Now let us say your dean tells you that, hey, I want equal distribution, equal number of people from each and every state. This is called uniform distribution, right? This is the actual distribution, this is the uniform distribution. In order to come up with this uniform distribution, there is not sufficient people in Goa. There are only 80 people are there. But when you want to do the equal distribution, total 5 states, let us say 5 places are cities, okay, if you do the equal distribution 20%, 20%, 20%, but this 160 is, the population is not coming there. So even if your dean tells that, okay, take the uniform distribution, then you should be able to tell that uniform distribution is not possible here and we should go for some other criteria. Okay, for example, if it is like 180 people, yes, I can take the equal distribution, then the distribution is a very good distribution. So what I want to say here is that the number of people that you are taking the admission, okay, should convince others that, okay, this is a very good strategy of selecting the people. This is a good strategy of selecting the population on which you are going to do the statistical study. So for all these things, okay, you do that. You actually consider this. Now I'm going to a little bit. I will give you one. I will go into one of the real cases. Let us say, whenever any transaction happens, okay, I'm just taking another example here. I'm going to tell you what it is. Whenever you are doing any ATM transactions, okay, assume that 1 million transactions are happening in Bangalore for a bank like SBI. Okay, out of 1 million transactions, every day there is a possibility of happening at least one fraud. Fraud, what I mean by is that that fraud is something like using a card to withdraw some money, and then they will get a call from the customer that money is withdrawn without using any card. That means somebody is tapping your card or some fraud is happening. If you are taking this example, now out of 1 million transactions happening in a day, maybe I'm exaggerating the number, but just to show you the difference of the distribution here, 1 million transactions are happening in a day or in a week. Let us say in a week there are 2 frauds are happening. Assume that. Now they will come to Vikrant and they will say that, hey Vikrant, we are having this particular problem that out of 2 million transactions, sorry, 1 million transactions, every week we are actually finding out 2 frauds. Then you would say that, okay, then you will ask some questions. Okay, 1 million transactions, how much money was the actual transaction happened? They would say, okay, almost all 2.5 crores of ATM, or 20.5 or 20 crores of money has been actually withdrawn. Then you would ask the question, okay, the further 2 frauds that is happened, how much money did you lose? So they will say that, okay, almost all total of 2 frauds I lost some 50 lakhs, which is a very big amount, right? So right. Out of 20 crores or 20 crores, 50 lakhs amount of fraud is happened means it's a very big amount. Then they will ask you the problem, can we predict what kind of fraud that might happen in the future? Okay, where exactly the fraud can happen? Can we predict? So you can predict at least with some 30% probability or 60% probability. You cannot predict, of course, with 100% probability fraud would happen on this day, this particular time. But by using the kind of transactions, the kind of timing of the transactions, the amount of the transactions, and the velocity of transactions, the place of the transaction, these are all different variables that you consider. But in this whole population, if you take the data of history of the past 10 years, okay, and assuming that in 1 month or 1 week, I will take it 1 month, 1 million transactions, there will be 12 million, and 10 years of data, 120 millions of transactions. Out of 120 millions of transactions, I am getting almost 24 into 10, 240 fraud cases had happened. So the distribution of that particular one, okay, if you draw it, which is very big like this, and the other transactions are very less. Okay, now you are going to build one artificial neural network model on all those variables, because artificial neural network or any other decision trees, some other machine learning models are actually proved to be finding this fraud patterns most efficiently. When you are trying to build the model, you need some set of, you need to sample the data most efficiently. So when you sample the data, randomly you sample the data, there is a high possibility that you may not get the transaction that is not a fraud in your model, right? Because there are almost 240 million transactions, you just go and pick up at least 20,000 transactions, for example. Okay, small n is equal to 20,000. When you are picking up n is equal to 20,000, which is very small, out of 240 million transactions, the probability that you are getting a transaction that is fraud in your sample is very, 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 very less. So in those cases, we generally use stratified sampling. Okay, so stratified sampling, what will you do is that the moment you collected 240 million transactions of the data from that particular bank, what you do is that you will tell your juniors or your subordinates, hey, this is completely, the distribution of the data is highly skewed. Okay, highly skewed in such a way that the number of frauds is coming out to be 240 here. So do one thing, create 2 buckets that I will call it as strata 1, strata 2. Okay, strata of the total population, because out of 240 million transactions, you have only 240 frauds, right?
Okay, right.
So what I do is that I will create strata 1 is 240 million minus 240. This is the strata 1, and 240 is the another strata 2. Without fraud, this criteria, and here the example, you understand the example. Similarly, if you are having some age of the people and male and female, so what you do is that, hey, I want to create some criteria like 2 stratas I want to create, strata 1, strata 2. Okay, strata 1 consists of males, strata 2 consists of females. Now for your IQ testing or any other testing, you want to take people who are actually, you want to take 2 males or 5 females or 1 male or 4 females, like that you can change that one. And in that case, what happens is that you might sometimes get a criteria, no, I want to test this for an IQ test equally for both males and females. Then what you do, okay, I will create 2 stratas, male, another strata, female. Then I will take equally means 3 males, 3 females. Randomly I will take them. Then I will just do my study on. If you are having some 300 columns, okay, then if you take randomly, then what is the probability that you will get the equal probability of males and females there?
Okay.
Right. So it's only one example I'm telling you, but the strata that I have created here is only with one column. You may come up with another column is that, hey, I want to do the strata, I want to create the strata in such a way that males Bangalore and earning more than 20,000 rupees per month, like that I will create some kind of rule to define the stratas as well. Sometimes the distribution, the sampling that you do, this is the main mistake I found in my team also. People generally take the data, okay, we wanted to start with some criteria that, okay, take the distribution of this like this. They will take equal distribution means, yeah, I applied equal distribution, but they really don't check whether it is actually equally distributed or not. With the less sample, not 800, in that case, if you do this one, if you take all the 80 and 720 people only, on that 720 people only, they start building the models. They are missing a lot of data there. So every time we have to double check, that is called quality check, the number of samples that we got is actually correct or not. Every step we have to do that one. That is once you start doing the practice, it will become more practical.
Okay.
Okay.
And don't we compare the distribution pattern of a sample with the full distribution of whole population? I mean, to check,
Very
I mean, that.
Very
Yeah.
good question. But that is what. Sometimes the whole population distribution you don't know. A number of cars coming between 5 o'clock to 7 o'clock
Right.
this evening, you don't know.
Right.
The population you don't know. That's what I told you, right? If the population is fixed and it is very well known, like you are actually testing the population on a class of students, yes, you know. If you are doing that complete study on some kind of unbounded population, you don't know their distribution, right?
Right. 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 So, I mean, you mean, I mean, there we check the distribution pattern for sample as well as the full population, where we have, I mean, fixed boundaries.
Yes. Even if it is the fixed population of people in Delhi and Bangalore, okay, you know the total population. You want to know that whether, even though it is fixed population, you cannot go and measure each and every person's height, right? Even then it is fixed population.
Okay.
Okay, so that is the main challenge here, is that suppose you want to measure the height of a penguin. Okay, you know that there are so many penguins. You know the population is fixed, let us say, assume that, and you cannot go and measure the height of the penguin. So if you want to say that somebody will ask you this question, hey Vikrant, can you find out what is the height of the penguins? Then you would say that, okay, I will take some sample, let's say 20 or 50 or 100, then I will actually measure the heights of these 20, 50 or 100, and I will draw the distribution. Then I will find out the mean of it, and then I will say that, okay, this particular mean is coming out to be, let us say, height is coming out to be, let us say, just 2.5 meters. Okay, you come back and say that, hey, I have found the average mean of 50 penguins. It is coming out to 2.5 meters. Then people ask you this question, Vikrant, have you done on the complete population? You say, how can I do that on the complete population? I cannot do that, obviously. But how confident are you on coming out to be 2.5 is the one? Then that point you should be able to convince him that there are no sampling errors. Okay, there is if I'm taking the average of is coming out to be 2.5 meters, my confidence is that this 2.5 meters is the whole population's average height. The whole population's average height also will be 2.5, or it may be between 2.3 to 2.8 with a confidence of 90. That is called confidence interval. That's what we discussed. We draw the distribution, right? And we show that one, right? Sigma, 1 sigma, 2 sigma, 3 sigma. That is how you actually answer that. Okay. In those cases, you do not know the mean population. You have to estimate the mean population. Okay. And also, I'm going to the t-distribution. There I will tell you that, but I will give you some kind of understanding here. When you do this experiment, okay, when you do this experiment, you have taken some sample population. It is coming out to be 2.5 meters of the penguin height. You will actually go walk across the ocean, and you go to another region, and again you pick up another population. Okay, here which is randomly but completely different subsample you have taken. On that you got 2.6 is the average height. Okay, and again you take another segment of it. Again you take another segment of it. Again you take another segment of it. Like that, since you have energy, time, and money, then you have almost all. You did not cover the complete population, but you have taken the number of random samples more and more. So as you started moving like 1, 2, 3, 4, 5, 6, 7, 8, 9, like as you are increasing the number of statistical studies of different samples, if you are getting, let us say, 2.5, 2.6, 2.3, 2.4, 2.5, 2.6, 2.8, these are the means of the samples, for example, and the means of the mean is going to be the complete population sample. Okay. Anyways, I will explain more there. Okay. So you understood what is the stratified sampling? There is actually proportionate sampling and disproportionate sampling. Okay. Disproportionate sampling is actually what you do is that here if you look at here, okay, is actually 1, 2, 3, 4, three males are here. Total males are 1, 2, 3, 4. 1, 2, 3, 4, 5. So out of 12, I guess 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Out of 11, that actually I have taken 5. There is actually 5, but here I have taken only 3. So it is nothing but 5 by 11, and this one is actually 6 by 11. 5, 6, 7, 8, 9, 10, 11. Yeah, 6 by 11. So actually this distribution is actually not following this actual total population distribution. Am I right or not? Here it is coming out to be 3 by 6, which is nothing but 50% of the 50%. Here it is 1, 2, 3, 4, 5, 5 by 11, which is coming out to be almost close to 50%, but not the 50%. So that is what disproportionate sampling is. This sampling is not actually representing the complete population. Here it is 3. Okay, 1, 2, 3, 4, 5, 6. 6 out of that I have taken 3. 6 by 11 here again. So disproportionate sampling is the stratified sampling procedure in which the number of elements sampled from each stratum is not proportional to that representing the total population. Now proportionate sampling is the one where you will maintain the same one. Let us say here 1, 2, 3, 4 by 12, I guess. Yeah, 12. 4 by 12. How much? It is 1 by 3. Here 2 by 6, 1 by 3. Females I am talking about. Okay, this one males are 8 by 12. Okay, here 1, 2, 3, 4. 4 by, it is another 2 by 3. This is also 2 by 3. Proportion in the distribution, not count. Right. Whenever you are actually doing with the whole thing, then it will called as a probability, not the count. It is something like you are maintaining the same proportions here and there. So there is a high chance of your studies, whatever you are conducting, would actually reflect the same on the complete population also. You choose one sampling technique, Vikrant, that comes only based on your data and the problem. Systematic sampling. Systematic sampling, I just want to give you this example, is systematic sampling is the sampling where you wanted to apply some kind of intervals in between the times. You wanted to see whether a particular disease is epidemic or not. Okay, what I mean by says that, okay, or you can say that in any assembly process you found some kind of quality issues of that particular engine, some missing of bolts or some missing of all these things. So immediately you go and complain to the quality control department and see these number of samples I have taken, or on which the number of bolt torque is actually less. Then they will say that, okay, we'll fix this problem. They fix that problem. Again, you just wait for 2 weeks, again go and pick up another sample. Okay, again you wait for another 2 weeks and you will pick up another sample. So which is a systematic sample is something like, here I have given the same example, I guess. So systematically select every car with every ith car in the assembly line of a car manufacturing company is a good example. Okay, which is a systematic sampling. Any traffic police officer who wants to check whether the license, people are carrying the license or not, then they just let other people go. The moment one particular person is processed, then they will pick up another person. So that is called systematic sampling. So they cannot pick up all the population, but they will just pick up people in some kind of intervals. So this cluster sampling is generally cluster sampling. I told you, right? You asked me this question when you asked me, can we do this directly or? So cluster sampling, what happens is that you have male, female, and different states and different salary ranges and different occupations and everything. You are having many columns. there, when you apply this criteria, let us say he should be male, he should be female, he should be male, coming from Bangalore, earning more than 20,000 rupees, having this kind of software job. I want to take that sample. But sometimes when you do your rule, it may not be true that it may not be possible to get a very good sample out of it. You may get one or two for sometimes if you apply a very big rule. So what you do is that you apply this clustering. Clustering is a technique. What you do, it will group all the people based on some criteria. Let us say all the people coming from Bangalore, okay, but maybe having a different occupations may come into one cluster just because the criteria they are coming from Bangalore. Okay, maybe people who are coming from not coming from Bangalore but having ages, same ages and same salary criteria may come into one cluster. But so what I mean to say is that by clustering on some set of variables, you are trying to group the people at least meeting some certain criteria. Clustering is a technique that actually represented as two vectors of represented any two peoples or any two observations are represented as vectors. Whenever the distance between them is coming out to be 0, may not be all times 0. If it is 0, then it is overlapping, right? Any 2 points, if you take in the Euclidean space, the distance between them is 0, means they are overlapping. So they are not overlapping, but at a distance of 0.1, 0.01, 0.8, 0.2, like that, then which is something like representing as okay, they are very close to each other but not the same. Okay, that is what this clustering. So this defines a cluster where, okay, if everybody is matching to the everybody is actually same, altogether same, then it will be a point. It's not a group. Okay, so clustering is a technique where it will actually cluster group the people based on certain attributes. Okay, where the distance between those peoples almost all will be not 0 but at least at 0.1, 0.2, like that. So this is one way of sampling also that people generally follow.
Okay.
Okay.
How will we measure the distance? Like if we have one criteria salary greater than 30,000 and we have another criteria like age greater than 30. So how will we be able to measure the distance between these two criteria and group people?
Okay. So let us say you are taking different variables. Okay, age, salary, height, and location. Okay, occupation, something like this I have taken. Okay, so age is coming out to be 25, salary is coming out to be 20,000, height is 150 centimeters, location is Bangalore. Okay, occupation is software engineer. Let us say I will say Bangalore, his age is like 24, earning 15,000 and coming out to be 145, and he is a manager, something like this, something like 23, 20,000, 123, Gurgaon, and he is something like an analyst, for example. Okay, when you want to do the clustering, let's just imagine that there are many data points like this. When you are having, just imagine that there are many data points like this. Okay, just I'm putting some like this. So there are many data points like this. Then each one actually represents a vector, right? So here it is actually 4-dimensional vector. Okay, so I will just take only 2-dimensional. No, 4 dimensions I cannot take because we cannot visualize that, and I'm actually just taking 3-1. Okay, this is coming out to be something like this is, oh shucks, this is something like age. This is something like salary. This is something like height. Okay, just I'm taking only these three variables for our easy understanding. The first and foremost thing that we are going to do is that I'm going to cover in the next session actually, but I'll tell you here itself. Do you think should I go and directly apply it here? Okay. Let us say age is 25 and salary is 20,000 and height is 150. Then that point is coming out to be somewhere salary is 20,000. Okay, here. Okay, and 24, 15,000 this one, and this is coming out to be salary. This is 25. Then I'll go 24. 15,000 is coming here. Height is less than this, so it will be somewhere here. Okay, just somewhere here. This is my second point, and this one is further down. 23 means that this is 25, 24, 23. I will take it here, and 20,000 is salary, same high. This one, and 123 is the height. So since we cannot visualize very perfectly, I will just drop it here. Okay. Now you want to do the clustering on this one. Okay. Just like this, assume that there are many points I'm taking. Okay, many points I'm taking here. Now you want to do the clustering. What it will do is that you are not applying any rule or greater than or 20,000 or anything here. That you are doing only for the stratas. Okay. Here what you do is that you are trying to identify those rules out of here in terms of clusters. When you do the clusters, what it will do is that it will calculate the Euclidean distance between these two and between these two and between these things and between these two also. So it finds out, okay, the Euclidean distance is actually coming out to be very high here, okay, very large than these two things. Then it will disconnect this connection and it will make one particular cluster here. Similarly, it depends upon actually there are some parameters that you have to adjust in order to find out the best clusters or anything here. Okay, it will find out this cluster. So that is how you will find out the clusters and everything here. Okay, then this is out of these clusters, then you will take randomly one person from here, one person from here, one person from here. The best example is that I take an India map and find out the clusters of different states and taking the people out of each particular state. Let us say V1 is 25 I plus 20,000 J plus, these are I, J and all these are all some unit vectors. Plus Bangalore L, something like this. Okay, this is one vector.
Got it.
Okay. Now I want to go back to the students T distribution. Okay, since you understood the complete this thing. Okay, now student T distribution is a kind of distribution. When would we apply this one? Okay, whenever you are taking this sample, let us say, okay, whenever you are taking this whole sample and whole population, and you want to take a sample like this, for example, this sample will have some mean that I am actually representing with the x bar, okay, and a mu, assume that you know that, okay, but you don't know the standard. Mu is not constant. Mu is the
right.
Complete population one. Complete population one, you know that, okay. Then but only thing is that you apply this student t distribution. Okay, you can apply normal distribution also. When this t distribution is helpful is that this is the condition. When you are taking the number of samples is less than 30, okay, and the standard deviation is not known to you. Okay, the standard deviation of the complete population is not known to you, and comparing the distribution of any two samples. I will tell you about this one in the next slide. But so here, if you take ICC decided to select 20 cricketers out of 100 cricketers whose scores are distributed with an average runs of 45. So you know the mean X bar 45. You know the total sample N is equal to 20. You know this. Okay. So what is the probability that the selected sample would score at least 40 runs? Okay, with the standard deviation of 10. Okay, that means S is 10. Okay, and at least 40 runs is nothing but probability of the event that you want to calculate.
Okay.
Okay. Earlier examples of things, then I will go to that in just a minute. Earlier I was actually showing you these things. Okay, in the ICC World Cup, top batsman scores have been collected. You remember these things? So when we were doing this one, see here, this is the event. This is actually mean. Standard deviation is given. Okay, right? And you want to calculate this probability. But here, what the t distribution is actually doing here is that this one. You are taking 20 cricketers out of it. That means the sample size is 20. When it is out of this thing. So whenever the sample size is less than 30, it is a rule. I don't know how it has come up, but generally I told you the student distribution is it is not anything related to student or anything, but this is the t distribution. This technique has come from Guinness brewing company. They wanted to test the quality of the Guinness beer, so where they are actually going to take very less number of samples, and there may be some thousands or 10,000s or 1 lakhs of beer bottles, and they want to test it only 10 or 20 beer bottles only. So in those cases the sample is very less, and there is a problem as we discussed in normal distribution also. When not normal distribution, just quite 5 minutes ago. When you take the sample is very less, okay, the chances of that particular very small sample, let us say I will go back to the same example of the measuring the heights of the penguins. There are almost all 200,000 penguins are there. You want to know that one. You have taken only some small sample of the penguins. If you are taking only 2 penguins, and if you are calculating the average height of that one, that is not actually representing the complete population. So you have to take the best sample out of it. There are cases that you cannot take those many samples. If you want to test any doctor's efficiency on some surgery, you cannot put many people's lives at risk by taking many samples, right? Where the number of samples can be 1 or 2, maybe even not 1 or 2 also sometimes. I'm just telling you. So in those cases, what happens is that the number of samples is very less, and standard deviation is not known, and you wanted to know how much this particular sample. Please, I'm going to talk about this. Whatever the value that you get some value for sure, t value, okay, from this. But how do you interpret that value? You are going to interpret that value in such a way that when you take this sample, let us say 20 cricketers you have taken. So cricket board will come and ask you, hey, why didn't you take 20? You should have taken 60. Then you would say, sir, I cannot take 60 because the chances of spending the money on their trips will be going to be very high. Then why are you taking exactly 20 only? So how do you think that this 20 is actually representing the 100 cricketers? This is the question comes to them. Then you will say, sir, I can take these 20, okay, I am sure that these 20 cricketers I am taking, the random sampling error I am going to get is very less. Then they will say, what is this random sampling error and all these things? Then you will say that the sample that I am taking is almost all representing the complete population. This is what you will say in simple English. Okay, in order to convince them, what you would use is that you will calculate this t-value. Okay, once you calculating this t-value, you will have to tell that with some confidence. That is called the confidence interval that we discussed in the distribution. So when you go and try to describe them, okay, you get some t-value, let us say 0.3 or 0.2 or 1.2 or 1.3. So for every one this one, you will go to the t distribution curves. If you can Google it, you will get the t distribution curves. Okay, for each t value, there is a probability that those are actually defined in those tables. These are called statistical tables also. Okay, nowadays what happens is this, earlier in our schools or colleges, we used to calculate this value and go to that t tables. If you want to see those t tables, you can quickly see those things here. Okay, t statistic yeah, t statistic p tables, t statistic table. Okay, these are the tables. If you remember, if you go to the 10th standard or 12th standard, we used to look at these tables. You remember? Okay, so for each t value, there is a probability value that is going to define. So this is the distribution, and it will show you how much probability value that it is actually having. Okay, I'm going to talk about it. Okay, so earlier we used to go and find those values. Okay, before going to that interpreting the t value, I just give you one more example of where exactly shall we use. So comparing the distribution of any two samples. Let us say you wanted to know IQ of people from Delhi and Bangalore. Okay, so from Delhi you have selected some people. Okay, let us say this is the population, the complete population of India, and you have taken N1 samples from Delhi and N2 sample from Bangalore, let us, or Madras. And now you want to compare the distributions of these two samples. So it will have some mean, okay. Now whatever the distribution that you have taken, you should be able to convince the people that these two distributions are actually the best sample that I have taken for my studies or for my model building. So you calculate the t value here also. Okay, you calculate the t value here also. Earlier only one sample I have taken, that is with respect to the complete one. Mu is the complete one. Here with between two samples. Okay. So when I calculate this t value, I got the t value. Okay. Now from this t value, using those tables, I got the p value. So p value is nothing but it is the probability that the sample is actually, I'm going to tell this rejecting hypothesis, null hypothesis. Don't look at these things, but I don't want to confuse you, but look at these curves only. So p value you have decided is something like 5%. Okay, 5%, which means that this is the actual total distribution. So from here to here 90%, and this is 10%, 10%. You say that 5% means total is 5% means here it is 2.5, 2.5 because symmetry. You actually take something like 5% means 95% is from here to here. You say that, hey Madan, I want to take 10% of p value. Okay, no problem, go ahead. So when you take that p value, okay, you take the p value something like 10% you have taken. So this is the curve. The t value from which you got the p value is coming out to be, let us say, 0.01. Where exactly that will come? Somewhere here, 0.01, because you have taken almost 10% means 0.1, right? It will come to the 0.01 here. So whenever this is actually coming in this region, means whatever the region here, then I'm telling you very simple English, okay, then you are confidently can say that the sample that I have taken is very good. The sample that I have taken is good and it represents the complete population. So everybody will agree. In case the t-statistic, I want you to calculate it by yourself, okay? The t-statistic you will get something like 0.8 out of this one, for example, from this same experiment if you do this, okay? Okay, why don't we calculate right now? Right now it's, so x bar is what? The statistic one, how much is that? 20 is the n, and 100 who scores this is 45, then standard deviation of 10, at least 40 runs. What is the probability that they would score at least 40 runs? So I did not give you the x bar, I guess. Okay, I did not give you the x bar. Okay, I'll just consider at least. No, it is not at least. Score average 40 times. So 40 minus 45. Okay, which is minus 5 by s by this one. So root 20. Okay, anyways, can you calculate this one? Okay, by yourself, and you will get, let us say, one t-statistic. Okay. Okay. That t-statistic, just you go to any t and p calculator, p-value calculator. I just want to show you how generally do. Okay, we can take this one. Pick p-value from t-score calculator. So let us say, I don't know, yeah, your t-score is coming out to be, let us say, 0.3. Okay, and the significance level is, you are telling, is 5%. Okay, and it is a two-tiled. Then when you calculate this one, what is this? Oh, degrees of freedom, I did not give you. Okay, degrees of freedom is nothing but the sample n is there, right? Right. Okay, and minus 1 is the degrees of freedom. Okay. 19. Okay. Now let us say calculate this. See, the p-value is coming. This is actually coming from the table that I had shown. It's coming out to be 0.767435. See, the result is not significant. Are you reading this one? Yeah. The result is not significant, which means that if the population that you have taken is not actually, in simple English I'm telling you, not in the statistical thing, is not actually the right sample for your test. So I'm taking something like 12, just very large number I'm taking. The p-value is coming out to be this result is very significant. Okay. Because the value is coming out to be like, I'm just taking some more value. Means if t-statistics comes, t-statistics is not a big deal, you can calculate from there. Even t-statistics is coming out to be this one, the probability is coming out to this, and it is 0.05, two-tailed one, because your curve is two-tailed one, and it is significant. Which means it is significant means, that means the population that you are taking is very good. Okay, the population sample that you have taken very good with that particular mean of average. So that distribution is very good for your further studies and analysis. So now this is the actual region. Whatever I have shown is that for that particular t-statistic, whatever you are calculating, that is actually coming out to be that where exactly that p-value is coming out here. It is not only that, I have given an example here. If you are planning to conduct a study, okay, like how many customers would purchase a Samsung S3? So we cannot consider the whole population. So and select a sample. So whether that sample is significant to draw out any conclusion or not, that is what actually this particular p-value is actually helping you. Why are you going to this t-distribution? Just because the number of samples is very less. Out of 20 lakh people, you are taking only 20 people. Because there are 20 lakh beer bottles are there. You cannot test all of them, right? Generally, yeah, as per my friend, he was saying that when you want to test these beers, they have to sip the beer. Means they have to take at least 100 ml, they have to drink it and they have to test sometimes, humans, not chemical composition. So you cannot drink those many beers in order to test that. So yeah, in those cases, this t distribution is really going to help you a lot.
Okay.
Is that clear? So now I just wanted to review about the probability distributions that we have been talking, and by covering different samplings and everything, sampling distributions and everything. So different distributions, there are many distributions that I'm not covering here, but my ultimate objective here is that how do you, whenever you want to really draw out any conclusions, how do you select the right distribution, like normal distribution, t distribution. I'm going to talk about chi-square distribution also when we are trying to test the dependency test. So my point here, Vikrant, is that how much you are going to apply these techniques in your real world data science applications, that I don't know. But having the complete understanding of these kinds of different distributions would help you to actually convey your results in a more meaningful way. Okay, and also whenever any data comes to you, you should be able to discuss with anybody, or you should be able to formulate the data in such a way that by understanding what is the criteria. And now I'm going to tell you, until now Dhawan is making the score or Sachin Tendulkar is making the score, then you can say that okay, I can go to this normal distribution, I can find out the probabilities and everything. But the problem that I discussed that you are going to solve is that whether any transaction that is going to happen next in 1 hour in any SBI ATMs, what is the probability that you would say that it is going to be fraud or not? So how do you say that one? Then suddenly the person asks you, hey, tell me which distribution are you planning to use in this case? Then you should be able to say that no, I cannot use normal distribution, I cannot use t distribution. Okay, I can use binomial distribution perhaps, I can use Poisson distribution perhaps. So what you should have for that particular problem, what is the distribution that I should be able to use? So that is what people say that in the client meetings, they say that okay, which distribution are you using? You should be able to say that no, I'm considering simple Poisson distribution. So what is a Poisson distribution, for example? This is a simple example. Okay, last month the average number of days means it is nothing but you know the mu value, which is the mean value. You know, average number of days that any patient stayed in our hospital is 4 days. So what is the probability that any patient will stay exactly 5 days in the next? This is the question. So here there is not actually, when you are actually going to build a model, it is more complex. I'm not going to do that, but if you have the intuition of which distribution should be used for this problem and how exactly can we calculate these probabilities, then we need only 2 values. One is that average number, that is called mu. Another is that the days that you are actually going to expect, which is something like somebody comes to you and knocks at your door and tells you, Vikram, can you tell me how many number of accidents might happen tomorrow? Then you will ask, okay, can you tell me at least average number of accidents happened yesterday? That means you are using some time intervals here. Time intervals, and also you are talking about only success and failure, which is called binary, which is nothing but fraud is going to happen or not, or whether this customer is coming or not, going or not, giving or not, getting or not. These are all binary. Success and failure, that's what people say. So somebody comes and knocks at the door, okay, what is the probability that Sachin will score a century tomorrow? you will definitely have some complete history of the Sachin's thing against Pakistan or against Bangladesh or against Sri Lanka. You will say that, hey, there is a high probability that he will make century because last time he almost hit 100 with Sri Lanka in those matches. So there is a probability that he would hit that one. So that is how this is actually going to help you Poisson distributions. So number of accidents are going to happen or not, whether number of customers are going to, number of customers are coming tomorrow to my shop. Yesterday there were 10 customers. What is the probability that, not yesterday, I would say average number of average mean. You should give the mean, not on a particular point estimate. So similarly, another example is that the average number of car accidents in national highway is 2. What is the probability that there will be no car accidents tomorrow? Okay, so which is this? If you want to calculate similar thing, you can do here. Okay, Poisson calculator. You can use that one, or you can use with simple Excel also. Okay, Poisson distribution calculator. I'm giving you something like the same example. Mean is 4 and I want to know 5, right? 5 and this is 4. The Poisson probability is actually 15%. Exactly the number of days that a patient is going to stay in that hospital, 5 exactly, and is 0.15. If it is less than, cumulative probability is 62%. If it is less than or equal to 78%, if it is greater than, this is. Similarly, when I'm asking this question here, okay, national accidents is 2, and what is the probability that there will be no car accidents? So no car accidents is 0, and it is 2. Okay, then it is 13.5%. That is what. Okay, so now whenever there are more than 2 car accidents and less than 5 accidents, which is something like Sachin Tendulkar is making the score between 80 to 90, that is how the question, which is something like more than 2 and less than this one. So probability of x is equal to 3 plus probability of x is equal to 4. So I will put it x is equal to 3 and the number of car accidents is still just 2. X is equal to 3, exact 3 means 0.18, this is 0.18, okay, x is equal to 4. It is another 0.09. So 0.18 plus 0.09 is the value that is coming out to be 0.18 plus 0.09, right? 0.09 plus 0.27 means 27 probability that the number of accidents going to happen between 2 and 5 is 27%. No accidents is going to happen is 13.55%. This is how Poisson distributions are those distributions. Okay, generally we use for whether it is a fraud or not, or how many number of days customers the patient is going to stay in my hospital, how many number of customers are going to come to my shop tomorrow. So for these kinds of different problems, we assume these distributions.
Now let's start off with deep learning. So deep learning is a subset of machine learning where it learns through data representations as opposed to task specific algorithms. So we saw that the drawback in machine learning models was that the models are specific to only one particular task. But this is not the case with deep learning models, as these deep learning models are based on the data representations, and these deep learning models are mostly built with something known as deep neural networks. So this is how a deep neural network looks like. So these deep neural networks completely learn the data which is fed to it. So this is the data. So let's see if this image of woman is fed as the data to the deep learning model, then it will completely extract all the features of this data by itself. Again, the difference between ML and deep learning over here is that the extraction, the feature extraction in machine learning is manual. But when it comes to deep learning, the feature extraction is automatic. So the deep learning model automatically extracts all of the features associated with that image. And when new images are fed to it, it automatically is able to tell whether the image is same to this or not. So this over here we have a graph which tells us how does performance vary with respect to the amount of data. So what happens in machine learning is that as we keep on increasing the data, the performance increases only up to a particular threshold. After that, if we increase any more data, there is no increase in performance. So this is another problem when it comes to machine learning. But on the other hand, when it comes to deep learning, the more amount of data you give it, the better will be its performance. And that again is because deep learning is based on learning data interpretation. So the more data you give it, it will automatically learn all those features of the data by itself, and it will be keep on increasing its performance gradually. Now let's look at some applications of deep learning. So speech recognition is one application of deep learning. Now you need to understand that you cannot build speech recognition applications with machine learning. So this is where machine learning fails and deep learning comes in and helps you to build speech recognition applications. Also, another application of deep learning is self-driving cars. So we see over here that the person is just sitting. He is not even touching the steering wheel and the car is driving by itself. So just an amazing application of deep learning. And then we have language translation over here. So this again is a part of deep learning. So over here we are typing something in Spanish and it is being automatically converted into English. So we also have visual translation over here. So over here this text or this board is in some random language, and this app over here which uses deep learning automatically converts this visual into English. So those were some applications of deep learning. Now let's actually understand how does deep learning work. So most deep learning methods use neural network architectures, and that is why deep learning models are often referred to as deep neural networks. So a deep neural network basically has these three models: an input layer, the hidden layers, and the output layer. And the term deep usually refers to the number of hidden layers in the neural network. So traditionally, neural networks only contain 2 to 3 hidden layers, while deep networks can have as many as 150 hidden layers. Now that's a very huge amount, isn't it? So deep learning models are trained by using large sets of labeled data and neural network architectures that learn features directly from the data without the need for manual feature extraction. So all of the input data is given to this input layer, and this input layer automatically extracts the features by itself. Now that data is sent to this hidden layer which performs all sorts of processing tasks, and then the final result is given out through the output layer. So now let's also understand what exactly is a neural network. So a neural network is a computing model whose layered structure resembles the network structure of neurons in the brain with layers of connected nodes. So it can learn from data which can be trained to recognize patterns, classify data, and forecast future events. So the neural network is based on the biological neural network of our brain. So that is why it is given the name neural network. So the layers are interconnected via nodes or neurons, with each layer using the output of the previous layer as its input. So its main function is to receive a set of inputs, perform calculations, and then use the output to solve the problem. Now, as I've already said, these artificial neural networks are based on something known as a biological neural network. So, our biological neural network has dendrites, cell body, and axon. So, dendrites are where the input is taken, cell body is where the processing is done, and axon is where the message is transferred to other neurons. And the same thing happens in artificial neural network as well. So first we give in the data, that data is processed, and then the final processed result is given out as the output. So over here, let's say we train the data with images of cat, and the labels would be either cat or not cat. After that, we give in a new image of a cat, and then we basically try to predict whether the model correctly classifies this as cat or not cat. And since the model has learned the data properly, it correctly classifies this image as cat. Now, there are many ways of knitting the nodes of a neural network together, and each way results in a more or less complex behavior. Possibly the simplest of all topologies is the feed-forward network. So when feed-forward neural network, signals flow in one direction without any loop in the signal paths. And typically, artificial neural networks have a layered structure. The input layer picks up the input signals and passes them on to the next layer, known as the hidden layer. And there can be more than one hidden layer in a neural network. And at last comes the output layer that delivers the result. Now, the first question to pop into your head would be, what is the inspiration behind these artificial neural networks? Well, the answer to that is the biological neural network of our brain. So let us first understand the architecture of a biological neuron. So as you can see in the slide, our biological neuron has these three main components. So we have the dendrite, the cell body, and the axon. These dendrites receive the signals, and the cell body processes these signals, and the axon finally sends out these signals to other neurons. So just like the biological neuron, the artificial neuron has a number of input channels, a processing stage, and one output that can fan out to multiple other artificial neurons. So now let's understand these artificial neurons in detail. These artificial neurons are the most fundamental units of deep neural network. It takes an input, processes it, passes it through an activation function, and returns the output if the condition is met. Or else it will process it again until you get the correct output. And such type of artificial neurons is called as a perceptron. So they are basically like a linear model which is used for binary classification. So as the figure shows, we have x1, x2, x3 and going on till xn as inputs in the input layer. Now, to which we add the weights and the bias that are randomly selected. So here we have W1, W2, W3 going on till Wn as weights. So we multiply these weights with the corresponding inputs and add all the values together, and finally we add bias to that sum. So this final sum is passed through an activation function which finally gives us the output. So let us see this in detail. So here we have three arrows which correspond to the three inputs coming into the network. Now for these three inputs, we have corresponding weights associated with them. So input 1 is associated with a weight of 0.7, input 2 is associated with a weight of 0.6, and input 3 is associated with a weight of 1.4. Now, these inputs are multiplied with their respective weights and their sum is taken. So if the three inputs are x1, x2 and x3, the sum would be x1 into 0.7 plus x2 into 0.6 plus x3 into 1.4. And to this sum, we add an offset which is called as bias. So this bias is just a constant which is used for scaling purpose. Now let us understand the concept behind these weights. So these weights basically determine the relative importance of the inputs. So let's say we have two inputs, humidity and wearing a blue shirt. So here we can see that wearing a blue shirt has almost no correlation with the possibility of rainfall. So that is why the weight assigned to input x2 would be low in order to bring down its importance. Now let us see why do we need activation functions. So consider this scenario where you have two different classes. One class is represented with triangles and the other class is represented with circles. Now let's say I ask you guys to draw a linear decision boundary which can separate these two classes. So is that really possible? Can we draw a linear line which can segregate these two classes? Well, the answer is obviously no, isn't it? So let me tell you guys how can we do this. So we'll have to add a third dimension to create a linearly separable model which is easy to deal with. So the logic is, when you're going from 2D to 3D, you're making your equation non-linear. So with the third dimension, I have introduced non-linearity in our data, which helps in creating a linearly separable model. And in real-world situations, you don't always get linear problems. So you should know how to deal with non-linear problems as well. And this is where activation functions help us to convert the linear equation to non-linear form. So these activation functions bring in non-linear functional mappings between the input and the response variable. Their main purpose is to convert an input signal of a node in an artificial neural network to an output signal. And if we do not apply an activation function, then the output signal would just be a simple linear function. Now there are many types of activation functions, and today we'll be discussing some of the widely used ones. So let's start with the identity function. So the identity function gives out the same output as the input. So no matter how many layers we have, if all the activations are identity functions, then the final output of the last layer would be the same as the input given to the first layer. And the range of the identity function goes from -infinity to +infinity. So after that, we have the binary step function. So this binary step function is usually denoted by h or theta, and it is a discontinuous function. So if the input is less than 0, then the output would be 0. And if the input is equal to or greater than 0, then the output would be 1. And this is why binary step function is used to solve a binary classification problem. So after that, we have the sigmoid function. So the formula for the sigmoid function is denoted by 1 upon 1 plus e power minus x. The sigmoid function basically scales the values between 0 and 1. So if the input is a large negative number, it is scaled towards 0. And similarly, if the input is a large positive number, it is scaled towards 1. Then we have the tan h function. It is a hyperbolic trigonometric function which scales the values between -1 and 1. So one advantage of tan h function over sigmoid is that it can deal more easily with negative numbers. And after that, we have the ReLU function, which stands for rectified linear unit. So this function will give out 0 if input is less than 0. And on the other hand, if input is equal to or greater than 0, then it will act as an identity function and give out the same value as the input. And this ReLU function is the most widely used activation function and is primarily implemented on the hidden layers of the neural network. Then we have the leaky ReLU, which is just a modified version of ReLU. So the leaky ReLU, instead of just completely removing the negative part, it just lowers the magnitude. And finally, we have the softmax function, which is ideally used in the output layer for classification problems. So the softmax function basically gives a set of probability values for each class of the output. And that particular class, which would have the maximum probability, will be our output class. So that was all about activation functions. Now let us learn more about perceptrons. So like we were taught how to behave in certain conditions, perceptrons also require training. So they have a learning algorithm through which they produce the output. By training a perceptron, we try to find a line, plane, or some hyperplane which can accurately separate these two classes by adjusting the weights and biases. So consider this image where we give the dogs and horses as input. So here, after the first iteration, error value is 2 since the horse has been classified as dog and there is one dog which is placed in the horses class. And in the second iteration, the error value is reduced to 1 as it is just the dog which is classified as a horse. And finally, in the third iteration, we get the correct output as the perceptron has been trained well with no error. So all the dogs have been placed in one class and all the horses have been placed in one class. Now let's understand the perceptron training algorithm. So this perceptron over here receives multiple inputs and each input is initialized with a random weight. So after these, we multiply these weights with their corresponding inputs and then we get the sum. Now this input is passed through the activation function, which would give us a non-linear output. So this process until here is known as feed forwarding. Now, if the output which we get is not optimum, we calculate the error in prediction and then go back and then update the weights and bias. So this process where we go from output to the input layer is known as backpropagation. And we keep on backpropagating until we get the desired output. So that was the perceptron training algorithm. Now let's have a look at the benefits of using artificial neural networks. So the artificial neural networks can learn organically. This means an artificial neural network's outputs aren't limited entirely by inputs and results given to them initially by an expert system. So artificial neural networks have the ability to generalize their inputs. This ability is valuable for robotics and pattern recognition systems. Artificial neural networks also help in nonlinear data processing. So nonlinear systems have the capability of finding shortcuts to reach computationally expensive solutions. These systems can also infer connections between data points rather than waiting for records in a data source to be explicitly linked. This nonlinear shortcut mechanism is fed into artificial neural networking, which makes it valuable in commercial big data analysis. Artificial neural networks also have high potential for fault tolerance. When these networks are scaled across multiple machines and multiple servers, they are able to route around missing data or servers and nodes that can't communicate. And these artificial neural networks can also self-repair themselves. So if they're asked to find out specific data that is no longer communicating, these artificial neural networks can regenerate large amounts of data by inference and help in determining the node that is not working. This trait is useful for networks that require informing their users about the current state of the network and effectively results in a self-debugging and diagnosing network. Now, to implement these artificial neural networks, we would need the help of a deep learning framework. So the first question to pop into your head would be, what are the different deep learning frameworks available? So today we'll cover just that. So let's start with TensorFlow. So TensorFlow is arguably one of the best deep learning frameworks that we have today. It is an open source software library developed by the researchers and engineers from the Google Brain team for high performance numerical computation. One well-known use case of TensorFlow is Google Translate. So Google Translate is coupled with capabilities such as natural language processing, text classification, forecasting, and tagging. So TensorFlow basically comes with two tools, TensorBoard and TensorFlow Serving. So building massive deep neural networks could be complex and confusing. This is where we can use TensorBoard to visualize our TensorFlow graph and plot quantitative metrics. And then we have TensorFlow Serving, which is a flexible, high-performance serving system and can be used for rapid deployment of new algorithms while retaining the same server architecture and APIs. So now let's look at the next deep learning framework, which is Keras. So Keras is actually a high-level API which can run on top of other deep learning libraries such as TensorFlow, Theano, or CNTK. And with the help of Keras, we can implement both convolutional neural networks as well as recurrent neural networks. And the best thing about Keras is, model building is extremely easy. It's like stacking layers on top of each other. So next, we have PyTorch, which is a scientific computing framework developed by Facebook. So we can get from the name itself that PyTorch is Pythonic in nature. That is, it can leverage all the services and functionalities offered by the Python environment and also smoothly integrates with the Python data science stack. Another great feature of PyTorch is that it offers dynamic computational graphs which can be changed during runtime. This is highly useful when we have no idea how much memory will be required for creating a neural network model. And the next deep learning framework is DL4J. So unlike deep learning frameworks which we saw till now, which were all based on Python, Deep Learning 4J is a deep learning programming library which is written for Java and the Java virtual machine. And the biggest advantage of DL4J is it includes inbuilt integration with Apache Hadoop and Spark. So it helps in getting state-of-the-art results on image recognition tasks. So it shows matchless potential for image recognition, fraud detection, text mining, parts of speech tagging, and also natural language processing. And finally, we have MXNet. So MXNet is a deep learning framework developed by Apache Software Foundation specifically for the purpose of high efficiency, productivity, and flexibility. And the beauty of MXNet is that it gives users the ability to code in a variety of programming languages, such as Python, R, Julia, and Scala. This means that you can train your deep learning models with whichever language you're comfortable in without having to learn something new from scratch. And this deep learning framework is known for its capabilities in imaging, speech recognition, forecasting, and NLP. So when you hear the term TensorFlow, the first question to pop into your head would be, what exactly is a tensor? So in TensorFlow, data is represented in the form of tensors. Simply put, a tensor is a multi-dimensional array in which data is stored. So you can consider these tensors to be the building blocks in TensorFlow. Now, these very tensors are given as the input to the neural network. So as I've said, a tensor is nothing but an n-dimensional array. So the number of dimensions used to represent the data is known as its rank. So if a tensor has just one element, in other words, if it has just magnitude and no direction, then its rank will be 0. If a tensor has magnitude and direction in one plane, then its rank will be 1. Similarly, if a tensor has magnitude and direction in two planes, then its rank will be 2. And this goes on higher up the order. Now, TensorFlow, as the name states, is a combination of two words, tensor and flow. Here, the data is stored in tensors, but the execution is done in the form of a graph. So this is not like your traditional programming where you just write a bunch of lines and everything gets executed in sequence. So first, you'd have to prepare this computational graph, and then this computational graph is executed inside something known as a session. Now, in this computational graph, all the mathematical operations are depicted inside the nodes, and all the tensors are represented on the edges. So the entire computation process is done in two stages. In the first step, the code is depicted onto the computational graph, and in the second step, a new session environment is started and the graph is executed inside this session. So that was all about the computational graph. Now let's look at the program elements in TensorFlow. So we have three program elements: constant, placeholder, and variable. So let's start with constants. So constants are program elements whose value does not change, or in other words, the value is fixed. So let's head on to Jupyter Notebook and work with these constants. Right, so my first task would be to import the TensorFlow framework. So I'll type import TensorFlow as TF. I'll click run. So let me just wait till the import is done. Right, so we have successfully imported the TensorFlow framework. Now, as I've said, let's go ahead and start working with the constants. So let me just type in constants over here. So I'll create the first constant and name this constant as con1. Now this is how we can create constants in TensorFlow. So I will use this TF and then put in a dot and then type in constant. Now inside this, I will give the value of the constant. So let's say the value is 10. So this is an integer type constant. Now similarly, I'll also create a floating type constant and I'll store this in con2. So I'll type TF dot constant and the floating value would be 3.14 Now after this, I'll create a string type constant. So again, this would be tf dot constant, and the string which I'd be giving would be this is Sparta. And finally, we have a Boolean type constant, and I'll store this in con4. So this will be tf dot constant, and let's say the value is false. Now I'll run. Now let me print all of these values. So I'll use the print function, and then I'll go ahead and print all of these values, con3, con4. Right. So we see that this first constant is a tensor of type integer. This second constant is a tensor of type float. This third constant is a tensor of type string, and this fourth constant is a tensor of type Boolean. Now we see that we only have the data types of all of these tensors, but we don't have their values. This is because, as I've already told you guys, we have to create a computational graph and then execute that computational graph inside a session. But till now, we have not started our session. So let's go ahead and start a session first. So I'll type sys equals tf dot session, and I'll hit run. Now I will run all of these inside this session. So I will type sys dot run, and let me go ahead and run all of these, con1, con2, con3, and con4. So this time we have the values of all of these tensors. So the value of constant 1 is 10, the value of constant 2 is 3.14, the value of constant 3 is this is Sparta, and finally the value of constant 4 is false, right? So first we'd have to create all of the constants, then we'd have to create a session, and inside this session we'd have to run all of these constants. Now let me go ahead and perform some simple operations on all of these constants. So let me just type in operations over here. So I'll do a simple addition operation. So I'll type addition over here. And let's say the value of the first constant is 20. I'll put a plus symbol, and then I'll take in the next constant, and the value of the second constant would be 30. So I am basically adding two TensorFlow constants. The value of the first constant is 20, the value of the second constant is 30, and I'm storing that result in addition. Similarly, I will multiply these two constants now. So multiplication tf dot constant. So I'll give the value of 20. Now I'll put the asterisk symbol, and then this would be tf dot constant of 30. So this time I'm multiplying these two values, right? So I'll hit on run. So now again, if I'd have to see the resultant addition and multiplication values, I'd have to run these two inside a session. So I'll type sys dot run, and then put in these two values over here, addition and multiplication, right? So we see that 20 plus 30 gives us an addition value of 50. And similarly, when we multiply 20 with 30, we get a result of 600. Right. Now, so this was basic operation with scalars. And we already know that tensors can have higher dimensions. So let's go ahead and perform addition and multiplication with these higher dimension tensors. Right. So again, I'll just put in addition over here. And I will take in the first constant, and inside this, I will give in a list of values. So let's say I will take in 1, 2, 3, 4, and 5, and I will add this list with the next constant. And this time, the second constant has the values of 5, 4, 3, 2, and 1. Similarly, I'll also multiply. So multiplication equals tf dot constant, and this will have values, let's say the same values, 1, 2, 3, 4, and 5. Let me put a comma over here. Right. Now I'll put the asterisk symbol. Again, I'll type tf dot constant, and I will give in the list of the values 5, 4, 3, 2, and 1. Now I'll hit run. Again, I need to run these two inside a session. So sys dot run. Let me put in addition over here. After that, I would also need the multiplication value. Right, so this is our result. So when we add 1 plus 5, we get 6. When we add 2 plus 4, we get 6. Similarly, when we add each of the corresponding elements with these elements inside the list, we get all of the 6s over here. Now let's take this multiplication result. So over here, when we multiply 1 with 5, we get 5. When we multiply 2 with 4, we get 8. 3 cross 3 gives us 9. 4 cross 2 gives us 8. And again, 5 cross 1 gives us a 5. So this was addition and multiplication with respect to lists. Now let me also do a simple operation on strings. So let me take in the first string and name it as str1. So this is a constant. So tf dot constant. And let's say I type over here, I love, and then I give a space. Now I will take in the second string, which would be str2. And inside this, and again, this would be a constant. So tf dot constant, and the value of this constant would be TensorFlow. Right. Now I will run this and let me execute this inside a session. So sys dot run of str1 plus str2. So the result which you get is I love TensorFlow, right? So the first string is I love, and then there's a space, and the second string is TensorFlow. So when I add these two strings, the resultant is I love TensorFlow. Right, so that was all about constants. And then we have placeholders. So when it comes to placeholders, we don't have to provide an initial value and can specify it during the runtime. So this allows us to build our computational graph without needing the data. And this is how we can create placeholders. So tf.placeholder is the syntax. And inside that, we just give the data type of the variable, which we will substitute later on during execution. So let's head back to Jupyter and work with these placeholders. So let me just type in placeholder over here. So let me create my first placeholder. So I'll name that as A and tf dot placeholder, and this would be of integer type. So tf dot int 32. Now I will create another variable which would be b, and the value of b would be actually a cross 2. So let me run this. Now I will run these two inside a session. So sys dot run, and I want to see the result of b. So I'll put in b over here. Now, since we know that a placeholder takes in a value during runtime, so this is when I'll feed the value to this placeholder a over here. Now to do that, I would have to create something known as a feed dictionary. So feed dict equals, let me create a dictionary over here. So it would be a, and the value which I'll be giving to a would be, let's say, 5. Now let me run this and let's see what do we get. Right. So during the execution time, I have assigned a value of 5 to a. And when we multiply this 5 with 2 over here, we get the value of b, which is 10. Right. So all of this is happening during runtime because with the help of a placeholder, we can assign it a value during execution. Now, similarly, let me go ahead and give a list of values over here. So instead of 5, let me give the list of values 1, 2, 3, 4, and 5. Now I'll run this. So over here, 1 cross 2 gives us 2, 2 cross 2 gives us 4, 3 cross 2 is 6, 4 cross 2 is 8, and 5 cross 2 is 10. So you get an array of values during runtime. Now similarly, let me also create a placeholder for strings. So I'll type string placeholder over here. So now let me create this variable and name this as string name, and this would be your placeholder. So tf dot placeholder, and I am taking in a string. So tf dot string. Right. Now let me create another string over here. So the name of this string would be my name, And let's say the value of the string is I am. Alright. Now let me run this and I'll execute this inside a session. Ses.run, and I want the result of my name when I add it with respect to string name. Now let me also create a placeholder for strings. So I'll just type string placeholder, and let me create the first placeholder. So I'll name that as str1 name, and since this is a placeholder, tf dot placeholder, and I will be giving in a string during execution time. Now I'll also create another string value over here and name that to be my name, and the value of this string is I am, and then I'll give a space. Right, so now I'll hit run and let me execute this inside a session. Now let me also create a placeholder for strings. So this will be string placeholder. Right, so let me create this placeholder. I'll name this as str name, and since this is a placeholder, I need to use tf.placeholder, and I will be assigning a string to this during execution time. Now I will also create another string which would be my name, and this would be equal to I am, and there's a space, and I will be adding this with str name. So let me hit run. Right, now I'll execute this inside a session. So for that, I'll type ses.run, and I want the result of my name. So I'll just put in my name over here, and then I'll provide the feed dictionary. Feed dict equal to, let me put in the dictionary over here, and I will assign the values of str name over here. Right. So the values of str name would be Sam, Bob, and Charlie. Now let me hit run and let's see what do we get. Right. So what we are basically doing is we are adding this with the placeholder value over here, and we are giving the values during the execution time. So I am Sam, I am Bob, and I am Charlie. Now these three values are coming from this feed dictionary during the runtime. Right. So this is all about placeholders. And finally we have variables. So a variable is just a program element which allows us to add new trainable parameters to the graph. And this is the syntax to create a variable. tf.variable, and then we give the value, or we initialize the value, and then we specify the data type of that variable. Right, so let's head back to Jupyter now. I'll just type in variables over here. Right, so let me create my first variable, and the name of that variable would be var1. And we can create a variable like this, tf.variable. So guys, you need to keep in mind that this V over here is actually capital. Right. So now after this, I would have to assign a value to it. So let's say I assign this variable a value of 20. And this is of integer type. So tf.int32. I'll run this. Now another thing to be kept in mind is whenever we are declaring values in TensorFlow, they have to be initialized. So this is how we can initialize all of the variables. So we have something known as global variable initializer. And when we invoke this function, all of the variables which we have declared would be initialized. I'll hit run. So now let me execute this inside a session. So ses.run of init, and I have initialized this variable over here. Now let me also go ahead and run that variable, ses.run var1. Right, so we have the result of var1, which is 20. Now since this is a variable, the value of a variable can be actually updated. So let me go ahead and update the value of this. So I will name this as updated var1, and the function would be tf.assign. And inside this, the first parameter would be the variable which I'd want to update. And after that, I need to give the value to which I'd want to update this. So I want to make this value of 20 to 25. Right, now I will run this. So now this is actually a variable. We can actually update the values. So let me go ahead and do that. So the name of the updated variable would be, let's say, updated var1, and the function for that would be tf.assign. And this takes in two parameters. The first parameter would be the variable which we are supposed to update, and the second parameter would be the value to which we are updating it. So I want to make this 20 to 25. I'll hit run right now. Let me run this inside a session. Sys.run, and I need to pass in the variable which would be updated var1. Let me make it small v over here. I'll run this. Right. So initially the value of var1 was 20, but we have updated it and made its value to be 25. Now let's also go ahead and create a small linear model. So let me just type in linear model over here, and this is how our linear model would look like. Wx plus b, where w and b would be variables and x would be a placeholder. Right, so let me start off by creating w. So w is a variable, so w would be equal to tf dot variable, and I am initializing it with a value of, let's say, 10, and this is of integer type. So this would be tf.int32. Now similarly, I will also assign the value for b. So b is also a variable and its initial value would be 5, and this is also of integer type. And finally, we have x, which is a placeholder. So x is equal to tf.placeholder. And since placeholder does not actually take an initial value, it just takes a data type. So the data type is again tf.int32. So I'll run this, and now what I'll do is I will multiply w with x and add b to it. So the equation would be w cross x plus b, and I will store it in a variable and name that variable to be linear model. Right, so this is w cross x plus b. I'll run this. Now again, if I have to execute this, I have to run this inside a session. And since also I have created two new variables, I'd have to initialize them first. So init1 equals tf dot global variables initializer. I'll hit run. So now I will create a session. So sys.run, and I will execute init1 first. So I have successfully initialized these two variables w and x. Now I can go ahead and run this linear model. Sys.run. Now I would want the result of linear model. So linear model, and then I will use the feed dictionary. Now inside this feed dictionary, I would have to assign a value to this placeholder x. So x equal to, let's say I give a list of values over here, and the list of values would be 1, 2, 3, 4, and 5. Now I'll run this, and let's see what do we get. Right. So if the value of x is 1, we get 15. So this basically means that 10 into 1 plus 5, which is 15. Now after that, if the value of x is 2, so this would mean 10 into 2 plus 5, which is 25. Similarly, if x is 3, that would mean 10 into 3, which is 30, plus 5 is 35, right? And same is the case for 4 and 5.
So let's go back in 1980s. There was this crazy guy called Geoffrey Hilton. He proposed that we could mimic somehow the mind, how a human mind works, and we can mimic the way it works, so that we can also try to make a thing out of it, so that whatever our mind is doing artificially, we can also do that thing. So he proposed a paper, and everybody said that, Hilton, listen, you are doing something wrong. This is not what is right. And everybody, didn't like the way things were going on. But after 20 years, almost in late 90s, around 1999, he again came up with this paper. He brought in his paper, but this time with a proof, and he won a contest that is called ImageNet in 2004. This time he came back and everybody had to listen. So we were at 2004 when he won the ImageNet. I have two people who I've already told that ImageNet is ImageNet is actually in a competition. It is held by a joint vision of Stanford plus Princeton University. These guys come up and they downloaded a corpus of images. Now they have a very large collection of images, around 1 million images, around covering 1,000 categories. They have. You can just click on explore and you can see this tree around here. So what you have to do is that you have to make a model out of it so that you can classify the images. So people used to make, hand coded, classifiers, and they were working. But at some stage, they had to fail because like now, let's say that fish, you are trying to detect a fish, but fish cannot every ways be in the same manner in which you are building the hard coded thing, right? Or let's say that you are trying to detect a cat, and then you say okay, top right if it is an eye, top left is an eye, and then it's a squishing mouth, then it's a cat, right? But now the cat face will not always be available to you in that particular fashion, right? It might be a top view, a side view, a bottom view, any view might come up, and at that time people used to fail. But in 2014 2004, when Geoffrey Hilton came with his paper, the competition he won was with 94% accuracy, and that was never achieved, and it surpassed the human accuracy also. So that was where, when people started listening to him and he came out, then he proposed slowly that okay, that this is what I think, that artificial neural network is nothing but that we are trying to mimic what is happening in our own mind, right? So if I say that what is the theory, what Geoffrey said about neural network is that he said that artificial neural network is a computational model that is inspired by the way biological neural networks in our brain human information possesses, right? So I mean, most of you know this thing, that that our nervous system is made up of axons and okay, I'll show you the photo, that it is made up of axons and brains. I show you the photo and you might be able to. Okay. See, this is actually how a human nervous system is. Most basic diagram, and everybody of you might have seen this. So how this works is that there is a exact replicate copy of this. If I copy this, and you can attach it back here again. So these are the axon terminals that are connected to dendrites again, and this is how it flows. So let's imagine that your fingertips where you can have your dendrites, and these are like small particles again of your pure neuron connected to your brain. So this is how there are like millions of these connected, and they're connected. If I take this, okay, one more feature of Jupyter Notebook that you already know, that you can add a markdown language. So what I do is I do escape M and then I'll write HTML inside it. So I write img src is equal to, right? This is how you can write your, in this you can add that this is, right? Let's now look at it one by one, slowly. Okay, so these are called dendrites. These dendrites are the one who are like septicles. These are the one who are responsible for catching all the information and sending it forward to the nucleus. Now nucleus processes this thing and it sends to this axons and again throws it out to the axon terminals. Now imagine again that this is this copy, this is again replicated here, back here. So you can imagine that these dendrites are connected to these axons, right? And then they're flowing. Now imagine, let's say that you touched a very small, a very hot glass, right? The moment you touch the hot glass, the dendrites at your fingertips, they sense that something is very hot there. So they send this information to your brain, okay, that this is hot. Now imagine this dendrite is processing the information, sending it to terminal, terminal to dendrite, and dendrite to terminal. It goes on until it goes to your brain. Now the brain says that this is very hot. You should remove your hand. Okay. Now this process is again flowing back to the dendrite, the original dendrite here. Let's say that this is the original dendrite here. Okay, and your brain will say that this is really hot. You should remove the fingertips from the glass. And now when I'm saying that this information is going on, believe me, from your fingertip to your brain, there are like millions of these dendrites who are connecting and flowing this information. Now again, a process of reversal information flow is going on, and this time your brain is sending a signal that remove your hand from the glass, and this is again going back to the fingertip, and then you release your hand from the glass. But in real life, when you touch the glass and when you remove it, how much time do you take to remove this? It's just some nanoseconds, right? I mean, less than. Your reflexes are very strong. You just remove the hand out. But imagine what is happening when you do this. Your brain is not, your hand is not taking the decision of removing that. You might think that, okay, my hand is taking the decision to remove that. No, the hand is like a slave of brain. So every body part of ours is like a slave of a brain, right? Whatever we are doing, it is sent by the brain. The information is sent by the brain, and then it's doing. This is how your body works, right? So it's a slave of your brain, and the brain sends the information, remove or attack, whatever it is, then it reacts. But it's really fast, right? Similarly to this way only, Joffrey said that, okay, this neural network, this is how even I will also build a neural network. Now I'll show you how a basic neuron looks like. Here it is. This is the image. You write it. Basic neural. It's not a network, it's just a neuron. But this is an artificial neuron. So Joffrey said that, okay, this is how I propose. Let's do the following. Let's say that your hand is not doing anything. Your dendrites or your nervous system is not, this basic neuron is not doing anything. Imagine that it's doing nothing. But it is reciprocating the information. But how it is reciprocating the information? By activating itself. So when you touch a hot glass or something, it activates itself, and then only it's transmitting the thing, right? Now imagine if this would have not activated, it would have sent nothing, right? So this is also playing a very crucial role. See, brain is sitting somewhere like a million neurons far, right? He doesn't know what is happening to your hand until and unless this neuron is sending the information. So what information will the brain process if it doesn't have the information? So these guys are very much responsible for sending the information, and they send the information only when they're activated. So this dendroid will become, this nucleus will become activated, then only it will send the further information. And see, there is also a basic kind of a information processing is going on. It doesn't mean that these dendrites are just sending blank signals. See, I'll tell you more depth inside. See, these dendrites, they collect the information. These dendrites, they collect the information and they send it to the nucleus. Now, nucleus thinks that should I process this and send it forward? Yes or no, depending on that, nucleus send it further. Right. Now, how is nucleus sending is? Nucleus has a particular threshold value. After processing it, it says, okay, if I am activated by that processed value, it will send it further. If not, it will keep it to itself. So this is also how a basic artificial neuron, when I say artificial, it means that the one that we are building right now in deep learning, right? This is also built. Now what is happening is that imagine this round thing that you're seeing is the nucleus. This thing is a nucleus. but this is a nucleus, right? And these are the dendrites to it. This one, this x1 and x2. This is the way of thinking how we are intimating, and this is the tail, axon tail, and it is again connected to again a neural network. So it's a chain of multiple neurons going on. Now if we go mathematically, what is happening inside this? It is nothing but a linear combination of all the inputs with a bias. I just like went to the very human biological way and I just sent a sentence. It's doing nothing. What it's doing is that it collects the input. Let's say that you have two inputs. Let's say that you have two inputs, x1 and x2. These are your two inputs. Now to every input, you will give some weightage to it. Let's say our weightage is here. This weightage is called W1 for x1 and W2 for x2. Correct? Now what I said, it is trying to build a linear regression, right? So what it does, it multiplies the weight of the corresponding input to itself. So W1 x1 plus W2 x2 plus it adds a bias to it. Now you will ask what is a bias? I'll say imagine that there is another input called x0. There is another input called x0 and the value of x0 is equal to 1. The value of x0 is equal to 1 and there is this weight associated to it that is called W0, right? So this bias is added to it and then you add this. That's it. You plus all these values, multiply plus all these values and you give this output to something called y. This is all a neuron does. Make sense? Any questions? Please ask. It's very important that you build the intuition that what is happening here. So this is the most basic, it's the smallest part of a neural network that you can pick. And the smallest part of a neural network is doing this. Like it takes all the inputs that are coming to itself, give them some weightage, multiply the weightage to the corresponding input, and then sum all these, and then add a small bias to it also. That's it. Over. How is this weightage and bias being introduced? That who is okay, x1 and x0, x2 and x1, I can say okay, someone is giving to us the input that what is the temperature of the glass. Let's say it is coming from the outside environment. X1 and x2 is coming outside, but who is giving this w1 and w2? So okay, so the answer is that in a artificial neural network environment, at the very first instance, they are randomly allocated to it. So see, you all guys have learned ML, right? So how does ML work? ML says that I know the output and depending on the output, I have to give some weightage to these inputs so that they can give me the output. Now you know that the output will be y. You know that the output is going to be y, right? Now you want to make some equation where y is equal to x1 plus x2. Okay, and now this is not the correct answer, right? X1 and x2 will never give you y1. So what you do, you add some w1 here, some random w1, and then here random w2. What it will do, it will not give you the answer. W1 and W2 will not give you the answer. You will do some corrections again in W1, W2 and ultimately it will give you Y. So this is what is happening. At the very first instance, you will take W1 and W2 as random. First is that does the process is reverse? Yes, it also reverses itself. The model will not only go from x1 x2 to y, but it can also come back from y to x1 x2. And second, let's say that he's asking Shivam, does it process recursively? Recursively, just imagine that there are like thousands of, now I'll draw it again to show you. This is just a very basic one, right? Now imagine what is going on here is that this is the small that you saw, right? X1, X2, and it is giving some Y. Now here it is again, there is a X1, X2, and then this is giving me Y. Now this Y and Y1 will become an input for some other cell. And then it is giving here. So are you imagining how will it look like? This becomes this, and this will become again an input for some other. So these are like connected. These are like throwing information from one to another, one to another, one to another, right? But this is how it works. This is how a small network looks like. And this is If I write down the theory, it says that the basic unit of computation in the neural network is a neuron, or often called as a node, right? And came right it very right. This is called a node, or you can say it a unit also. So it receives input from some other node, from an external sources or external source, that I was saying right also, right? The X1 and X2 might be an input from another neuron, or it might be given to you directly from the external environment, right? Computes the object each input has an associated weight to it, which is assigned on the basis of its relative importance to other. The node applies a function f to the weighted sum of this input, right?
So we'll be having the students' data, so whatever the marks, based upon their marks, so we have to decide the grade. So we have to adjust whether the student is passed out or failed. So we will be adjusting the marks based upon the grade.
This is a very hard-coded problem, I think. But let me take an example that you're working on a machine learning problem where you are trying to find out the loan defaults, right? That in bank you have multiple people who take the loan. Now the bank wants to know how will this person repay the loan or not, right? Now you already have a historical data with you. The bank will give the data to you. Okay, let's say that this is the data with you. So in that data you already know that if this is the feature of a person, this is the credit history of the person. Based on that, they will also give you that, okay, he paid, he didn't paid, he paid, didn't paid, right? And based on that you adjust your model, right? So there also you have a x and y with you. You will have your x and y with you at that particular instance also. Okay, so everybody gets this this function thing, right? That's how this function is working. This function f is called the affine. So the f function that you see, this is called the affine thing, and it's doing nothing, right? You saw that it's doing a linear thing here, just multiplying the weights the corresponding x1 x2, and you might now consider x1 x2 as the importance feature. So the more important x1 is, the more higher the value of w1 will be, right? The more lower the value of w2 is, it means it doesn't make much sense to y. So everything that we will now talk will be with respect to y. So the x2 is not making much sense to y, so the value of w2 will be very less. So let's say y is dependent on x1, so this value of w1 will go more higher, right? And then your bias you already have, this is a static thing, right? Because the x not associated to it is equal to 1, right? Let's now go back at what further happens here. Now you get the y out of here, right? Now this y thing is a little, you have got the answer, and this might be greater than 1 or less than 1 also, right? So there is no measure of this answer. It might happen that w1 w2 is very small. Let's say w1 w2 are very small, then the value of y might be almost equal to 0, right? Or let's say that w1 value is very high, like very high, so the value of y might also get very high, right? So now this might bring some bias, this might bring some ambiguity to our model. This y might be sometimes, next to infinite, it might be equal to infinite, or it might also be equal to 0, right? Depending on the variables. And we don't want that. We want our y to be in some particular range, right? We want our y to be in some bonded weights, right? Then comes next guys whose names are activation functions. Activation functions. Now we got to know that how this y is made, right? How this y is ultimately achieved. Now to adjust the value or squeeze the value of y, we need some other thing, right? We need something that can control the value of y, and these are called activation functions. Now what activation functions does is that they will take the value of y and they will squeeze the value of y in some certain range. What they will do, they will squeeze the value of y in some certain range. So we have multiple, let's say we have a step function, we have a 10h function.
Shivam, Sanjay said, can you please come again about this activation function? Not getting you properly.
So let's come back what this activation function is. So you understand that the value of y, how it is calculated, right? It is now totally dependent on w1 and w2. If the value of w1 and w2 is very less, I mean 0.0000, or let's say 10 to the power minus 23, then the then the y is going to be very less, right? Next to 0. Or let's say that the value of w1 and w2 is like 10 to the power positive 48 plus 48. So this might be very high. The value of y might be very high. There might be no standard to control this value of y, right? Mathematically, there is no, this value can go from negative infinite to positive infinite, right? And this is not a very good range to get about a particular output, right? So what we do is we introduce something that is called activation functions. Now what this activation function will do is activation function will make sure that your output that you have got y should be in some particular range. What it should be? It should be in some particular range. Now how do you decide that who is going to be in what range, and how is that range called? See, the activation function, if I ask you mathematically, the mathematical purpose of introducing an activation function is to squeeze the value of y between some variable called 0 to 1, right? Majority times. So the purpose of activation function is to bound the y in some range, right? And this range might be -1, say 1, 0 to 1, or sometimes 0 to infinite. It might be different things, right? I was at this thing that mathematically the value is to be squeezed between 0 to 1, but if I talk to you about statistically why I am doing this is, now imagine till here, till this particular range, your model is a linear model. Everybody agrees with me, right? This is a linear model. Nothing non-linear have been done till now, right? All the things that we have done till this step in this circle, everything is linear. There is no non-linear thing, right? Now linear things are a little bad at classifying things if there are more than 3 classes, right? If I ask you, can you, if let's say there are 3 classes, one is like crosses, right? One is circles, right? And one is some triangles. Now can you make a single line and can divide these 3 data? No, right? If it would have been 2 classes, you might have drawn a single line and you might have divided the data into like 2 classes, right? But if it is a 3 class data, how will you divide this? You have to ultimately make a triangle kind of a shape, or this kind of a shape, right? Then only you can divide the divide this thing, right? So I'll show you a photo also. Let's say, let me give you an example, then I'll show you how this works. Okay, can any one of you, let me hide it here. Now this is this thing in front of you. Everybody can see your data. There is this red dots and there is a blue triangle in the screen, right? Everybody can see this. Now can you make a linear model that can separate these two things? This can only do in a 2-dimension, right? But if I say you that, okay, see a magic, anybody wants to try this thing? How will you do? No? Okay. What I'll do is I'll remove this now. So what I did was I introduced a 3rd dimension, and now I could easily separate by introducing a hyperplane here, and then I can say, okay, something that is above this hyperplane is red, something that is below this hyperplane is blue. Makes sense to everyone, right? So this is why we do activation function, to make sure that we want to classify things more better, to make things more clear. We do an activation function. So mathematically, why we are doing activation function? Because we want to squeeze the value of y somewhere. If I talk statistically, what we are doing, we are introducing non-linearity in a linear model, because linear models are very much not capable of classifying things in when the number of classes increases. So now we saw that as soon as we increase the linearity, if we increase the dimension in the data, if we introduce non-linearity in the data, what it is doing? It increases the chances of making a linear separable model, right? Right. So if I say in three times, first mathematically squeezing the y. Second, if I say graphical thing, why we are doing this? Because we want to introduce a new dimension. And statistically saying why we are doing this? Because we want to introduce non-linearity inside it. Now you might be asking what these functions do. It's a very good question. I have activation functions graphs. See, this is how a sigmoid looks like, a tanh looks like, a ReLU looks like. And see, everybody is bounding. So see, sigmoid is bounding between 0 to 1. Tanh is bounding between -1 say 1. ReLU is bounding from 0 to infinite. So it lets go everything that is going above. Yes, we have step function also. Step function says that you can go, if something can be only have two things, either 0 or 1. If something is negative, it goes 0. If something is positive, it goes 1. It's a step function, sigmoid, tanh, ReLU. So there are multiple things. These are doing the same thing that we want to do for a activation function. ReLU, you can understand that if something is negative, it says it's a 0. And if something is positive, it lets go whatever the value of this is, right? I write the variables in here. This is what brings in. Sigmoid is this, tanh is this, and ReLU is this, right? What is the maximum of 0 to 1? That value it will take, right? This is what activation functions is. Let's say that you have this thing called y1 and y2, right? And now the value of y1 and y2 is very large, right? So this y3 will become ultimately also very large, and this y4 will become also very large. And we know this is not the exact thing. We always expect our output to be in the form of 0 to 1 if it is a classification problem, and if it is regression problem, then it will always be in some range from 0 to 1, right? You all agree with me, right? In machine learning also, whenever you did a classification problem, you one hot encoded the problem. So you never said that the output is going to be a C80 cat or DOG dog, right? You always said that, okay, if 0 comes, this is cat, 1 comes, then it's a dog, right? You did the same thing, right? In machine learning also. Or if it was a regression problem, then you always regress a value from 0 to 1 with a multiplicative factor, right? So this is what is happening here also. The y3 and y4 ka value can never go up beyond a limit. To control that limit, we have to squeeze the value. And see, when I'm saying squeezing the value, that is in mathematical format. But if you see in statistically, what we are doing is that we have to introduce non-linearity into the data, right? Because linear data are not, linear equations are not good in separating non-linear data, right? Right? This becomes separable. You see, now it is very much separable just by a simple hyperplane. Okay, so coming back to a feed forward neural network. So see, this was the input x1, this was input x2, and now what a feed forward neural network expects is that a hidden node should be connected to all the inputs. What does it expect? It should be connected to all the inputs that are in the previous layer. So this is, let's say this is called layer, input layer. Wherever your hidden neurons, this is called hidden layer. And your outputs are here. This is called a output layer. Now when you are building this feed forward neural network, your responsibility is just one, that whichever neuron you're standing, let's say we are standing on this particular neuron, let's say this neuron, this neuron. Now the only thing that this, okay, this is not a neuron exactly, oh sorry, let's say we are standing on this neuron. Now the responsibility is just this, that if you go to the previous layer, The previous layer is the input layer. All the neurons in this layer should be connected to this hidden node, right? Similarly, output 2 also expects the same. You go to the previous layer. So this is the output layer. What is the previous layer? Hidden layer. So all the neurons in the hidden layer should be connected to the output node 2. Make sense? Or if I make it more easily, let's say that whichever neuron you are standing, just go to the previous layer, and all the neurons in that previous layer should be connected to this particular neuron, right?
What is this layer signifying here?
Correct. Very good question. So what you are doing is you have stacked all your neurons one by one in some format, right? So all your input neurons. So see, whatever you made in this above statement here, in this above thing here. So this x1 and x2, this is x1, x2. This might be x3, x4, x5, x10, right? So these x1 and x2s are what? Inputs, right? So what you do is you collect all these and you just put it inside a layer here. This becomes a hidden layer. Now you will not only have one neuron, you will have multiple neurons, right? So what is happening is that what you have done is, rather than having just one neuron, what you have done is you have made multi-neuron system. So this is a feed forward multi-neuron model here. So what you are seeing in the previous photo, that is the image that I showed you, that was just a multi-input single neuron, but now you have multiple neurons. So what you do is you stack these neurons in this layer, then you can have, so this is just an example. What you can do is you can have an image like this also, multi-layer. Okay, so now if you see Tarun here, so what is happening is these are your inputs x1, x2, x3, x4, right? This is your input layer. This is your hidden layer 1, where all your affines and activations are happening, right? This is your layer 2. Again, all the affines and your activations are happening, and this is your output layer. Hidden layer HL2. This is HL1, and this is input layer. So what is happening is that, let's say this is called neuron 1, that Y1 just marked. So let's say this is N1. This is called neuron 1. Now what is happening is that this neuron 1 is connected to X1 also, X2 also, X3 also, and some bias also. So what is happening here? This affine will be happening here. What will be happening? It will be here that W1 X1 plus W2 X2 plus W3 X3 plus some bias B will give some output called Y. And here you will be having a very small activation function also residing here, right? Similarly for this N2 also, this N2 is connected to all the inputs, right? This N2 is connected to all the inputs. This N2 is connected now. It is connected to this, to this, to this, and this. Now N2 will also do some affine and then bring some activation, small activation function here, and it will also give some output called Y2. Similarly, Y3 will also be here. Now this Y1, Y2, Y3 will become input for these neurons. Let's say we call this neuron as N4. Now this N4 is connected to this, this, and this. Similarly, again affine, and let's say it gives the output called O1. Now O1 is here. Similarly, O2 is here. Now this O1, O2 will also become input for this. Let's say we call it O1 right here, right? This is O1. Y4. Let me remove this. Sorry. We were here that there is this some output called Y4, and there is some output called Y5, right? Now what is happening? Y4 and Y5 will become output for this O neuron, and they will give some output O1 and O2 similarly here, and then you will have outputs, right? This is how a multi-layer neural network works.
How will we know that how many layers?
Correct. This is one of the very good questions that first of all, how many layers do you want? This is the layers that you have, L1 and L2. Now you might have another question that, okay, in one layer, how many neurons can I fit? So there are currently 4. I can fit 5, 6, 10 also, right? I can fit 10 neurons also. So who is going to tell me that how many neurons and how many layers? This is what exactly what data science you are going to do here. I mean, everything is built for you. This neuron thing and this all thing is this is already built for you. The only thing that you have to do is that you have to come up with the optimal number of neurons and optimal number of layers for each neural network. And now who is going to decide this? Very good question. This is you who is going to decide this. And how? Okay. So first answer is that hit and try, that everybody will tell you, and I am also telling you that the first approach is hit and try. Let's say that you are doing a very new problem. I mean, you don't have any idea, you are just doing. So one thing is that you'll go with the hit and trial model. Second is that as soon as you become a little bit expert, now you start learning, okay, this is how my model is reacting to this particular neural network layer. Then you see the model capacity. Okay, so let's say that, so see, this is a very good question, but this is also an advanced question. Now see, when this, let's say this is called neuron 1. When this neuron 1 is connected to x1, x2, x3, there is a weight called W1, W2 on this layer, and W3 here, right? So, but when this N2 is connected, this is not W1, W2, W3. There is W4, W5, W6. So when this x1 is connected to this N2 here on this line, there is another weight, that is W4. So imagine how many weights are there for 3 inputs, 3 neurons. There will be 9 weights, right? Now there are 9 weights. Now imagine here again that you have 3 inputs and 2 outputs, 3 to 6, then you have 6. So 9 plus 6. Then again here 2 to the 4. So you will have 2 plus 4. So 9 plus 6 plus 4 is 19. So 19 weights are there, and then you will have 3 biases here, right? So 19 plus 3 is what? 22. So for the small neural network, you have 22 values that you have to predict, right? Because y1, w1, w2 we have taken as random, right? And biases are also random. So you have to adjust them in a very optimal way so that you can get the output as y. So now imagine that you have 22 things that you have to train here. 22 things that you have to predict, not predict, but you have to optimize, right? And now let's say that you have a data only for like 10 rows. Now, does this justify that you will have 22 things to adjust in the 10 rows of data? So this is called capacity building. So what you have to do is that you have to check your model if your model is even capable, if the data is even capable to adjust these values, right? Let's say that you are just doing a simple addition, right? If you give two numbers, your model has to give some output, right? Now let's say that you have 1,000 examples for it, but now you're building a, like, say, 1,000 layer and 1,000 neuron per layer, 1,000 neurons, and then you have 1,000 layers. Now does the model require this much of data? No. The data will be lost in some third or fourth layer only, right? And see, what I just said in just last 2-3 sentences, this will come slowly with the experience in you also. So what you'll do, so whenever a new problem comes to me, I first of all read the research paper through it. See, because we are not researchers. Let me be frank with you. We are not researchers who are going to make things. We are deep learning engineers here, right? We have to implement the engineer and we have to solve a business problem through it, right? So what you do is, first of all, you read some papers out of it, right? Then you get the intuition of how do you build a neural network around it. Then I do some hit and trial error. Okay, this is how you build, and this some changes, and then slowly you understand. Okay, when I change this thing is affected more. Then you reduce and more. Then you have some prior knowledge also, like that I told you. Keep capacity. That what is the capacity of the model? Let's say that you have a very large data, but you are just building one layer. Then the data is underfitted, right? Or let's say that you have very less data, but you have made a very big neural network for this. And this is called overfitting, right? You have a very over number of neurons for your model to be predictable, right? So slowly you will you will have intuitions. And this is, I will tell you, with your when you will be doing your first problem in a neural network, you will understand slowly. See, you might be thinking that, I'm not taking to you practical, right? I am not telling you about any real world example, but this theory is really important. I might directly jump to the code also, but that will make no sense to you after 2 or 3 weeks, right? Because code anybody can write. Until unless you don't know, okay, what will happen is the next after 2 or 3 months, when you will be making your own neural network, you will fail that, okay, which activation function to use. Then this thing will occur. Okay. So see, this is what he is talking about to all the people. This is what he is talking about. Let's say that you want to add more layers. So currently there is only 2 hidden layers. You want to add more, add more, add more, right? If you want to increase per layer, you want to increase the neuron, you might go like this also. Okay. You might like, I'll reduce it to like, let's say 6. This I'll reduce it to 4. This and 2 and this is 1, right? This is how your neural network will look like. These are the 2 inputs. Now every input is connected to the every neuron in the first hidden layer, right? Then second, then third, and fourth similarly. And this is how the data is flowing inside here. You can see now slowly. When we put every X into each neuron, does every neuron give same Y? Very good question. But no. See, Kim, if we come here, it would have been the same if they would have same W, right? So if X1 is connected to N1 here at this layer, it has W11, right? But when X1 is connected to N2 here, it has something called W12, right? So there are different weights. So it is coming from X1, but because it is connected to different neurons, different input neurons, they will have different weights also. Understandable? So to other people, what Kame is asking is that, okay, that you are doing affine. I understand that you are doing affine, but let's say that, let's go back to affine equation. Because the value of x1 and x2 is constant, the output will always be constant, right? But no, because y1 is made up of this equation, and this equation is also driven by w1 and w2, and the w1 and w2 values are different, the value of y will also be different in each case, right? Makes sense, right? And when we were asking about a real world problem, this is how a neuron will work. Okay, I have this also, don't worry.
So you mentioned overfitting and underfitting neurons,
Yes.
So how do we come to know that based on the Y or?
Again, a very good question. So I took these 2 words called underfitting and overfitting. This is how it actually works. This is a intuitive GIF. Okay. So what Suresh is asking is that, that I took 2 words in overfitting and underfitting, and how do we address this problem? So what we do is that we divide our data into 2 parts, and I think you must have also done this in ML also, right? Training data and validation data, right? Not 2, just 3 parts, right? Training, validation, and testing, right? So what you do is, whenever you are training your model, you just make a slice, another slice of data, and this is called validation data. And you will never show this data to the model, right? So no, you are never going to train your model on this particular data. So what you're doing is, you will never show this data to the model, so model will never come to know about it. So it will never learn about it also. Now once your model is made, what you will do is, you will test it on this data. What you will do, you will test this on this data, and then the model will say, okay, this is how it looks like. Okay, this is what the predictions are, and then you'll see the predictions, and then you'll compare the predictions. Okay, this is not what I wanted, so the model is underfitting or overfitting. Now how will you do underfitting and overfitting? You'll do a confusion matrix, and then you'll see that if the model is just giving out you only 1 classes, let's say that your data had 10 classes, and if the model is just pushing towards 1 class, then this is overfitting. Your model is overfitted at a very lot level. Okay. Then we have another question from Kim. He says that it means, now this dog image, when we expand this image mathematically, this will come out to be 3 things. One is called x1, x2, and x3, right? Now what we have to do is, this x1, x2, x3 is done towards from our end. Now this x1, x2, x3 is connected to this neuron 1. Okay. Now x1 is connected to n1. This is called w11. But when it is connected to n2, it will have some another random weight called W12. W12. Make sense? So number of neurons you can increase as much as you want. As much. You can have N3, N4, N5, N6, N7, doesn't matter. But you have to make sure that this W11 is not the same weight for all N1, N2, N3. Right? Cool. Thank you. Thank you. So inside the matrix, you can see there are multiple values. The value ranges from 0 to 255. 255 is for like utter black and 0 is for white. Right? The value ranges from 0 to 255. You can see the more black it is, the more the value it has. Right? So what is happening is that these are the multiple inputs that you will have inside your images. Multiple inputs. And all these inputs will go in here. So in this particular example, you are seeing 3, but this time you will have more. So these all the zeros in first, all the values in second, third, fourth, fifth row till the 28th row. You will have all the numbers inside this input layer stacked one by one. So ultimately you will have 28 cross 28 is equal to 784. So you will have 784 inputs normally for this small image. And this is you guys were all asking about me how this will work in real world. So real world, let's say that you have an image of 500 cross 500. So that becomes around like 25 0000. That means 2.5 million inputs you will have for single image, right? And let's say that you have 10,000 images, so this becomes multiplied by 10,000, right? So these are the number of inputs that will go inside one by one by one by one by one. So one image will go one time, two image will go two, second time, third time, and then based on this, the output is the model is going to do some calculations in the hidden layer, and then it's going to predict the output, and it will give you some output at y. Okay, so now we'll turn up pages and we'll move to multi-layer perceptron. But now we might have multi-layer perceptron architecture. Now a multi-layer perceptron architecture simply means that you might have multiple hidden layers. Okay, so apart from having a input layer and output layer, you might have hidden layers in between of them also. Whereas a single perceptron was only a linear function, a multi-layer perceptron will have multiple linear and non-linear functions, a combination of them, right? I'll show you this. Again, I was not able to continue today and tomorrow. Today also you will not be able to continue. Okay, don't worry. I'll push the notebook in there and then you can have it. Okay, so I think you already saw this, but I have an image of multi-layer perceptron also. Let me show you. Okay, so this is how a multi-layer perceptron looks like. If I just minimize my screen a little bit, so you can see this now. Again, just to memorize things up, this is x1. This is what your input, x1, x2. These are your two inputs, right? Now you have a single hidden layer right now here. You have this one neuron here. Now you already know that what is the calculation going on inside. There is the affine function. Affine function, what it does, it takes input from all the behind layer neurons, right? So if I say it takes input from all the behind layer neurons, and if this is a hidden layer h1, then it means that it will take inputs from all the neurons inside this input layer, right? So this is x1, then this is connected, this is x2, this is also connected. Now whenever a neuron is connected to another neuron, it is connected through some weightage corresponding to it, right? Let's say this is w1, this is w2, right? And then you might also have a x0. Now the x0 is always equal to 1. So you might say this is just a bias as b. Now this b is like constant to this neuron also and to this also, right? I change this and it must have come to this. Okay, so now this is x1 and x2. For this, when they are connected to this neuron, the one that is downwards, and this neuron, they are connected again to some weightage, but this weightage might or might not be equal to the w1 that is the one that is described here. The one described here, this is never going to be equal to this one, right? So these are different weights associated to different. So you might, to make it more simplified, you might think that whenever there is a string connecting two neurons, it is connected through a weightage, and this weightage is different for each one, right? This weightage is different for each one. You might also see the equation here down here, w naught in plus 1 plus w1 x1 w2 x2. Now you know that w naught is equal to 1, so we have replaced w naught is equal to 1. Sorry, x naught is equal to 1, so we have replaced x naught with 1, and w naught in itself, you can say w naught, or what people like to say is it's called as notation called b, and this is called the bias of the neural network. Okay, bias, and these w's are called the weightages, right? And then you do again a summation out here, and this time you do the final output, and then you give the output right here, right? You also remember that after every neuron there is also activation function which is sitting here, here, and here. They are also present on the outer section also. This and this, they're present here also. So they, and then you read that there are different types of activation functions. From step function to sigmoid, then to uh, softmax. We have different. I'll slowly go through each of them, and then you'll understand that how they interact, and how you might be also changing them according to your needs, right? Okay, I'll minimize it. Visible now? So now once we are done with this perceptron layer, now okay. So this is called a feed forward neural network. Just one thing, feed forward neural network. Once you come from here, this neuron, you go till here, then there's some calculations goes on. Then you come to here, which is taking connections from this and this neuron, and then you give the output, right? Now let's say the output comes out to be some y1, whereas the actual output was, let's say, y, right? Now there is the error associated to it. So you say that you have an error, and what is the error? Y minus y1. This is the error, right? Y was the actual answer that should come, right? But you are saying the answer is y1. Then y minus y1 is actually the error. What it is? It is actually the error. This is actually the error, y minus y1. Now your model, you say to your model that model, you have done some kind of mistakes. Now if you go back inside your session, if you go back to your session, you might see some errors inside it, and that error might be equal to y minus y1. So go and do the changes. Now if you see our function that we have done till now, the result through which we have come till now here at this point y1, it is all how much dynamic things you have taken, I mean non-static things you have taken. See, x1 is always going to be static, right? This no one is going to change this x1 and x2, because these are given by the data itself, right? So the data can never change itself. It is you who has to change, right? Then what is the thing that we have taken, assumed? These are the values of w1 and w2. W1, W2, and W naught. These are the, similarly these W's here. I mean, all the W's that are here, all the W's that are here, these values are something that you have assumed, right? So now what the model says, that the value that you have assumed, W1 and W1, W0, W till Wn, these values might have some kind of a correction, because the current values of W are giving some error, that is y minus y1. So to reduce this error, you go back and check your values of W and switch the values of W to such an extent so that they minimize this error, right? Whatever I said just now is statistically, right? Makes sense to everyone, right? What I just said here. Okay. Now this thing is called backpropagation. Back. Now this thing is called backpropagation. Now backpropagation, if I take the copy of the, can we try different activation functions too? Yes, you might try whatever activation functions you want to try, but there are some. Okay, so Oman has asked this question that how do can we use different activation functions also? Yes, it depends on the problem that uh, uh, what functions do you want to choose. So I'll tell you my particular example. So I was working on this library that is called DOLD5. Here what we are trying to do is that we are trying to restore colors into images that don't have color. So I mean, if you talk about images that are like from that are before 1924. So we have some German artifacts. Those are before 1924, and those are totally black and white images to us, right? So what we have to do is that we have to fill images inside it. Now, filling images inside it is, I'll tell you, it's a complex process, but there is a form of images that comes out. It is called the LAB images. So if someone of you who has interest in photography uh, or if you understand what images are, then you might have heard this term called LAB. LAB images to convert. Now the range of LAB images is from -128 to 128. So here my task. So if generally if you see the activation function, if you remember from the previous class, all our activation function from ranging something from 0 to 1 or like -1 to +1, right? Now I wanted something that has to go from -128 till +128, right? Then how will these things two go? So accordingly you can change your activation function and you make your own function out of it, right? Make sense?
Yeah, I forgot you in the last lecture you said whenever you're trying to bound your values in a certain point, then you use
Correct.
different activation function. I just reminded.
Correct. Totally correct. So so this is all about the feed forward. Now feed forward, if I just say in one line, feed forward is going from input to output. Now if you want to come back from output to input to make corrections, that is called back propagation. Now back propagation is one of the most used, or I should say, okay, now visible. Okay, now this is one of the most not used, but this is one of the most obvious things in backpropagation. This is in AI, and why this is famous, because this is the main backbone for AI. This is how AI learns itself, right? So people say that AI is learning from itself. No, it's not learning from itself. It's learning from the errors. Whatever error it is making, it goes back and it checks. So see, a human tendency of error checking is what? Let's say that you are doing some calculation and you do some error. What do? You go back again to the calculations and you check, okay, I did this mistake, and then you correct it, right? This is also the way how machine is also understanding. So what machine does, machine does some calculation, it calculates that there is some error, then based on the assumptions that it took, or based on the assumptions it took, it thinks, okay, these are the things I assumed and this is now the error. So what it does, it goes back and say, okay, I will change my assumptions, I'll tweak my assumptions, and then I'll see what is the error again. This is a iterative process. So again, let's say that in backpropagation, what will it do? It will try to change the values of W1 and W2, right? It will try to change these values of W1 and W2, and then it will again go in the forward direction, and it will again see, okay, again there will be some error, but this time the error will be less as corresponding to the previous error, right? Now again it will go back, then come forward, again go back, forward, go forward, inward, forward, backward, forward, backward. This will happen multiple times, and at one point the error will saturate. The error will look like this. So error graph will look almost like this. Here error is on the y-axis, right? And this is whatever you say, time on the number of epochs or steps, let's say, as of now. Steps means that how many times you have gone forward, backward, forward, backward. So you can easily see here that that the error was very high at this particular point, but then it slowly decreased. It decreased till here, but now it's almost saturating. So it's like almost saturating, and at one instance it will be like parallel to the x-axis. It will become parallel to your x-axis. This is how it looks, right?
Shivam, so how this program will go back and forth? Means it's APIs, or we have to manually do this every time, run the program each time, and or run the program in the reverse order? Can you make it clear?
Okay. So, so the point is that first of all, we'll do it on in our hands. So we'll do it manually first.
Okay.
But good news for you is that no, you don't have to do it manually. All these things are like handled by the framework itself.
Many times we have to go back and forth so that it is
No,
minimized,
no,
the
no,
error
no.
become
This you have
parallel.
to decide. This you have to decide. You'll see the error graph continuously, and then you'll decide, okay, now I want to stop, or okay, no, I want to go further. This is up to your hands. Okay, makes sense, right? I mean, see,
Correct.
what if they can even tell this that if they can even tell this that how to stop, then I think the problem is done. I mean, then we will be doing nothing, right? We just open the and we just say this is the code, read the code and do it itself. Read the problem and do it itself, right? No. The problem is that it will do everything, all the calculations for you, but the mind where to stop the problem, where to go ahead with the problem is still in your hands. You have to still make sure that where do you want to stop the things, or where do you want to again get the further out of it, right? Make sense, right? Okay, let's move forward. I have one more theory for you. Let me paste it. Okay, so don't read this. I'll tell you. This is just for your purpose, so that in the weekend, when you weekdays, when you go back and you want to, don't have to like revisit the whole video. Don't review the video. You can just read it through the notebooks only, right? That's why I'm just copy pasting the theory here also. So what happens is I've already told you that all the edges that you are hit that you see here, that all these lines that you sorry all these lines that you see here, these are called edges. All the connecting things are called edges. Now for every corresponding edge you have a weightage, right? For every corresponding edge you have a weightage, and these weightages are by default randomly assigned to you, right? Now they're randomly assigned at the very first point. When the problem start at that particular instance, these are like randomly assigned to you. Now for every input in the training data, the ANN is activated and its output is observed. This is what I told you also, right? That once we'll do all the calculations, we'll do the first feed forward neural network. We'll check what the output is, and then the output is compared with the desired output that we already know. And the already know, this is also, you might have heard this term again and again. This is called ground truth, right? So see, deep learning may you might have heard this is not equal to what traditional technologies. In traditional programming, you have been given the input and people ask you output. But here it's not like that. Here they will give you the input also and the output also. And then you have to define some way to convert this input into output, right? This is how machine learning works, right? Because they give you input also and then they give you output also. So like say, let's first on the first example, if someone tells you that you have to do some image classification problem, then this is not like they'll give you at the very first instance, this is the image, now tell me what it is. No, they'll give you a training data set where they will give you the output also. With the image, they will also tell you that okay, 9 is written here, 5 is written here, 7 is written here, right? So you have the ground truths with you also. Now what you'll do, you'll compare your result with the ground output, and then the error is propagated back to the previous layer. If you read the line propagated previous layer, the error is noted and the weights are adjusted accordingly. This process is repeated till the output error is a predetermined threshold value, or where you think that it is being saturated. Right? This is what I also told you. Now, if I tell you that how it goes, okay, let's see one by one. Mathematically, I'll show you one by one also. Now, see, it's pure maths, okay? Just a little attention, and then we'll be here. Let's say this thing is called okay, or otherwise, what I can do is I'll just pick up the smaller problem, and then I'll show you also how it is done. Okay, just a second. Let me search for the image that I have. Mhm. Okay, sorry, I cannot find it right now. Otherwise, but okay, let's go. Let's see that error is equal to. I'll write it down. Error is equal to, let's say, y actual minus y predicted, right? Let us write down. Error is equal to this. E. I'll write down. Okay. Now, if you see that how is this y1 calculated, then let's say that we had an input called we had an input called I1 and let's say I2, write down, and let's say that we only have this one. Okay, let's make it more simple, right? I will take just this image. That will make you understand how things work, right? Let's copy this. Okay, I'll write it down. Okay, this is the example, right? So now we have input as x1 and x2, right? And we have an output called y. Let's say that the actual or the desired output be ya, right? This is what we require from them. This is how we have, and the value of y is equal to w1 into x1 plus w2 into x2, right? Everybody agrees to this, right? That how is this calculated, right? Now the okay, and let's then define error. Error is equal to y minus ya, right? Or whatever you want to say, ya minus y doesn't make much problem to us, right? This is how this is working. So now if I say E is equal to y minus ya, then I can say E is equal to, instead of y I can write w1 into x1 plus w2 into x2 minus ya, right? Now if you open up this, doesn't make much sense, but let me write it down. W1 into x1 plus w2 into x2 minus ya, right? Now, sorry. Okay, now the error is this, right? Now, what do you want to do? Now the final equation of error is in front of you, right? If I write it down, the final equation is in front of you. You can now you have the final equation in front of you. Now you have to see that how to minimize this equation, right? How will you minimize this equation? This is the equation of error in front of you. Now what you can do is, now you might be thinking that okay, this error equation is just a simple linear equation, I can solve it linearly. Now imagine that instead of x1 x2 you have 1000 xn, right? Now this equation is not a 2D equation, now this is a 1000 dimension equation. Now you cannot just simply do things and just check it around, right? You cannot just do it like that. You cannot just plot a graph and you can look into that, right? This is a little more complex than we thought of it, right? If I show you how the graph might look like, right? The graph will look like this. Don't just read this, just for the time being, forget this thing. Just don't read these things. Okay, so what I can do is I say, okay, this is your error equation, or let's say error I can also say J of W. You might see this terminology J of W as error. Okay, I should not do this. This is not making it good. Okay, when you plot this thing here, now what you can see is, see, x1 is what? X1 is a constant, right? X2 is a constant and y is a constant. You all agree, right? That x1, I will put a star and say x1 comma x2 and ya are constants, right? You cannot change them. These are constants, right? They make no effect to e. The one that might change e is w1 or w2. Okay, for a fact, none of you told me, but we missed a bias also here. Bias B. We missed this bias B here, right? Say this B, but this B is, I mean, it's not going to make some effect to us, but still, just for the courtesy, let's put this, right? To anyone, any doubt is still here, please ask me questions, right? So now we can see that, okay, what is happening is that E is only dependent on W's, right? The error is only dependent on W1 and W2 and B. None of the other people are changing this E. So what we'll do is we'll try to plot this error with respect to the weight, and we'll see this is how the graph looks like. And what do we want to do with the error? If error is ya minus ya, what is our aim? Our aim is to make ya is equal to ya as equal to y, right? This is what our aim is, right? If ya is equal to, then we are saying that the error should be equal to 0, right? Error should be equal to 0 or tending towards 0, right? But if I say mathematically 0 is, if I say statistically, this error is never going to be 0, right? This is never ever tending to 0. So what our main focus is? Our main focus is that if E is here, our main motto is to minimize the current error. Whatever the error is, we have to minimize this error. Now the value of this error can be found here, right? You can simply see the graph and say, okay, this is the value of E. Just take the value of W's and plot them, right? But as I told you, now these errors are not just two inputs. We have like 1,000 inputs, so we might have 1,000 W1s and then one B also. So we cannot just plot it. So it will become a 1,001 dimensional graph. You cannot just plot it. So now we have to think mathematically that how can we minimize the error E. Now minimizing the error E, but we also have the like the equation of E also. We have the equation. Don't think that we have the graph, just think that we have a equation of E also, right? This is above, right? And equation of E is somewhat like this. If I copy this from here, this is somewhat like this, right? This is somewhat like this. This is what the equation of E is, and this is how we have to minimize. Now in mathematics, we have learned, in inferential mathematics, we have learned that if you want to minimize any curve, if you want to minimize any polynomial curve of the order greater than 2, what is the process? Can anybody tell me? If you want to find out, if you want to know that where is
First derivative, I believe.
I'm sorry, what?
Take the first derivative.
Take the first derivative. Okay,
yep.
Okay, correct. Take the first derivative. That's very much correct. So as Omar said, that you have to take, so see what the first derivative tells you. The first derivative tells you that wherever there is a change in the slope of the graph. If I talk about what we learned in our higher education about differentiation, was the differentiation tells you that point coordinate where the graph changes its slope from positive to negative or negative to positive. So if you take the first derivative, it will tell you this place. See, it was in negative slope, then it came in positive slope. Now again here, when it was in positive slope, then it came into negative slope. Again positive, negative, positive, negative, positive, negative, positive, negative. So it will tell you all the places where it has uh, changed the slope from positive to negative or negative to positive. Vice versa, it's possible, right?
Yeah, but
Sorry,
like for global minimum and maximum, you have to take the second derivative instead of the
second
derivative.
derivative. Correct, 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 correct. So this was how we talk about inferential mathematics. But if you go in descriptive mathematics, it says that what is a derivative of a function? A derivative of a function when you have a tangent that is parallel to the x-axis, right? When it is parallel to the x-axis. So how where will be the tangent parallel to x-axis? Whenever there is a slope that is equal to 0. So if the slope was from positive to going to negative or negative to positive. So both the mathematical percepts tells you that there is a change in the slope in that, right? So similarly, we can know that where are the positions, where are the places where we can get a change in the slope. Now, as Omar very he suggested that we will get all the points where it is maximum and minimum also, and we just want the point where it is minimum. I mean these points, we are interested in the one that are by dotted by green, either this, either this, either this, right? But now again there's a problem is that these are very higher error. This one that I'm just marked as E1, this is a very higher level of error, right? We don't want a higher level of error, we want a lower level. This one we want the E3, we want E3 to be our error. So what we do, we take double differentiation. We first take differentiation, then we take double differentiation. Now double differentiation, then Omar, can you tell me what is the condition if it is less than equal to or equal to less than 2? Okay, I'll tell. Now with the first derivative you can know that where is the slope of change, but if you want to know that what it is, if it is a maxima or if it is a minima, how do you know it? You know by doing a double differentiation of that thing and then checking its dimension. So if the double derivative of any of your function is greater than 0, if the double derivation of a function is greater than 0, then it is a minima, right? And if the double derivation of any of your function is less than 0, then that is maxima. These are the conditions. Then you will check accordingly and you will go for minima. Now again the problem is that okay, now you will reject these points. You will reject all. Okay, so you might discard this, you might discard this, you might discard this, you might also discard this, right? So you will remove all these blue points. Now you will only have the green points with you, right? Now you want this E3 to be there, right? Now we don't have any mechanism through which we know that we have reached global minima or not. This is the dilemma in deep learning. And so slowly what we do is now understand this mechanism. This is called this whole thing that I'm showing you right now is called gradient descent or GD, right? You might have also heard this as SGD, stochastic gradient descent. When you do a gradient descent in batches, it is called stochastic gradient descent. Okay, I'll take a pause here, and to anyone who has not understood this thing, please ask. I know I might have taken a very quickly this up, and again one more point to other people also who are not math heavy. See, this maths is just for your understanding. You won't be doing all this maths in your programming. No, you won't be doing all this in your deep learning courses. You will be just writing the direct code You won't be doing all this mathematics. This is already done by the framework, so don't worry about this. But again, my point is, please try to get this inside, because this is necessary, right? This is necessary. If you don't understand what is your framework doing, then there is no sense of your framework doing something, right? So so just please, and if you have any doubts, please ask. Please ask. Do not hesitate, because I know it took me 3 days to understand this thing. So I was, how do you put, okay, so I am assuming that everybody understands till here. Okay, so what I'll do is I'll take the first derivative of dE. Sorry, dE. Now you know that E is equal to this. Let's write it down. So now you have seen this one thing, that now the E is dependent on either W1 or W2. So what you'll do is you'll take the derivative with respect to one time with respect to dW1. So what will happen? It will say x1 and then everything is equal to 0, right? Because these are all constants. Am I correct or wrong? What I'm doing is I'm trying to take a derivative with respect to W1. What will happen? X1, correct. X1 into 1, totally correct. Plus W2 is again a constant, plus constant plus constant. Makes no sense, right? That's there. And if you want dE by dW2, then what will happen? It will give you x2, right? x2 into 1. Don't worry again to, okay, it's in chat. Just a second. Again, see, someone is asking me this question that, is this really required? No, this is not required. This is just for your reference. Don't worry.
Shivam, I think
Okay.
you need to add a constant term too into the derivative.
Oh yes. So we need we add a constant term, but here we know that that constant term is equal to 0. So yes, he's right. We'll have some C1, C2, but these are constant as of now for us. They don't bring much value to us. I'll put this picture around. So see, this was just for one, right? If you go from here till here, this was just for adjusting the new values. Now what will be the adjusting values of W1 and W2? So now we already have the older values of W1, W2. So the new value of W1, W2 will be dW is equal to W1 minus dE by dW1, and W2 will be equal to W2 minus dE by dW2, right? This will be equal to this, and but there is a special term that is called alpha that is associated here. It is multiplied here. I'll tell you what alpha is. Here, I don't know how to type alpha in like latex, but okay. Okay, so now you might ask that, okay, now we understand that this is the new value of W1 and W2, right? So now what will happen? This older value of W1 and W2 will be replaced by the new one, and then you again go forward, and then you again get the error, again come back, change the value, again go forward, backward, forward, backward. But there is one thing that you might ask me, that what is this A here? This A is called alpha. Sorry, this is not A, this is actually alpha, and this is also called as learning rate, or you might see people calling as LR. Right, now what learning rate is, now just pay a little attention towards here, right? So let's say the previous value of W1 and W2 will give you some error that would be here at this point, the one that I draw very small here, right? The next one will be here, then here, then here. So it might vary that how gradually you are moving your W. Let's say that you are making very small change in W, very small change in W. So your error, let's okay. Let me maximize it. Okay. So now let's say you have taken some initial value of W such that W1 such that the error is here, right, at this point, at this particular point. Now you make a very small change in your W1 and make it to W1 dash. So what will happen? The error will shift very slowly also, right? Your error is also going to shift very, very slowly because you have made a very small change in W1. Or otherwise, let's assume that you might, there your W1 originally was here and you made a very big change in W. So your error might be here at this point, new error might be here, or it might also happen that it might come here also, right? It might change that how gradually you are moving your W. So there is this terminology that says that you should very slowly move your W so that you don't miss your minima. Assume again, let's assume that you slowly moved your hair till here. So you have come till here. Your W1 is here now. And now you suddenly increase, you did a change in W1 so large that you came here. You came at this point. Now this is bad because you missed the global minima in here, right? So what people say that you should very slowly move the value of W, very slowly. You should do all the changes very slowly, and your dE by dW, your dE by dW should be controlled by some another external factor, and that factor is called alpha. Now, because if you go down the screen, if you see, I have multiplied this dE by dW term with a thing called alpha. Now this alpha is with you. This is a constant and this is in your hands. You can change it anytime that you want, right? So what you will do is, I'll move back up here. So what you will do is that you will select the value of alpha such that it is moving very slowly, right? But now there's a disadvantage also, because if you move very slowly, then let's say you are here, then you will come here at this point, then here, then here, then here. So you might reach your global minima at a very larger time. It will take a lot of time to you. So you have to take a very critical value of alpha such that it moves very slowly. I mean, not
So
slowly. Yeah.
are you trying to like tune up your model?
This is not tuning, it is just adjusting the thing that how the model is reacting to the changes that we are doing. So it's like we are controlling our own process of the flow of gradients. And alpha, keeping the value of alpha, yes, you can say this is one of the parameters of hyperparameter tuning. Hyperparameter tuning, HPT. Yes, this is one of the small features that you are tuning. So the value of alpha you should keep is 0.001. But again, if someone says you this, well, like I just said you that you should keep your alpha, no, I'm totally wrong. It depends on your data that how slowly you see that your model is moving. This is just the initial value that you should take. So if you will see all of your major frameworks like Keras or like TensorFlow, you will see that they have put a value of 0.001 also by default. Make sense? Till here, anyone is having any doubt? Let's say that if you want to do it for multiple cells, this is how it looks then. I don't want to scare you, but this is how this mathematics goes backwards, and then you do all the changes slowly. If you want to see the weights adjusted also, I have a picture for that also. Let me. Yes, this is how it looks like. Anyone, any doubts till now? Okay, I have some questions. Cool. No questions? Then I think we should move forward and I should show you some things. Okay, now I will take questions from the previous class that someone asked me that how does the image looks like, and I showed you this GIF, right? So I told you that this image is nothing but images are just numbers. Numbers ranging from 0 till 255, where 255 being the highest value and 0 being the lowest value, and these are called pixel values. These are pixel values, pi values, right? These are pixel values to you. These are pixel values. This is how the images work. But the image that you are seeing on your screen, this is a single channel image, right? This is a single channel image. Now you might have multi-channel image also. Let me show you the demo. Okay. Last time, anyone in doubts in backpropagation, because this ends your theory for uh, deep for neural networks, right? Neural network intro is done here, right? I'll take up a new Python and I'll just demonstrate you how images. Okay, so there are multiple libraries that you might want to use. These libraries for image reading, image processing, and I personally feel if you have passion for images, these are the best libraries that you should use. And see, one thing is that deep learning is doing wonders in all the dimensions, but especially in image, it is doing great. And deep learning started with images only, and that's why we are covering multiple use cases in images only and less in other domains. So that's why you need to also have first is OpenCV. Without any doubt, you should use OpenCV. Second one is, I remember, SK Image. That is again made by the people from sklearn only. So sklearn machine learning you might have learned. Third is PIL. PIL is like very largely used. Then I want to write Keras also, but Keras is actually using backend is made up of PIL only. So it doesn't make much sense that which one use. It uses PIL and SK image both. So this is these are like major importing libraries, and now I show you how do you import a image inside your code. Before that, let me quickly check if I have some images. Okay, I have. Okay, let's say the test image is equal to If I go back, I have a folder called data. Then I have a folder called small. Then I have a cat image as a test set with me. How do you read it? First, do you import the library? Then you say image is equal to cv2.imread, and then you say test image. Now you read the image, and now image is no image to you. Image is actually is like this. It's a matrix to you. It's a numpy matrix to you. If you see the shape, it says it's 499 in height, 403 in width, and 3-channel image. If you want to see the image, you have to import another library that is called matplotlib. Matplotlib will help you in visualizing things. plt.imshow, and then you can do image, right? So this is a cat image, a 3-channel cat image, right? Now what I can do is, I can put a here it is. Okay, I just made sure that I'm not doing any kind of a changes by putting this tag. This will make sure that we are not doing changes. Now what I can do is I can show you okay, can anybody tell me? You are all okay. What is this actually doing? The one written in line number 11.
Split.
Can you please explain this more? I mean, what split it is doing? Is it correct?
It's just giving a RGB split.
So you are saying it will give you 3 splits, R, G, and B.
Yeah, I mean that's what I think.
Partially yes and no also, but you are close. Okay, so see, if I show you how this 499403 looks like, this is somewhat like this. This is like first channel, then you have second channel, then you have a, sorry for my bad, then you have a third channel, and then these are connected like these, like right. Now what I just did, this is a numpy array. If you so sorry, I just deleted. Shit. Okay, so if I show you the type of this is actually a numpy nd array type of a nd type of a image. Oh sorry, type of a matrix, right? And when I say this means that this means you want the whole height, you want the whole width, but you only want the 0th number of channel. And how many channels are there? 3 channels. And so the Python will index them as 0, 1, and 2, right? Python will index them like this, 0, 1, 2, 3, right? So what you're asking from images, you are saying that you give me whole height, you give me whole width, but instead of giving me these 3 channels, just give me the 0th channel, right? So what I'm going to do is I'm going to
Can we plot just one channel and see how it looks like?
This is what one channel is. See, the one that I'm going to show you is the R. Sorry, I am sure. This is what the R channel looks like.
Oh, that makes sense. In Photoshop, you can do that.
Yes, see, this is R, similarly for G, and similarly for B. Sorry, it will be 2. So it might look similar to you, but these are not similar. If you see the matrix, they will make more sense to you. So the matrix value will be totally different. So these are like I peeled off 3 images, and then you are seeing this out, right? Let me do one thing. If I remove this tag, and then if I do still the same. Okay, so what I just did was that I tried to peel off this image, this 3-channel image, and I just converted it into R, G, and B. Right? These are the different color codes. What you can do again is that okay, image 2 is equal to cv2.imRead, and then you say you want to read the test image but with a 0. Right? What will happen with test image as 0? Sorry, CMap as green. Actually, the problem is not with, see, it's not with Matplotlib. It's not a problem with OpenCV. It's actually the problem with Matplotlib. So what I just said, I said 0. This means that this will read the image into a. If I show you image2 dot shape, see what it converted. It converted the image into a single channel image.
Can we say this image channel is a dimension, like one-dimensional, two-dimensional, or it is different?
I am sorry. Can you please repeat?
This channel is what? It's a dimension, like one-dimensional image or something like
See,
that.
these are colors. See, so what is happening is that whenever you are seeing something, whenever you focus, so this is optics, right? So what is happening is that whenever you see something, there are like the primary colors RGB. Now, based on the wavelength reflection that they have, the thermal properties that they have, they are reflecting back those color, these wavelengths back to you, right? Now, so whenever you see, you throw a light out of the electromagnetic wave, not electromagnetic, but it's an optic wave that goes out, it comes back to you, it reflects back based on the wavelength it gets back, right? So now the wavelength is these three metrics. So for the red, you got this thing. For green, you got this thing. For green, sorry, RGB. So for the blue one, you got these things. Now you add these three things together, and then this final image is made. This final image is made in front of you, right? And this, yes, you are totally correct that these are a dimension. Yes, you can say this is a dimension also. So you can count this as dimension also, that 499 is height, 403 is width. We obviously know this is a dimension. But now we have a third dimension. This is called number of channels. So how many number of channels does your image has? So this image has 3 channel images. So RGB are separated. But let's say I took this example where I read the image with a 0th tag. Now 0 tag means that you don't, you just want this image to be in a single channel image. So what we did, it converted this image, see, only single channel, right? Make sense? Okay. So now sometimes people confuse that, this is a single channel image, and people think that single channel image is a black and white image. No, black and white images when you will only have black and white, either 0 or 255. This is a grayscale image. Grayscale image means you will have everything in the tone of, you will have pixel values ranging from 0 to 255 only, but you will have this in a single codec. So you won't have three codecs for RGB separately, right? If you see image 2, see, you will have values all ranging from these all values, right? And if I show you one more thing, just give me a second. Image 1 underscore image 1 is equal to image dot sum x is equal to 2. Image 1 dot shape. Okay. Okay, this is not what it is, what I was thinking, but okay. This is the basic idea. plt.im show image 1. So what I just did was that I took the sum. Okay, I should not take the sum, I should take the mean. Okay, now I should check that if which one is equal to image 2 and not. Okay, correct. Okay, so see, these are different techniques that you can do. You can check with your I mean, you can do multi-processing images here. You can do convert into LAB, LAB to IAB. So there are multiple mode of images. You can go and check them, check these different things out. Like, image processing is very cool, and especially with the libraries like OpenCV, which are now using deep learning to do image processing. It's like a whole circle. So you do image processing because you want to do deep learn. You wanted to do deep learning, right? So this is like a circle like this. You want to do image processing because ultimately you want to do deep learning. But what people are doing, people are now using deep learning to do image processing. So it's like a circle that you go round and round and round. But image processing is very cool. And okay, one thing that I did forgot to tell you, that how do you install OpenCV? Installing OpenCV is a little pain. How do you install this? Installing install OpenCV is simple. You just say pip install OpenCV -python. It's not CV2, right? And then when you say Python, and then you will import it like import CV2. So there's a little confusion. So you install it by OpenCV Python, but you import it as CV2, right? Similarly for skimage is simple. Pip install skimage. For PIL is again a problem. Install PIL name is pip install pillow. Actually, what you have to do, what you will generally do is from PIL import image. Okay, these are the one. Keras actually gives you images inside keras.preprocessing.images. I will write it down. I can like show you also. Okay, let me show you that only. That import keras first of all. Let me put everything inside the same thing. Okay, you say keras.preprocessing.image. Okay, from this import load image, then image to array, right? These are two things that you want to do. Then you say image underscore 3 is equal to load image, then you say dot data, and then dot get small, let us do dog. Okay, and then you say plt dot im show, and then you say image 3. It won't work, it will give you error. Oh no, it's not it. Why? See, I'll tell you. Actually, what this image is, image 3 will give you a image context only. This is a problem with Keras. Keras will give you this image, right? Actually, otherwise, what you have to do is, if you want to see the array of array context of this, it will say you have to say image dot array, image to array, and then you say image 3. So now it will give you all the stuff, numpy stuff. right? So if I like cut paste this thing inside this, okay, it says clipping data under the valid range of okay. Oh yes. So see, what is this problem with this IMG2 array is that this, I don't know why it converts everything into a decimal. You can see, right? See, a float, right? Only. So what you have to do is you have to say this is at as type. I think int should work. Yes. Sometimes there are very small things that you need to focus. And I think if you can see the code here of load image, this is not a very, see, it's using PIL image, right? You can read everything that how is it using. It is using color mode as RGB, then it is grayscale, interpolation is nearest. These are different codes. It is how it is reading, right? And then it is returning the image dot resize height width tuple. Height width tuple is taken from here, right? Target sizes, and then you can do these things. Make sense? This is how you read images. You do multiple things with them. You multiply some values and you come out. Grayscale. How do you do single channel images? Right. Any doubts, concerns that you want to ask?
See, we are going to read these images. So will
Yes.
it compare to any other image and will tell us that what the image is, what the picture is, or the alphabet or whatever it is. So will it tell that this is the image that you have searched for?
See, this is just reading of images. As of now, we are just reading the images. Nothing much what we have done. Now what you're asking is that let's say that this digit contains something, right? You're asking the same thing, right? That let's say that the picture is, yeah, we have written something, right? Let's say we have written a 9 on an image and then we are feeding the image to we are reading the image. Now you want to know that what is written on that image, right?
Yes.
That is what deep learning will do. This is what we are going to do with that. But as of now, we are just reading the image because we have to ultimately do this stuff. Deep learning stuff. For the deep learning stuff, we have to read that first. So we are just reading as of now. These images are just meant to be read, not now.
So, suppose you are a computer vision engineer and a client has approached you with a problem statement in which you have to detect the faces from a set of images that they will be providing, and you have taken up this project, and these are the following steps that you have to follow while building up this project. So, these are the images that they have provided to you. These are some of the images that have taken from their dataset, and here we'll be working on Python with OpenCV. In this project, we will be using the Har cascade classifier for detecting the faces from multiple images. So, firstly, you have to perform the downloading part for the Har cascade system. So, here I have written download Har cascade frontal face default.xml and this raw GitHub code. These are the raw datas for the Har cascade. You have to just simply save as, and you can save it as desktop, and you have the Har cascade classifier. So now next we will be just importing the CV2 and glob. So now we will be practicing it in the Jupyter notebook. So firstly you have to import the CV2 library and glob. So I want to tell you that glob is the function which returns us the array of those file name which we will write in the next line. Like we just have to perform face detection on those images which have .jpg extension. So for that I will be writing gimage equals to glob.glob. So here I am calling the object glob and with the function glob, and here inside the function I will be writing the star.jpg. So it will take up all the images that have extension .jpg. So after that we will detect, after getting the glob images, now we will create cascade classifier so that we can, so as it helps us in getting the face detection, it contains all the features of the images like nose, ears, face, object. These are some of the features of the image. So here we will be writing detect equals to cv2 dot cascade classifier. Then inside the braces we will be writing which classifier. We have downloaded the Har Cascade frontal face default classifier, so we will be mentioning the same name, Har Cascade. Okay, Har Cascade frontal face default.xml. So now after creating the Har Cascade frontal face default XML file, then what we will do, we will now traverse the glob images so that we can detect the faces. So for traversing we will be creating a for loop for traverse, or you can also write timage for traversing the image, timage in gimage, the glob image. Okay. So now it will take one image at a time. Now in the for loop we will read the image, a particular image. So for just reading the image we will write like I have taken image equals to cv2 dot im read, and what is this reading? The T image. Okay, so after reading the particular image from the G image, now we will convert the images. These are the colored images. The image that it has read, it is the colored images. So in this phase detection, we will first have to convert the colored image into the grayscale image. So it is easier for the classifier to handle the image and detect the faces from it. So for converting the image from converting the colored image to grayscale image, we will write gray image. I have written this gray image equals to cv2 dot cvt color color, and in the braces it will have this image that you have to convert it into grayscale, this image comma the, we will write cv2 dot color and underscore bgr to gray gray. Okay, so after converting it into grayscale, now we will detect the faces from the images. So for detecting the faces, I will be writing the face equals to detect dot detect. I am calling this object here and with the function detect multi-scale, and it has 3 parameters. So the first one is in which image you want to detect the face. So we will be writing this gray image here, and the next parameter is the scale factor. So we will be more, so we have to see the value of the scale factor, as the scale factor is that value which decreases the volume of the whole grayscale image by 5% until the face is detected. So it basically what does, it decreases the value of the image so that it can find the face from the image. So I am writing 1.25. The smaller the value is, the greater will be the accuracy. So I am writing 1.25, and the next parameter is the minimum neighbor. So we don't have to bother this value. Now after that, after detecting the face, now we will be describing the rectangle shape for the face. So for that, create a for loop for Now in this braces, we will be writing all the dimensions for the rectangle like x, comma, y, comma, w, comma, h. Length, breadth, height and width. Okay, so after the parameter, now in what? In face. We are actually we have detected the face, but now we have to define that face with a rectangle shape. So for that, we will be using the dot rectangle function. So here I am writing cv2 dot rectangle. Okay, rectangle. Now in this we have 4 parameters. The first one is the image that you have to detect the face image. This image that we have read it here. Okay. The second parameter is the RGB value. RGB value means the colored value. So here I am writing the x, comma y, and then the other parameters for the rectangle. We are basically defining the parameters of the rectangle, how it will look on the image. So we will be writing x plus w, comma y plus h. Okay, so after defining the parameters of the rectangle, now we will be look at the color of the rectangle. So here I am just taking the green color. So this is the code for green color. Okay, 0, 255, 0. Okay, so now after that the last parameter is the thickness of the rectangle. So I am giving 2. So now after defining the rectangle, now we will just show the image. So for displaying the image, cv2 dot imshow, in the parenthesis we will be writing detect. Any message you can write like detect images. Okay, and comma which image? This image. So image. Okay, so after displaying the images, now we will be defining the wait key function. What does wait key does is we will define some intervals between the images. It's just a time period that what will be the intervals between the images. So cv2 dot wait key, and how many? I am taking 200 milliseconds. Sorry, 2000 milliseconds, and we will be writing cv2 dot destroy all windows. So destroy all windows will closes all the windows based on the wait for key parameter. So here I am writing the 2000 milliseconds, so it will destroy it for that. So here, okay, so I am running this code. So here you can see that all the faces have been detected. Okay, so I hope you have liked.
Machine learning is the heart of artificial intelligence, and it consists of techniques that lay out the basic structure for constructing algorithms. These algorithms are used to build machine learning models that predict some outcome based on the input. So let's look at the first question. So the first question is, what are the types of machine learning? So there are 3 types of machine learning, that is supervised learning, unsupervised learning, and reinforcement learning. So let's see them in detail. So the first is supervised machine learning. In this type of machine learning technique, machine learns under the supervision of labeled data. There is a training data set on which the machine is trained, and it gives the output according to its training. So for example, if a patient is diagnosed for a disease of cancer, so the machine will predict the outcome based on the input or the symptoms as positive or negative. Now the next is unsupervised learning. Unlike supervised learning, it has unlabeled data. So there is no supervision under which it works on the data. Basically, unsupervised learning tries to identify the patterns in the data and make clusters of similar entities. After that, when a new input data is fed into the model, it does not identify the entity, rather it puts the entity in a cluster of similar objects. So you can see over here, the robot tries to identify the object and makes the clusters of similar objects, and whenever a new data is fed into the machine, It tries to identify it according to the cluster identified by it. Now the next is reinforcement learning. So reinforcement learning includes models that learn and traverse to find the best possible move. The algorithm for reinforcement learning are constructed in a way that they try to find the best possible suit of action on the basis of the reward and punishment theory. So you can see in the example, the agent tries to learn from the environment, observes the environment, select action using policy, and it gets a reward or penalty according to its suitable action. So whenever it gets the reward or penalty, it tries to learn the right suitable action according to the environment. Now let's see the next question. So differentiate between classification and regression in machine learning. So in machine learning, there are various types of prediction problems based on supervised and unsupervised learning. There are classification, regression, clustering, and association problems. So here we'll discuss about classification and regression. So in classification, we try to create a machine learning model that assists us in differentiating data into separate categories. So the data is labeled and categorized based on the input parameters. For example, imagine that if we want to make predictions on the churning out of customers for a particular product based on some data recorded. So either the customer will churn out or they'll not. So the labels for this would be yes and no. So this lies under classification problem. Now the next is regression. So it is the process of creating a model for distinguishing data into continuous real values instead of using classes or discrete values. It can also identify the distribution movement depending on the historical data. So it is used for predicting the occurrence of an event depending on the degree of association of variables. For example, the prediction of weather condition depends on factors such as temperature, air pressure, solar radiation, elevation of the area, and distance from the sea. So the relation between these factors assist us in predicting the weather condition. So this was about classification and regression. So the next question is, what is linear regression? So linear regression is a supervised machine learning algorithm. It is used to find the linear relationship between the dependent and the independent variables for a predictive analysis. So you can see the equation over here, that is y equal to a plus bx, where x is the input or the independent variable, y is the output or the dependent variable, and a is the intercept and b is the coefficient of x. So let us see the graph for it. So this is the graph where it is having a best fit line that shows the data of weight, that is y or the dependent variable, and height, that is the independent variable, of 21 years old candidates scattered over the plot. So this straight line shows the best linear relationship that would help in predicting the weight of the candidates according to their height. So to this best fit line, we'll try to find the best values of A and B, and by adjusting the values of A and B, we try to reduce errors in the prediction of Y. So this is how linear regression helps in finding the linear relationship and predicting the output. Now let's head on to the next question. The question is, how will you determine the machine learning algorithm that is suitable for your problem? So for identifying the machine learning algorithm for our problem, we should follow these steps. So first is problem classification, second is checking the algorithm, and third is implementing the algorithm. So classification of the problem depends on the classification of input and output. So for classification of input, it depends on whether we have data labeled, that is supervised learning, or unlabeled, that is unsupervised learning, or whether we have to create a model that interacts with the environment and improves itself. For classifying the output, if we want the output of our model as a class, then we need to use some classification techniques. If it gives the output as a number, then we must use regression techniques, and if the output is a different cluster of inputs, then we should use clustering techniques. Now checking the algorithms in hand, after classifying the problem, we have to look for the available algorithms that can be deployed for solving the classified problems. Finally, we'll be implementing the algorithms. If there are multiple algorithms available, then we will implement each one of them one by one, and we'll check for the accuracy. And finally, we would select the algorithms that gives the best performance. Now the next question is, what are bias and variance? So bias is the difference between the average prediction of our model and the correct value. So if the bias value is high, then the prediction of the model is not accurate. Hence the bias value should be as low as possible to make the desired prediction. And the variance is the number that gives the difference of prediction over a training set and the anticipated value of other training sets. So high variance may lead to large fluctuation in the output. Therefore, the model's output should have low variance. Let's see the diagram for it. You can see in the diagram, the desired result is the blue circle at the center. And if we get off from the blue section, then the prediction goes wrong. So the model should have low bias and low variance. And if the model is having low bias, high variance, then very few of the points are lying close to the desired result. And if the model is having high bias and high variance, then the points are not lying close to the desired result. So the model should have low bias and low variance. Now the next question is, what is variance inflation factor? So the VIF is the estimate of the volume of multicollinearity in a collection of many regression variables. So it is calculated as variance of the model divided by variance of the model with a single independent variable. So the VIF quantifies the extent of correlation between one predictor and the other predictor in a model. It is used for diagnosing collinearity and multicollinearity. So higher value signifies that it is difficult and impossible to access accurately the contribution of predictors to a model. Now let's head on to the next question. So we have to explain false negative, false positive, true negative, and true positive. So let's start with true positive. When the machine learning model correctly predicts the condition, it is said to have a true positive value. Then true negative, when the machine learning model correctly predicts the negative condition or class, it is said to have a true negative value. Next is false positive. So when the machine learning model incorrectly predicts a negative class or condition, it is said to have a false positive value. Finally, when the machine learning model incorrectly predicts a positive class or condition, it is said to have a false negative value. Let's understand this with the help of an example. So if an alarm goes on in case of a fire, it is true positive in the sense that there is a fire. That is, the fire is positive and the prediction made by the system is true. Next is, if the alarm goes on and there is no fire, then system predicted fire to be positive, but it made a wrong prediction, hence the prediction is false and the condition is false positive. Next is, if the alarm does not go on but there was a fire, system predicts fire to be negative, which was false since there was a fire. So it is a false negative condition. Finally, if the alarm does not go on and there was no fire, the fire is negative and this prediction was true. So the condition is true negative. Now let's head on to the next question. So what is a confusion matrix? So confusion matrix is used to explain a model's performance and gives the summary of the prediction on the classification problems. So it assists us in identifying the uncertainty between classes. So this is the formula for calculating the accuracy from a confusion matrix. So it consists of true positive, true negative, false positive, and false negative values. So the accuracy is calculated as the sum of the true positive and true negative values divided by all the outcomes. So the accuracy is calculated as the sum of true positive and true negative values divided by true positive, true negative, false positive, and false negative. For example, consider this confusion matrix, and it consists of values as true positive, true negative, false positive, and false negative for a classification model. Now the accuracy of the model can be calculated as below. So it is the sum of true positive and true negative value divided by the sum of true positive, false negative, true negative, and false positive values. So the accuracy comes to be 0.78. So the accuracy of the model is 78%. Now let's head on to the next question. So what do we understand by type 1 and type 2 error? So type 1 error is also called as false positive, and it is an error where the outcome of a test shows the non-acceptance of a true condition. For example, a cricket match is going on, and when a batsman is not out and the umpire declares that he is out, this is a false positive condition. So here the test does not accept the true condition that the batsman is not out. Now type 2 error. So type 2 error is also called as false negative, and it is an error where the outcome of a test shows the acceptance of a false condition. For example, the CT scan of a person shows that he is not having a disease, but in reality he is having it. Here the test accepts the false condition that the person is not having the disease. So when should you use classification over regression? So both classification and regression are associated with prediction. So classification involves the identification of values that lie in a specific group, whereas the regression method entails a predicting a response from a consecutive set of outcomes. So the classification method is chosen over regression when the output of the model needs to yield the belongingness of the data points in a dataset to a particular category. For example, we have some names of bikes and cars. We would not be interested in finding how these names are correlated to bikes and cars. We would check whether each name belongs to the bike category or the car category. So that is why we use classification over regression. Now let's head on to the next question. So we have to explain logistic regression. So logistic regression is the proper regression analysis used when the dependent variable is categorical. Like all the regression analysis, logistic regression is a technique for predictive analysis. It gives the output as binary. So logistic regression is used to explain the data and the relationship between one dependent binary variable and the one or more independent variables. Also, it is employed to predict the probability of a categorical dependent variable. For example, if we have to predict whether a citizen is a senior or not, so the output will be in 0 or 1. So there are three types of logistic regression, that is binary logistic regression. So in this, there are only two outcomes possible. For example, to predict whether it will rain or not, it will give the values as 1 or 0. The next is multinomial logistic regression. So in this type of regression, the output consists of three or more unordered categories. For example, prediction on the regional languages like Marathi, Telugu. The next is ordinal logistic regression. So in ordinal logistic regression, the output consists of three or more ordered categories. So rating an Android application from 1 to 5 star, it comes in ordinal logistic regression. Now the next question is, imagine you are given a data set consisting of variables having more than 30% missing values. Let's say out of 50 variables, 8 variables have missing values which is higher than 30%. So how will you deal with them? So to deal with the missing values, we need to first identify the values, and for that, we'll specify a different class for the missing values. After that, we'll check the distribution of values over the data set, and we would hold those missing values that are defining a pattern. Finally, we'll change these into yet another class while eliminating the others with the help of eliminating functions available in Python or R. Now, the next question is, how do we handle the missing or corrupted data in a data set? So in Python, there are two methods that are very useful. So we can use these two methods to locate the lost or corrupted data and discard those values. So the first is null method. So we can detect the missing values using isNull method. And after that, we can use drop NA for removing the columns and rows with null values. Also, we can use fill NA to fill the void values with a placeholder value. Now, let's head on to the next question. So we have to explain principal component analysis. Firstly, this is one of the most important machine learning interview question. So in the real world, we deal with multi-dimensional data. Thus, the data visualization and computation becomes more challenging with the increase in dimensions. So in such a scenario, we might have to reduce the dimension to analyze and visualize the data easily. So we do this by removing the irrelevant dimensions, keeping only the most relevant dimensions. So this is where we use principal component analysis. So finding a fresh collection of uncorrelated dimensions and ranking them on the basis of variance are the goals of PCA. So here is the mechanism of PCA. So we have to compute the covariance matrix for data objects. Then we have to compute the eigenvectors and eigenvalues in a descending order. Next is to get the new dimensions and select the initial n eigenvectors. Finally, we'll change the initial n-dimensional data objects onto n dimensions. So here is an example for it. Here, the two graphs shows the data points and the two directions. One is green and the other is yellow. So we got the graph 2 by rotating the graph 1 so that the x-axis and y-axis represent the green and the yellow directions. So after the rotation of the data points, we can infer that the green direction gives us the line that best fits the data points. So here we are representing two-dimensional data, but in real life, the data would be multi-dimensional and complex. So after recognizing the importance of each direction, we can reduce the area of dimensional analysis by cutting off the less significant directions. Now we'll look into another important machine learning interview question. So why rotation is required in PCA? So what will happen if you don't rotate the components? So rotation is a significant step in PCA as it maximizes the separation between the variance obtained by the components. Due to this, the interpretation of the components become easier. So the motive behind doing PCA is to choose fewer components that can explain the greatest variance in a data set. So when rotation is performed, the original coordinates of the points gets changed. So there is no change in the relative position of the components. So if the components are not rotated, then we need more extended components to describe the variance. Then the visualization and prediction becomes more difficult. So you can see over this graph, the data points, these blue dots represents the data points. And if we rotate the axis to these dimensions, then all the points will lie in this x-axis. So the previous one is x-axis and the new dimension is x-axis where all the data points lies. Now let's head on to the next question. So we know that one hot encoding increases the dimensionality of a data set, but label encoding doesn't. So how? So when we use one hot encoding, there is an increase in the dimensionality of a data set. So the reason for the increase in dimensionality is that for every class in the categorical variable, it forms a different variable. Suppose there is a variable called color. It has three sub-levels as yellow, purple, and orange. You can see over here. So one hot encoding color will create three different variable as color.yellow, color.purple, and color.orange. Now in label hot encoding, the subclasses of the certain variables get the values as 0 and 1. So we use label encoding only for binary variables. So this is the reason that one hot encoding increases the dimensionality of data and label encoding doesn't. So you can see over here that in this label encoding, the categorical variables or categorical values are given to the name of the food, and in one hot encoding, the 0 and 1 values are given and the separate variables will be created for it. So it increases the complexity of the data. Now let's head on to the next question. How can you avoid overfitting? So overfitting happens when a machine has an inadequate data set and it tries to learn from it. So overfitting is inversely proportional to the amount of data. So for small database, we can bypass overfitting by the cross-validation method. So in this approach, we'll divide the dataset into two sections. So these two sections will comprise testing and training sets. So to train the model, we'll use the training dataset, and for testing the model, for new inputs, we'll use the testing dataset. This is how we can avoid overfitting. Now let's head on to the next question. Why do we need a validation set and a test set? So this question is similar to the previous one. So we split the data into three different categories while creating a model. The first is training set, the second is validation data set, and the third is testing data set. So let's see training data set. So we use the training set for building the model and adjusting the model's variables. But we cannot rely on the correctness of the model built on top of the training set. The model might give incorrect output on feeding new data. So we use validation set. So we use a validation set to look into the model's response on top of the sample that doesn't exist in the training data set. Then we will tune hyperparameters on the basis of the estimated benchmark of the validation data. When we are evaluating the model's response using the validation set, we are indirectly training the model with the validation set. So this may lead to the overfitting of the model to the specific data. So this model won't be strong enough to give the desired response to the real world data. So for this, we use the test dataset. The test dataset is the subset of the actual dataset, which is not yet used to train the model. So the model is unaware of this dataset. By using the test dataset, we can compute the response of the created model on hidden data. So we evaluate the model's performance on the basis of test dataset. So we do not always expose the model to test dataset after tuning the hyperparameters on top of the validation set. As we know, the evaluation of the model on the basis of the validation set would not be enough. Thus, we use a test set for computing the efficiency of the model. Now, let's head on to the next question. So what is a decision tree? So a decision tree is used to explain the sequence of action that must be performed to get the desired output. So it is a hierarchical diagram that shows the actions. So you can see the diagram over here. So we can create an algorithm for a decision tree on the basis of the hierarchy of actions that we have set. So over here, you can see we are checking whether a person is fit or not. So the parameters are, the first one is, we'll check whether the person's age is greater than or less than 30. So if it is yes, then we check for eats a lot of pizzas. So if this condition is true, then the person is unfit. And similarly for this, if the person is greater than 30, it checks for exercises in the morning. And if it is yes, the person is fit. So this is the working mechanism of a decision tree. So let's head on to the next question. So we have to explain the difference between KNN and K-means clustering. So K nearest neighbor or KNN, it is a supervised machine learning algorithm and in KNN we give the identified or labeled data to the model. Then the model matches the points based on the distance from the closest point. So you can see over here, these are the matched points according to the centers. And for k-means clustering, it is an unsupervised machine learning algorithm. So in this, we give the unidentified or unlabeled data to the model. Then the algorithm tries to create the batches of points based on the average of the distances between the distinct points. So you can see over here, these clusters are formed. So this is the difference between KNN and k-means clustering. Now the next question is, what is dimensionality reduction? So in the real world, we build machine learning models on top of features and parameters. So these features can be multidimensional and large in number. Sometimes the features may be irrelevant and it becomes a difficult task to visualize them. So here we use the dimensionality reduction to cut down the irrelevant and redundant features with the help of principal variables. So these principal variables are the subgroup of the parent variable, and it conserves the feature of the parent variable. Now let's move on to the next question. Both being tree-based algorithms, how is random forest different from gradient boosting algorithm? So the main difference between a random forest and GBM is the use of techniques. They both use different techniques for implementing. So random forest advances prediction using a technique called bagging, and GBM uses boosting to advance the predictions. So let's check each one of them. So in bagging, we apply arbitrary sampling and we divide the data set into n samples. After that, we build the model by employing a single training algorithm. Further, we combine the final predictions by pooling. So bagging helps to increase the efficiency of the model by decreasing the variance for overfitting. Now let's see boosting. So in boosting, the algorithm try to review and correct the inadmissible predictions at the initial iteration. After that, the algorithm's sequence of iteration for correction continues until we get the desired prediction. So boosting assists in reducing bias and variance both for making the weak learners as strong learners. Now let's move on to the next question. Suppose you found that your model is suffering from high variance. So which algorithm do you think you could handle this situation and why? So for handling the issues of high variance, we should use bagging algorithm. So what it does is it splits the data into subgroups with replicated sampling of random data. And when the data is splitted into subgroups, we create rules using particular training algorithms. And finally, we use pooling for combining the predictions of the model. So you can see the diagram. The data is divided into subgroups as bootstrap 1, 2 till n, and the models are created as model 1, 2 according to the training algorithms, and finally they vote for the final prediction. Now the next question is, what is ROC curve and what does it represent? So ROC stands for receiver operating characteristic. So we use ROC curve to represent the trade-off between true and false positive rates. So in ROC, the area under curve gives us an idea about the accuracy of the model. So you can see the graph. So this graph shows an ROC curve. So the greater the area under the curve, better the performance of the model. So let's move on to the next question. So what is rescaling of data and how is it done? So in real world scenarios, the attributes present in the data will be in a varying pattern. So rescaling of the characteristic to a common scale gives benefit to algorithms to process the data efficiently. For example, if a student is gaining marks out of 100 as 60 in subject 1, out of 150, 120 in subject 2, and 180 out of 200 in subject 3. So after rescaling, the marks will be out of 10. So in subject 1, he'll get 6 out of 10. In subject 2, he'll get 8 out of 10. And in subject 3, he'll get 9 out of 10. So this is how rescaling gives us the benefit to rescale the data in a common scale. Now let's move on to the next question. So what is binarizing of data? So in most of the machine learning interviews, so this question is asked. So I'll give you an example. So first of all, converting data into binary values on the basis of threshold values is known as the binarizing of data. So the values that are less than the threshold are set to 0, and the values that are greater than the threshold are set to 1. So this process is useful when we have to perform feature engineering, and we can also use it for adding unique features. So here, if a student A in subject 1 gets 60 out of 100, in subject 2 he gets 20 out of 100, and in subject 3 he gets 70 out of 100. So if the threshold is set to 40, so if the marks are greater than 40, then the student is passed, or if it is less than 40, then the student is failed. So after binarizing, we'll get the output as 1 and 0, from which we can decide whether the student is failed or not. Now let's move on to the next question. So how to standardize data? So standardization is the method that is used for rescaling data attributes, and the attributes would likely to have a value of mean as 0 and the value of standard deviation as 1. So the main objective of standardization is to prompt the mean and standard deviation for the attributes. So we'll implement standardization using Python. So let's move on to our Jupyter notebook. So this is our Python code for standardization. So we have imported the NumPy library and matplotlib.pyplot and pandas. So we'll be using the pre-processing in Python. So we'll be importing it from sklearn package. So basically, pre-processing is used. It is a package that provides several common utility functions and transformer classes to change raw feature vectors into a representation, and that will be more suitable for downstream estimators. So in general, learning algorithm benefit from the standardization of the data set. So this is the use of pre-processing. Then we'll load the data set. So I have loaded the data set using pd.readcsv. After that, we'll have a look at the original data. So the original data is over here. So it denotes the scientific values. So we have to do min-max scaling, or it is called rescaling of the data. So for this, we'll use min-max scaler. So we'll be storing it in min_max_scaler. So pre-processing dot min-max scaler, and the range of the feature will be from 0 to 1. So values will be stuck in between 0 and 1. After that, we'll use this fit_transform to fit the value of the data and transform it into a format. So let's have a look at the values after min-max scaling. So you can see the values are between 0 and 1. So these are rescaled. Now we'll look at standardization. So we'll use standardization, and we'll use this object of standardization and store this standard scaler in it so that we can use it afterward in standardization. After that, for scaled feature, we'll use this object as x_ after standardization to store the values that are standardized. So after printing the values after standardization, the output would look like this. So the negative values are the values that are less than mean, and the values which are positive are greater than the mean. Now let's move on to the next question. So executing a binary classification tree algorithm is a simple task, but how does a tree splitting takes place? How does tree determine which variable to break at the root node and which at its child nodes. So Gini index and node entropy assist the binary classification tree to take decisions. So basically the tree algorithm determines the feasible feature that is used to distribute the data into the most genuine child nodes. And according to Gini index, if we arbitrarily pick a pair of objects from a group, then they should be of identical class and the possibility for this event should be 1. So to compute the Gini index, we should do the following. So we should compute the Gini for subnodes with the formula as the sum of the square of the probability for the success and failure. So that is p square plus q square. Then we have to compute Gini for split by weighted Gini rate of every node of the split. Now we'll see entropy. So entropy is the degree of indency that is given by the following. So this is the formula for entropy, where A and B are the possibilities of success and failure of the node. So when entropy is equal to 0, the node is homogeneous. And when the entropy is high, both groups are present at 50-50% in the node. Finally, to determine the suitability of the node as the root node, the entropy should be very low. Now let's move on to the next question. So what is support vector machines? So support vector machine is a machine learning algorithm that is majorly used for classification. So it is used on top of the high dimensionality of the characteristic vector. So we'll implement SVM using Python. So let's move on to our Jupyter notebook. So I've written this code. So first we'll import data sets from the sklearn package, then confusion matrix, as we will be calculating the accuracy of the model, and train test split from sklearn.model selection, because we'll be splitting the data set into train and test set. So we'll use the iris data set for this. So I'll load the data set and I'll store it in iris.data and iris.target. Then we'll be splitting the data set into train and test set. So we have separated the data into data and target and stored it in A and B. So we'll be creating separate test and train data set for it. So we'll be using train test split function for this, and we'll give the argument as A, B, and random state will be 0. After that, we'll import SVC from sklearn.svm to implement the model. So we'll build the SVM linear model by using the SVC function and store it in svm underscore model underscore linear, where kernel will be linear and will give the data as train data set. After that, we'll predict the model's outcome using the predict function and give the argument as test. Finally, to calculate the accuracy, we'll be using the score function. So we'll be using this svm model linear dot score and give the argument as a underscore test and b underscore test. So after that, we'll get the confusion matrix. So we'll be using the confusion matrix function. So this will be our output. So this is our output that we get, and using this confusion matrix, we can calculate the accuracy of the model. Now let's move on to the last question of this machine learning interview questions tutorial. So we have to implement KNN classification algorithm. So the problem statement is classify the iris flower based on sepal and petal length and widths using KNN. So we already know that it is a supervised machine learning algorithm, and in it we give the identified or labeled data to the models, and then the model matches the points based on the distance from the closest point. So let's move on to our Jupyter notebook for implementing this. So this is our code for implementing the KNN classification algorithm. So we'll load the iris dataset from sklearn.datasets. Then we'll be importing k-neighbors classifier, which will help us in implementing the KNN classification algorithm. We'll import NumPy and then train test split so that we can split the dataset into train and test dataset. Then we'll load the iris dataset and store it in iris underscore dataset. After that, we'll be splitting the dataset into train and test using the function of train underscore test underscore split. After that, we'll use k neighbors classifier and we'll store it in kn object. Then we'll fit the model on top of training dataset, that is a underscore train and b underscore train. After that, we'll be creating a new array and store the values of the characteristics of the flower in a underscore new. Then for predicting, we'll use this predict function to predict the outcome using the a underscore new dataset. After that, we'll be printing the predicted target value, predicted feature name, and the test score, which will give us the accuracy of the model. So the model has predicted that the feature name is Satosa and the test score is 0.97. That means the accuracy of the model is 97%.
Hey guys, quick info. If you're looking for an end-to-end machine learning training program, then do check out Intellipaat's machine learning course. Now let's continue with the session. So this brings us to the end of the video. I hope you guys found this video informative. If you have any queries, then leave a comment and we'll get back to you at the earliest. Thank you for watching.